Hello everyone, I am Mayank and welcome to this amazing video on Cloud Experts course by Simplilearn. In this video, we will clear your doubt regarding the best roles, salaries and certification you can choose to advance your career in cloud computing. But before we begin, if you enjoyed these type of videos and find them interesting, then subscribe to our YouTube channel as we bring you the best video daily. Also hit the bell icon to never miss any update from Simplilearn. So let's get started. In this video, first you will learn about what cloud computing is and the types of cloud computing. Following that, you will come across the fundamentals of cloud computing like cloud computing roadmap, cloud computing certification, how to become cloud computing expert, and cloud computing job roles. Then you will be introduced to various cloud computing services providing platforms like AWS, Azure, and GCP. First, you will learn about AWS and its various interesting services. Following that, you will learn about Azure and how it differs from AWS. Then you will learn about GCP and its provided services and how it competes with other two leading cloud computing platforms, AWS and Azure. In the end, you will see top 30 cloud computing interview questions that will help you build your career in cloud computing and see you can proceed to become a cloud computing engineer, which will cover all the relatable data like eligibility criteria, qualifications and skills required for you to proceed in this path. By this end of this video, I can assure you that all your cloud computing related questions and doubts have been cleared. And whether you are a fresher or an IT expert with some experience, you can improve your skills in cloud computing by getting the proper training and certification. On that note, we present the postgraduate program in cloud computing by Simplilearn. The postgraduate program in cloud computing designed in collaboration with Caltech CTME helps you become an Azure, AWS and GCP expert. This in-depth cloud computing certification course lets you master key architecture principles and develop the skills needed to become a cloud computing expert. Benefits of this postgraduate program include Caltech CTMA postgraduate certificate, enrollment in Simplilearn Job Assist, receive up to 30 CEUs from Caltech CTMA. Simplilearn Job Assist help you to get noticed by top hiring companies, attend masterclasses from Caltech CTMA, live virtual classes led by industry experts, hands-on project and integrated labs. Online convocation by Caltech CTMA program director, 40 plus hands-on experience projects and integrated labs, caption projects in 4 domains, Caltech CTMA circle membership. You can also fast-track your career with this cloud computing certification and its in-depth course curriculum, which covers the key concept of Azure, AWS and GCP platform and services such as AWS Lambda, Amazon S3, Azure App Services and many more. These programs also cover the essential skills to become an expert in cloud computing, and you can consider these programs because it provides you with the certification from Caltech CTME, a well-reputed university in United States. So check out the link mentioned in the description box below. So without any further ado, let's get started.
What is cloud computing? As we learn what is cloud computing, we will also be learning about how things were before cloud computing and benefits of cloud computing, different types of cloud computing available, and some of the famous companies that are using cloud computing and they're getting benefited out of it. We're going to learn all that. Before cloud computing existed, if we need any IT servers or application, let's say a basic web server, it does not come easy. Now here is an owner of a business, and I know you would have guessed it already that he's running a successful business by looking at the hot and fresh brewed coffee in his desk and lots of paperwork to review and approve. Now he had a smart, not only smart looking, but a really smart worker in his office called Mark. And on one fine day, he called Mark and said that he would like to do business online. In other words, he would like to take his business online, and for that he needed his own website as the first thing. And Mark puts all his knowledge together and comes up with this requirement that his boss would need lots of servers, database and softwares to get his business online, which means a lot of investment. And Mark also adds that his boss will need to invest on acquiring technical expertise to manage the hardware and software that they will be purchasing and also to monitor the infrastructure. And after hearing all this, his boss was close to dropping his plan to go online. But before he made a decision, he chose to check if there are any alternatives where he don't have to spend a lot of money and don't have to spend acquiring technical expertise. Now that's when Mark opened this discussion with his boss, and he explained his boss about cloud computing, and he explained his boss the same thing that I'm going to explain to you in some time now about what is cloud computing. what is cloud computing? Cloud computing is the use of a network of remote servers hosted on the internet to store, manage, and process data rather than having all that locally and using local server for that. Cloud computing is also storing our data in the internet from anywhere and accessing our data from anywhere throughout the internet. And the companies that offer those services are called cloud providers. Cloud computing is also being able to deploy and manage our applications, services, and network throughout the globe and manage them through the web management or configuration portal. In other words, cloud computing service providers give us the ability to manage our applications and services through a global network or internet. Example of such providers are Amazon Web Service and Microsoft Azure. Now that we have known what cloud computing is, let's talk about the benefits of cloud computing. Now I need to tell you, the cloud benefits is what is driving cloud adoption like anything in the recent days. If I want an IT resource or a service now with cloud, it's available for me almost instantaneously and it's ready for production almost the same time. Now this reduces the go live date and the product and the service hit the market almost instantaneously compared to the legacy environment, and because of this the companies have started to generate revenue almost the next day, if not the same day. Planning and buying the right size hardware has always been a challenge in legacy environment, and if you're not careful when doing this, we might need to live with a hardware that's undersized for the rest of our lives. With cloud, we do not buy any hardware, but we use the hardware and pay for the time we use it. If that hardware does not fit our requirement, release it and start using a better configuration and pay only for the time you use that new and better configuration. In legacy environments, forecasting demand is an full-time job, but with cloud, you can let the monitoring and automation tool to work for you and to rapidly scale up and down the resources based on the need of that hour. Not only that, the resources, services, data can be accessed from anywhere as long as we are connected to the internet. And even there are tools and techniques now available which will let you to work offline and will sync whenever the internet is available. Making sure the data is stored in durable storage and in a secure fashion is the talk of the business, and cloud answers that million-dollar question. With cloud, the data can be stored in a highly durable storage and replicated to multiple regions if you want, and the data that we store is encrypted and secured in a fashion that's beyond what we can imagine in local data centers. Now let's bleed into the discussion about the types of cloud computing. Very lately, there are multiple ways to categorize cloud computing because it's ever growing. Now we have more categories. Out of all these 6 sort of stand out, categorizing cloud based on deployments and categorizing cloud based on services. And again, under deployments, categorizing them based on how they have been implemented. Is it private, is it public, or is it hybrid? And again, categorizing them based on the service it provides. Is it infrastructure as a service, or is it platform as a service, or is it software as a service? Let's look at them one by one. Let's talk about the different types of cloud based on the deployment models first. In public cloud, everything is stored and accessed in and through the internet, and any internet users with proper permissions can be given access to some of the applications and resources. And in public cloud, we literally own nothing, be it the hardware or software. Everything is managed by the provider. AWS, Azure, and Google are some examples of public cloud. Private cloud, on the other hand, with private cloud, the infrastructure is exclusively for a single organization. The organizations can choose to run their own cloud locally or choose to outsource it to a public cloud provider as managed services. And when this is done, the service, the infrastructure will be maintained on a private network. Some examples are VMware Cloud, and some of the AWS products are very good example for private cloud. Hybrid cloud has taken things to the whole new level. With hybrid cloud, we get the benefit of both public and private cloud. Organizations will choose to keep some of their applications locally, and some of the application will be present in the cloud. One good example is NASA. It uses hybrid cloud. It uses private cloud to store sensitive data and uses public cloud to store and share data which are not sensitive or confidential. Let's now discuss about cloud based on service model. The first and the broader category is infrastructure as a service. Here we would rent the service, network, storage, and we'll pay for them in an hourly basis. But we will have access to the resources we provision, and for some we will have root level access as well. EC2 in AWS is a very good example. It's a VM for which we have root level access to the OS and admin access to the hardware. The next type of service model would be platform as a service. Now in this model, the providers will give me a pre-built platform where we can deploy our codes and our applications, and they will be up and running. We only need to manage the codes and not the infrastructure. Here in software as a service, the cloud providers sell the end product, which is a software or an application, and we directly buy the software on an subscription basis. It's not the infra or the platform, but the end product or the software or a functioning application, and we pay for the hours we use the software. And in here, the client maintains full control of the software and does not maintain any equipment. Amazon and Azure also sell products that are software as service. This chart sort of explains the difference between the four models, starting from on-premises to infrastructure as a service to platform as a service to software as a service. This is self-explanatory that the resources managed by us are huge in on-premises, that towards your left as you watch, and it's little less in infrastructure as a service as we move further towards the right, and further reduced in platform as a service, and there's really nothing to manage when it comes to software as a service because we buy the software, not any infrastructure component attached to it. There are lots of famous well-known organizations around the world. They have moved or have migrated to the cloud environment. Pinterest is one company which is one of the world's largest visual bookmarking tool with more than 70 million monthly active users. Now Pinterest was able to scale its business because it was all built on Amazon Web Services. With a company with less number of employees, Pinterest decided that they do not want a dedicated staff time to manage a data center. Instead, Pinterest uses AWS, or they used AWS to manage their high performance social application and store more than 8 billion objects and 400 terabytes of data in AWS cloud using a service called Amazon Simple Storage Service, or in short Amazon S3. And not only that, they are running 225,000 instance hours a month, and they run that on Amazon compute service called Amazon EC2 or Amazon Elastic Compute Cloud. Spotify is another company that got benefited using AWS. It's an online music service offering, and it offers instant access to over 16 million licensed songs. Spotify needed a peculiar requirement. It needed a storage solution that could scale very quickly without incurring long lead times for upgrades. Long story short, Spotify used Amazon S3, which is Amazon Simple Storage Service, and Amazon S3 gave them the confidence in their ability and to expand their storage quickly while also providing high data durability. The third biggest company I want to mention is Netflix. It's the world's largest internet television network with more than 100 million members in more than 190 countries. Netflix uses Amazon Web Services for nearly all its computing and storage needs. Now that includes database, analytic, recommendation engines, video transcoding, and a lot more. Not only that, this company is planning to use AWS Lambda to build an automated or an rule-based self-managing infrastructure and replace some of their inefficient process to reduce the rate of errors, and replace inefficient processes to reduce the rate of errors and save their valuable time. Expedia is another famous company that got benefited by using cloud. Expedia provides travel booking service through its flagship site called Expedia.com, and not only that, they also run 200 plus travel booking sites around the world. Expedia is all on AWS, and by using AWS, Expedia has become more resilient with an high scalable infrastructure and better cloud services because it had offloaded the IT management to the cloud provider itself, in this case AWS. And because of this, Expedia's developers have been able to innovate faster while saving the company millions and millions of dollars. We can categorize the different types of cloud computing based on two wide categories, one being a deployment model and the other one being service model. Let's talk about the deployment model first. Deployment model is categorized into three types. First one is public, and then private, and then hybrid cloud. In other words, public cloud, private cloud, and hybrid cloud. It'll be easy for me to explain, and also it'll be easy for you to understand if I walk you through this example. Consider the different types of vehicles we use to commute from one place to another. For example, if I want to travel, I can pick a bus which is accessible to anyone. I get in and I pay for the seat that I occupy, and I pay for the time that I will be traveling in it, and I'm done. Cost is very less here. A similar kind of thing happens in the public cloud. I pay only for the resource that I use, and I pay for how long I use it. If I use less, I pay less. If I use more, I pay more for that month. Simple. On the other hand, private cloud is like buying your own car and using it for commuting purpose. Here, I pay a huge amount upfront, and it is all owned only by me. I do not pay for it in an hourly fashion, but completely and all upfront. The cost here is very huge. And thirdly, if I want the best of both types, like the comfort of the own car and still don't want to pay all upfront, otherwise want only to pay for the time that I use the service, I can rent a car. Similarly, I can have it in a hybrid environment, meaning if I already have a DC, I can integrate it with the cloud and use both the DCs, and that would become an hybrid environment. Alright, so that was good of an learning. Let's summarize the types of cloud based on deployment models. And as we know now about the public cloud is an cloud infrastructure that's made available to the general public over the internet, and it is owned by the cloud provider. Some of the major players as cloud providers are AWS, Microsoft Azure, IBM's Blue Cloud, and Sun Cloud. And private cloud? Now this cloud infrastructure is exclusively operated by a single organization. It can be managed by organizations or third party and may exist on premises or off premises, doesn't matter, but the point here is this is exclusively operated for a single organization. And some companies that provide private cloud are AWS and VMware. And hybrid cloud gives the best of both public and the private cloud. For example, the federal agencies, they opt for private clouds for storing and developing personal data, and they use public cloud to share the non-sensitive data with the general public or with other government departments. Now let's talk about different clouds based on the service model. If we need to categorize them broadly, we can categorize them as infrastructure as a service, IaaS, or platform as a service, PaaS, or software as a service, SaaS. They sometimes are referred to as IaaS, PaaS, and SaaS. Now at this moment you could be like this guy thinking, Sam, I thought you're done categorizing the cloud. Now you're going to talk about 3 more categories? Which one should I pick? Well, let me explain. If all that you want is just a VM and you have all the expertise to install the software on top of it and make it work, then go for IaaS. If you only want a platform or an interface to program or an interface to upload a program and make it run, then pick PaaS. Or if all that you want is a finished product hosted in the cloud and be able to access it through the internet, then go for SaaS. Here you get a username and password for an application, and you can begin to customize the application based on your needs. Alright, let's talk about IaaS in a bit more detail. IaaS, it gives basic computing infra. It's based on a pay for what you use model. And some of the cloud providers who are big players are AWS, Azure, and Google. And here the users generally will be IT admins. In PaaS, the provider gives you a platform or a runtime environment for developing, testing, and managing application. It's platform ready. You buy the platform, you upload your code, and you start working on it. And it allows the software developers to deploy applications without running the underlying infrastructure. And as you might have guessed by now, the interesting candidates who would use PaaS is software developers. And in SaaS, everything is managed by the vendor. vendor, be it the hardware or the software. It's managed by the vendor, and we pay for the service, and we pay for it through a pay-as-you-go subscription model. And as you might have guessed, the end users here would be end customer itself. All right, let's put together everything in the same page and compare and contrast the different types of service models. In this chart, it explains the difference between the four models, starting from on-premises to IaaS and then PaaS and SaaS. It is self-explanatory that the resources managed by us are huge in on-premises and little less in IaaS, and further less or reduced in PaaS, and nothing to manage when it comes to SaaS. Let me also explain the different types of cloud services through an example like this. Let's say that you have a crush on cake and you're planning to bake one yourself. Now let's look at the options you can have. You can make all the ingredients yourself, be it the flour, butter, and put together and bake the whole thing yourself using your own oven, pan, the needed water, and the rest. You get an idea, right? Everything is yours, and that's on premises. All that you use is owned by you, and nothing is managed by the vendor. The other options you can have is buy the ingredients and mix and bake the cake yourself. Now this would be like IaaS. Here the infra is managed by the provider and we get to use it and customize it the way we want it. Here the cloud service is a shared responsibility. The other options you still have on hand is simply pick a phone and order a cake. Now this is a lot simpler than the rest we discussed so far. It's simply picking the phone and ordering the cake and pay for it when it arrives. Simple. And when it reaches home, you will have to arrange the table, garnish the cake if that's needed, and then enjoy the cake. It's the same way with PaaS. Just get the platform in which you would run your code and upload your code and start running your application. Here you and the vendor still share the responsibility. You still have one more option left, that is simply go out and dine. This is a lot simpler, that it requires no effort from us at all. You buy the fully finished and garnished cake and pay for it and walk out. No responsibility on making the cake. It's the same way with SaaS. We buy the finished product and pay for the finished application.
Snapchat reports that more than 5 billion snaps are generated daily and more than 100 billion messages are sent on WhatsApp daily. Do you ever wonder if storing this data in local storage is possible? The answer is clearly no. According to the projections, by 2025, over 100 zettabytes of data will be stored in the cloud storage. 1 zettabyte is equal to trillion gigabytes. Now imagine the amount of data the world generates and how it is being managed. So cloud experts are responsible for this smooth transition. Google Workspace has already surpassed the mark of 2 billion users in 2020, and 60% of the total corporate data is already present in the cloud. So these stats are enough to let anyone know where this technology is headed and what wonders are awaiting in cloud computing. Tech giants like Google, Amazon, and Microsoft are trying to conquer this exponentially growing market with their products like Amazon Web Services, Google Cloud Platform, and Microsoft Azure. Furthermore, in this fast-paced world, a job in this field is more than worth it. The salaries offered in this field are very lucrative and fascinating. Among all the job roles currently available in cloud computing, a cloud architect in India earns an average salary of 20 lakhs per annum, and in the United States, it goes around $125,000. So these figures are stated by Glassdoor.com and show how beneficial it is to bag a job in this sector today. But the fact is, nothing comes easy. So we at Simplilearn will save some of your time and let you know about the process of how to become a cloud expert in 2023. We'll take you through the complete cloud computing roadmap. But before we begin, if you enjoy watching these videos and find them interesting, please subscribe to our channel because we bring the best videos for you daily. Also, hit the bell icon to get notified whenever we drop a new video. So without any further delay, let's go through the agenda for today's video.
This video will provide all the vital information about cloud computing. We'll start this video with an introduction to cloud computing. Following that, we'll take you through the skills to become a successful cloud expert. We'll then take you through the steps you can take to become a cloud engineer. And finally, we'll explore some of the potential roles and growth opportunities in the field of cloud computing. So let's start this video with what is cloud computing. Cloud computing in simple terms refers to the practice of using remote servers on the internet to store, manage, and process data instead of relying on your local computer. It allows you to access your files, applications, and services from anywhere with an active internet connection, providing convenience, scalability, and flexibility for individuals and businesses alike. A number of skills are required to become a master in the field of cloud computing. The first one is technical skills. Cloud engineers should have a strong foundation in areas such as networking, operating systems, and programming languages. They should be familiar with cloud platforms like Amazon Web Services, Microsoft Azure, or Google Cloud Platform. Problem-solving abilities. Cloud engineers often encounter complex technical challenges. Developing strong problem-solving and troubleshooting skills is crucial to identify and resolve issues efficiently. Security and compliance knowledge. Cloud engineers must understand security practices, data privacy regulations, and compliance standards. They need to protect sensitive data and maintain compliance with industry regulations. Continuous learning. Cloud technology evolves rapidly, so it's essential for cloud engineers to have a thirst for learning. Keeping up with the latest trends, attending training programs, and obtaining relevant certifications will help you stay ahead. Now that we have a grasp of the skills required, let's discuss the steps you can take to become a cloud engineer. Get familiar with cloud concepts. Start by gaining a basic understanding of cloud computing concepts. Familiarize yourself with the advantages, different service models such as infrastructure as a service, platform as a service, and software as a service, and deployment models like public, private, and hybrid. Second is learn cloud platforms and technologies. Choose a cloud platform to specialize in, such as AWS, Azure, or GCP. Explore their documentation, online tutorials, and resources to understand their offerings, services, and tools. Gain hands-on experience by experimenting with the platforms and building simple projects. Acquiring relevant certifications. Cloud certifications validate your skills and demonstrate your expertise to potential employers. Consider pursuing certifications such as AWS Certified Cloud Practitioner, Azure Fundamentals, or Google Cloud Certified Associate Cloud Engineer. These certifications provide a solid foundation and enhance your credibility. And Simplilearn has got your back as always. The postgraduate program in cloud computing, designed in collaboration with Caltech CTME, helps you become an Azure, AWS, and GCP expert at once. This in-depth cloud computing certification course lets you master key architectural principles and develop the skills needed to become a complete cloud expert. Benefits of this postgraduate program include Caltech CTME postgraduate certificate, enrollment in Simplilearn's Job Assist. You will receive up to 30 CEUs from Caltech CTME. Simplilearn's Job Assist help you get noticed by top hiring companies. You can also attend master classes from Caltech CTME instructors and live virtual classes led by industry experts. You will also get hands-on projects and integrated labs. There are many more other features of this postgraduate program. So you can also fast-track your career with this cloud computing certification and its in-depth course curriculum, which covers the key concept of Azure, AWS, and GCP platforms and services such as AWS Lambda, Amazon S3, Azure App Services, and many more. So this program also covers the essential skills to become an expert in cloud computing, and you can consider this program because it provides you with a certification from Caltech CTME, a well-reputed university in the United States. So what are you thinking? You can find the link mentioned in the description box below. The next step is gain practical experience. Practical experience is crucial in the field of cloud engineering. Look for opportunities to work on real-world projects through internships, freelance work, or personal projects. This hands-on experience will help you apply your knowledge and develop problem-solving skills. The last step to become a cloud expert is networking and collaboration. Connect with professionals in the cloud computing industry through networking events, online forums, and social media platforms. Engage in discussions, ask questions, and learn from their experiences. Building a solid professional network can open doors to new opportunities. As a cloud engineer, you'll have diverse career opportunities. Let's explore some of the potential roles and growth paths in cloud computing. Cloud administrator. Cloud experts or administrators oversee and manage a company's cloud infrastructure, including policies, security protocols, uptime monitoring, and technology updates. Cloud infrastructure engineer. This role focuses on designing and managing the underlying infrastructure of cloud platforms, ensuring scalability, security, and performance. Cloud Solutions Architect. Cloud Solutions Architect design and implement cloud-based solutions for organizations. They analyze business requirements and develop architectural designs to meet specific needs. Cloud Security Engineer. Cloud security engineers specializes in securing cloud infrastructures and services. They implement robust security measures, monitor for vulnerabilities, and respond to security incidents. The salaries in any of these fields are lucrative and fascinating. Congratulations! You have now learned the steps to become a cloud expert. Remember, it's a dynamic field that requires continuous learning and adaptation. So start your journey by building a solid foundation, acquiring relevant certifications, gaining practical experience, and networking with professionals.
The cloud is much more than just a reliable storage solution. The year 2021, like the year before, proved to be a watershed event for cloud computing. It gave businesses more freedom to operate in the face of COVID-19. Cloud computing, according to IT experts, will be at the forefront of all technologies used to address key businesses concerns in the coming years. Cloud computing has generated more anticipation, excitement, and investment than any other IT area in the last decade. According to IDC, the cloud will increase at a rate of 22% next year, with a market value of $277 billion. As a result, there will surely be a significant demand for cloud professionals. Therefore, a right certification in cloud computing can help you earn a handsome salary of $145,000 to $227,000 in the United States and close to 16 lakh to 24 lakh rupees in India. So let's have a look at the top 10 certification in cloud computing. The first one is AWS Certified Solutions Architect Associate. AWS Certified Solutions Architect Associate is a set of technical certifications offered by Amazon Web Services for beginners and professionals working in enterprise architecture and solutions architecture. This certificate aids in the identification and development of personnel with crucial capabilities for cloud implementation. AWS Certified Solution Architect Associate certification verifies your competence to build and deploy distributed systems on AWS. So this certification is for persons who can do solution architecture, such as deploying and securing web applications, and who have worked with AWS services for at least a year. And its difficulty level is easy. Skills required for this certification is understanding of specific programming or scripting languages like Java, Python, C#, and many other programming languages available, data storage fundamentals, networking, AWS service selection, cloud-specific patterns, and technologies. Moving on, here are a few certification details you will need to proceed with its examination. Cost of examination is $150 USD, and the average annual salary is $130,883. The duration of this examination is 130 minutes, with number of questions 65. You have multiple choice and multiple response questions, and the passing score is 70%. And the renewal time of the certification is 2 years. The companies hiring are Amazon, IBM, Capgemini, Mindtree, and Equia. These are the top companies that hire. Second is AWS Certified Cloud Practitioner. The AWS Certified Cloud Practitioner certification is a foundational level test designed for people who can successfully show an overall understanding of the AWS cloud according to Amazon. This exam verifies a candidate's understanding of essential cloud infrastructure and architectural concepts, as well as key AWS services. The certification provides an overview of AWS key services, as well as security and network. So this is the ideal cloud certification for beginners or anyone interested in learning more about cloud computing and the AWS cloud platform. So the difficulty level is easy. The skills required for this certification is oversight on creating architecture for AWS platform, ability to deploy AWS solutions and applications, building cloud solutions, developing plans for the adoption of cloud solutions, management and monitoring of cloud platforms. Moving on, here are a few certification details you will need to proceed with this examination. The cost of examination is $100. Average annual salary is $113,932. Examination duration is 90 minutes. Number of questions is 65. Types of questions are multiple choice and multiple response question. Passing score 70%. And again, the renewal time for the certification is 2 years. And the famous company hiring are Amazon, NetApp, Accenture, Deloitte, and Soliel LLC. Moving on, third is AWS Certified Developer Associate. AWS Certified Developer Associate is an Amazon Web Service examination that measures a person's ability to successfully demonstrate, deploying, and maintaining applications on the AWS platform. This is the ideal cloud certification for programmers and software developers interested in building cloud-native applications, and the difficulty level is intermediate. Skills required for this certifications are use the AWS services, APIs, CLI, and software development kits to write applications, identify key features of AWS services, understand the AWS shared responsibility model, use a continuous integration of continuous delivery pipeline to deploy application on AWS, and use and interact with AWS services. So here are the few certification details. Cost of examination is $150. Average annual salary is $130,272. Exam duration is 130 minutes. Number of questions is 65. Type of questions, multiple choice and multiple response questions. The passing score is 70%. Renewal time is 2 years. And the company hiring are Amazon, IBM, Capgemini, TCS, and Oracle. Fourth is AWS Certified System Operation Administrator Associate. The AWS Certified SysOps Administrator Associate certification is designed to demonstrate technical skills for system administrators in cloud operations jobs. This certificate assists organizations in identifying and developing personnel with crucial abilities for cloud implementation. The ability to develop, manage, and operate workloads on AWS is demonstrated by earning this certification. This associate certification is for professionals who have at least 1 year of experience with AWS deployment, management, and operations. It teaches you how to identify the right service for your needs, and the difficulty level is intermediate. So these are the skills required for the certification: understanding of AWS tenets, hands-on experience with the AWS CLI and SDKs tools, understanding of network technologies, understanding of security concept with hands-on experience in implementing security controls and compliance requirements, understanding of virtualization technology. Moving on, here are a few important details related to this certification. So cost of examination is $150. Average annual salary is $111,966. The duration of examination is 130 minutes and the number of questions is 65. which are multiple choice and multiple response questions, with passing score of 70% and renewal time of 2 years. And here are the companies hiring: Amazon, IBM, Capgemini, TCS, and Oracle. Fifth is Microsoft Certified Azure Fundamentals. Azure Fundamental Certifications allows you to demonstrate your understanding of cloud concepts, Azure services, Azure workloads, Azure security and privacy, and Azure pricing and support. The Azure Foundation certification intended for people who already have a basic understanding of cloud services. It will explain you cloud concepts as well as how to use them, and the difficulty level is easy. Skills required for this certification is the different cloud computing concepts, main Azure services, describing Azure security, privacy, compliance, and trust, Azure pricing and support. And here are a few certification details required for the certification. Cost of examination is $99 USD, which can vary. Average annual salary is $110,000. The duration of this examination is 85 minutes, and the number of questions varies between 40 to 60. And the type of questions are multiple choice and multiple response questions. The passing score for this examination is 70%, and the renewal time is 6 months. And the top companies hiring are Microsoft, Dell, Accenture, and Cognizant. Sixth is Microsoft Certified Azure Administrator Associate. An Azure Administrator is in charge of deploying, monitoring, and managing Microsoft Azure solutions, which includes significant compute, storage, network, and security services. By earning this certification, you will be able to demonstrate that you can deploy and manage Azure compute resources. This certificate will prepare you to develop, administer, and monitor cloud services such as storage, security, and virtual environments, among other things, and the difficulty level is intermediate. So the skills needed for this certification is main Azure services, describing Azure security, private, and compliance and trust, knowledge of Azure pricing and support, and knowledge of different cloud computing concepts. And here are the further important details needed for the certification. Cost of examination is $165 USD. Average annual salary is $107,683. Exam duration is 120 minutes, with number of questions varying between 40 to 60. And the type of questions are multiple choice and multiple response questions, with the passing score of 70%. Renewal time is 6 months, and the top companies hiring are Microsoft, Accenture, TCS, and Yahoo. Seventh is Google Associate Cloud Engineer. An Associate Cloud Engineer delivers and protects applications and infrastructure, oversees various projects, operations, and maintains corporate solutions to ensure that they fulfill performance goals. This person has worked with both public clouds and on-premises systems. For programmers, developers, and software engineers, this is the greatest Google Cloud certification. Its holder will be responsible for deploying web applications in the cloud, as well as monitoring and managing operations, and the difficulty level is intermediate. Here are some important skills required for you to excel this certification. Basic understanding of Google Cloud platforms, products, and services, and basic understanding of cloud concepts such as virtual machines, containers, and networking. And these are the few important certification details that you need to take care of. Cost of examination is $125 USD, with average annual salary of $109,415. Exam duration is 120 minutes, with number of questions 50. And the type of questions are multiple choice and multiple response questions with the passing score of 70%. And the renewal time is 2 years. And the top companies hiring are Google, Goldman Sachs. Here comes the eighth one, that is Microsoft Certified Azure Solution Architecture Expert. To implement solutions, an Azure Solution Architect work with cloud administrators, cloud DBAs, and clients. This credential displays the ability to provide advice to stakeholders and translate business requirements into safe, scalable, and dependable solutions. This certificate is for experienced programmers, developers, and DevOps engineers who wish to become Azure professionals. This is the ideal cloud certification, and the difficulty level is hard. And these are the skills required for this advanced certification: deploying and configuring infrastructure, implementing workloads and security, creating and deploying apps, implementing authentication and securing data, developing for the cloud and for the Azure storage. And these are the details you need to remember. Cost of examination, $165, average annual salary, $135,000, with exam duration of 150 minutes, and number of questions varies between 40 to 60. Type of questions are multiple choice and multiple response questions with a passing score of 70%. And the renewal time is 6 months. And the companies hiring are IBM, Microsoft, Infosys, and Medline. Coming to the ninth one is Google Professional Cloud Architect. A Google Certified Professional Cloud Architect means you demonstrate the ability to design and plan a cloud solution architecture, manage and provision the cloud solution infrastructure, design for security and compliance. The Professional Cloud Architect exam measures your abilities to design and plan a cloud solution architecture, manage and provision cloud solution infrastructure, and design for security and compliance. This is the ideal Google Cloud certification for experienced IT professionals interested in becoming solution architects for Google Cloud technologies such as Bigtable, BigQuery, and other GCP platform services. And the difficulty level is hard. And these are the skills you need to focus on: proficiency with command line, Linux operating system, and system operations, and 3+ years of industry experience. And here are the further details you need to take care of. Cost of examination is $200 with average annual salary of $140,000. The examination duration is 120 minutes with number of questions 40. The type of questions are multiple choice and multiple response questions with a passing score of 70%. And the renewal time is 2 years. And the companies hiring are Google and Goldman Sachs. And here comes the last but not the least, 10th certification, that is AWS Architect Professional. The AWS Certified Solutions Architect Professional exam verifies advanced technical knowledge and experience in designing distributed applications and systems on the Amazon Web Services platform. This certification aids in the identification and development of personnel with crucial capabilities for cloud implementation. The AWS Certified Solutions Architect credential verifies your ability to develop, implement, and evaluate applications on AWS under a variety of conditions. This advanced certification teaches you how to create and deploy scalable web applications on Amazon AWS servers, as well as how to choose the right service and power for your application. And the difficulty level is hard. And the skills required for this certification is familiarity with AWS CLI, AWS APIs, AWS CloudFormation templates, and Windows and Linux environments, ability to provide best practice guidance on the architectural design across multiple applications and projects of the enterprise, ability to evaluate cloud application requirements, and ability to design a hybrid architecture using key AWS technologies. And here are the details you need to know before applying for the exam. Cost of examination is $300 USD with average annual salary of $118,266. The examination duration is 180 minutes with number of questions 75. Types of questions are multiple choice and multiple response questions with a passing score of 70%. And the renewal time is 2 years. And the top companies hiring are Amazon, Accenture, IBM, and Mindtree. So this was all about top 10 cloud certification in 2022.
And whether you are a fresher or an IT expert with some experience, you can improve your skills in cloud computing by getting the proper training and certification. On that note, we present the postgraduate program in cloud computing by Simplilearn. The postgraduate program in cloud computing, designed in collaboration with Caltech CTME, helps you become an Azure, AWS, and GCP expert. This in-depth cloud computing certification course lets you master key architecture principles and develop the skills needed to become a cloud computing expert. Benefits of this postgraduate program include Caltech CTMA postgraduate certificate, enrollment in Simplilearn Job Assist, receive up to 30 CEUs from Caltech CTMA. Simplilearn Job Assist help you to get noticed by top hiring companies, attend masterclasses from Caltech CTMA, live virtual classes led by industry experts, hands-on project and integrated labs, online convocation by Caltech CTMA program director, 40 plus hands-on experience projects and integrated labs, caption projects in 4 domains, Caltech CTMA Circle membership. You can also fast-track your career with this cloud computing certification and its in-depth course curriculum, which covers the key concept of Azure, AWS, and GCP platform, and services such as AWS Lambda, Amazon S3, Azure App Services, and many more. These programs also cover the essential skills to become an expert in cloud computing, and you can consider these programs because it provides you with the certification from Caltech CTME, a well-reputed university in United States. So check out the link mentioned in the description box below. So without any further ado, let's get started.
Be that of a cloud developer, security engineer, a full stack developer, SysOps administrator, solutions architect, cloud architect, and so much more. Now let's have a look at some of the major cloud computing roles. First off, we have solutions architect. Now these are individuals who are responsible for analyzing the technical environment in which they are going to produce the solutions, the requirements, and the specifications. Secondly, they are required to select an appropriate technology that satisfies said requirements. They need to estimate and manage the usage and the operational costs of the solutions they provide, and they need to support project management as well as solution development. Next, we have SysOps administrators. They are involved in deploying, managing, and operating highly scalable and fault-tolerant systems. They need to select an appropriate service based on compute, security, or data requirements. They need to estimate and manage usage and operational costs, and they need to be able to migrate on-premises workloads onto an appropriate cloud computing platform. So among both of these roles, there are certain requirements that are remaining constant. Now let's have a look at the steps you need to take to become a cloud computing engineer. Your first step is to gain proficiency in a cloud computing platform. Now the first step is to become proficient in at least one of the 3 major cloud computing platforms, be it AWS, Azure, or the Google Cloud Platform. Now there are a huge number of resources that you can find on the internet. It could be YouTube videos, articles, virtual or physical classrooms, and so much more. Now, after you're done learning, you can get certified by Microsoft Azure, AWS, or the Google Cloud Platform. Now, for AWS, you have a number of different certifications, which can be divided into 3 categories, which are the foundational, which is just the basics, the associate level certifications, the professional level certifications, and the specialty certifications. Similarly, with Microsoft Azure, you have certifications that enable you to become an Azure Developer Associate, an Azure Administrator Associate, an Azure Architect Professional, and a DevOps engineer. Now, most cloud computing platforms have a free tier that you can take advantage of. These provide a number of free services for a period of time, some of which are free forever. So you can use these platforms to your advantage and do as much practice as you can on them. Now, if you want to learn more about cloud computing, you can also check out Simplilearn's YouTube channel. Then you can go on to the playlist section right here, and you can find comprehensive videos on a number of different cloud computing platforms, AWS and Microsoft Azure. Our AWS tutorial videos talk about what exactly is AWS, how you can become an AWS solutions architect, Amazon EC2, S3, some of the other services, and so much more. We also have detailed tutorials on Azure, which talks about what exactly is Azure, the certifications provided by Azure, some of the services like machine learning, Azure Active Directory, and so much more. And now we're at step 2, being experienced in at least one programming language. Unlike general purpose programming languages like C, C++, C#, and so on, cloud computing requires ones that are a lot more data oriented. Now, some of the major programming languages that are used in cloud computing are Go, Python, Clojure, and Java. Now, as I said before, there is a wealth of resources that you can learn from. There are free websites that you can practice your code on, like Quick Code, Code Academy, and several others. There's also resources like YouTube videos, as well as there's the option of online or offline classes. Now we're at step 3, specialization. You'll also need to be well versed with a number of key concepts. These are storage and networking. Now with storage, you need to know how data can be stored and where it can be accessed from. You need to know how it can be accessed from multiple different resources. You'll also need to have some experience with the services provided by Azure and AWS, like the Amazon S3 in AWS and the appropriately named Azure storage from Microsoft Azure. With networking, you need to have a strong understanding of the networking fundamentals as well as virtual networks. Next up, we have virtualization and operating systems. With virtualization, you need to know how virtual networks, which are just a combination of different virtual machines, can be used to emulate different components in a particular system. With operating systems, you need to have a very strong understanding of operating systems like Windows and Linux. Next up, we have security and disaster recovery. Now you need to understand how data, application, as well as infrastructure can be protected from malicious attacks. With disaster recovery, you need to be prepared for any unexpected circumstance by making sure your systems are always safe and are regularly backed up to prevent any sort of loss of data. Then we have web services and DevOps. Now you need to have a strong understanding of APIs or application program interfaces and web services. Some amount of experience with web design also can be of great help. With DevOps, you need to have a strong understanding of how cloud computing is able to provide a centralized platform on which you can perform testing, deployment, and production for DevOps automation. Moreover, with DevOps, you understand the synergy that the operations as well as the development teams have with each other and for the success of any project. And finally, you're a cloud computing engineer. Now, let's have a look at the salaries of cloud computing engineers. In the United States, cloud computing engineers earn around $116,000 per annum. In India, a cloud computing engineer is paid approximately 6,66,000 rupees per annum. Now, how can Simplilearn help you become a cloud computing engineer? So let's head on to Simplilearn's website. Here we have the Cloud Architect Master's Program. Now this deals with a number of different courses, all of which that can help you get started in your journey to becoming a cloud computing engineer. This Master's Program covers a number of different courses like AWS Technical Essentials, Microsoft Azure Fundamentals, AWS Developer Associate, and so much more. It provides you 40 plus in-demand skills and 25 plus services, provides you a master's certification. It has 16 plus real-life projects and helps you get a salary that ranges between 15 to 25 lakh rupees per annum. It also covers a variety of tools like Amazon EC2, Azure Data Factory, virtual machines, and so much more. So why don't you head on to simplilearn.com and get started on your journey to getting certified and getting ahead. Let's have a look at some of the skills required to become a cloud administrator. First off, you need experience with programming languages like C# and .NET. You'll also need to be experienced with DevOps tools like Jenkins, Docker, Ansible, and Chef. You'll need to have an understanding of database configuration so that you can take advantage of all the relevant information about the hardware and software components used by the organization. You'll also need to have experience with cloud infrastructure systems like servers, storage, network, and visualization software. Finally, you'll also need to configure virtual machines, VPNs, and cloud servers. Now, let's have a look at the salary offered to cloud administrators. Now, in the United States, the average salary of a cloud administrator is approximately $65,000 per annum. Similarly, in India, it's approximately 7 lakh rupees per annum. Now, let's have a look at some of the companies hiring for cloud administrators. We have companies like Wipro, Infosys, Accenture, IBM, and so on. So here I see a comment which says, I'm a fresher and want to learn about AWS. How can I start? So actually, any fresher can make a career in AWS as long as you have interest towards the subject. Now, if you are from a non-technical background, you need to put in a lot more hard work and have a lot of patience. So I would recommend that before you take up the AWS course, you have a look at the course curriculum, types of AWS courses, opportunities in the market for AWS certified candidates, and so on. So now let's go to number 6, Cloud Application Developer. Now, a cloud application developer mainly focuses on implementing and maintaining an organization's cloud infrastructure. Now, they're involved with designing, building, creating, analyzing, and maintaining cloud systems. Now, these individuals are also involved with ensuring that there's an effective design of business processes in the cloud. They're also involved with a number of different tasks like optimizing efficiency and performance, scaling application components, and security issues. Now let's have a look at some of the skills required to become a cloud application developer. First off, you need to have experience with database languages like MySQL, SQL, and MongoDB. Then you need to have experience with programming languages like Python, Ruby, and Perl so that you can code and create cloud computing applications. You'll also need to have experience with Linux. Now this is because most cloud infrastructures are created with Linux servers. You'll also need to have experience with cloud service providers like Amazon Web Services, Google Cloud Platform, and Microsoft Azure. You'll need to have experience with information security with the help of certifications. You'll also need to know how to create microservices and to create cloud applications. Now let's have a look at the salary offered to a cloud application developer. In the United States, it's approximately $70,000 per annum. In India, the average salary of a cloud application developer is approximately 8 lakh rupees per annum. Now, let's have a look at some of the companies hiring cloud application developers. You have companies like Bosch, McAfee, SAP, and so on. So now let's go to number 5, Cloud Network Engineer. A cloud network engineer is responsible for implementing, supporting, maintaining, and optimizing the network hardware, software, and communication links of the organization's cloud infrastructure. He or she basically focuses on automation and security while building the cloud infrastructure, enhancing network tooling visibility, and improving productivity. Now let's have a look at some of the skills required to become a cloud network engineer. First off, obviously, you need to have experience with networking, which means a familiarity with the internet and WAN communication technologies, protocols, and best practices. You need to have an understanding of cloud security and how you can design a public cloud with multiple options. You'll need to have an experience with data center administration, which basically means an understanding on infrastructure design, operations, and lifecycle management. And finally, you need to have experience with cloud computing platforms like Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Next, let's have a look at the salaries offered to a cloud network engineer. Firstly, the average salary of a cloud network engineer in the United States is approximately $72,000 per annum. In India, the average salary of a cloud network engineer is approximately 4 lakh rupees per annum. Now that we're done with this, let's have a look at the companies hiring cloud network engineers. We have companies like Amazon Web Services, Rakuten, Cisco, and so much more. Now for number 4, we have Cloud Automation Engineer. A cloud automation engineer focuses on cloud automation, orchestration, and integration. He or she implements, optimizes, and supports the cloud infrastructure and ensures it has high availability. They also have to increase the cost effectiveness and availability of the cloud. Now, let's have a look at some of the skills required to become a cloud automation engineer. First off, since the role is cloud-based, experience with a cloud service platform like Microsoft Azure, AWS, or Google Cloud Platform is an absolute must. You'll also need to have experience with programming languages like Python and Go that will help you make the process of automation easier. Next, experience with DevOps tools like Chef, Ansible, and Puppet are seen as a huge plus. You'll also need to have an understanding of Docker and containers. Experience with databases like PostgreSQL and MySQL that can handle multiple workloads would be very useful. And finally, you need to have experience with virtualization, which means you need to know how you can work with virtual servers, applications, storage, and networks. With this, you can reduce the amount of resources required by the organization. Now, let's have a look at the salary offered to cloud automation engineers. In the United States, the average salary of a cloud automation engineer is approximately $79,000 per annum. The average salary of a cloud automation engineer in India is approximately 5 lakh rupees per annum. Now that we're done, let's have a look at some of the companies hiring cloud automation engineers. We have companies like Oracle, Google, Capgemini, Disney, and so on. And now to number 3. Cloud Security Manager. A cloud security manager is someone who's responsible for providing security for cloud-based digital platforms and protecting the organization's data. He or she may be involved with creating new security methods or to analyze existing ones. They may also have to create cloud-based applications, performing threat simulations, and providing security recommendations. Now, let's have a look at some of the skills required to become a cloud security manager. First off, you'll need to have experience with at least one of the popular cloud service providers like Amazon Web Services, Microsoft Azure, and GCP. You'll also need to have experience in programming languages like Python, experience with commonly used DevOps tools like Jenkins so that you can implement continuous integration or continuous deployment models would be very helpful. You'll also need to be well versed with TCP/IP protocols and other networking concepts. You need to be well versed with PKI, SSL, SSH, HTTPS, and so on. Experience with web-based analytics and services would also be very helpful. Now let's have a look at the salary offered to a cloud security manager. In the United States, the average salary of a cloud security manager is approximately $99,000 per annum. In India, the average salary for cloud security manager is approximately 11 lakh rupees per annum. Now let's have a look at some of the companies hiring cloud security managers. We have companies like Deloitte, VMware, Cisco, Dell, and so on. Now let's move on to number 2, cloud engineer. A cloud engineer is an individual who is responsible for any technological duties that are associated with cloud computing, including design, planning, management, maintenance, and support. They are also involved with orchestrating and automating cloud-based platforms throughout the organization. Let's have a look at the skills required to become a cloud engineer. First off, you'll need to have experience with at least one of the popular cloud service providers like AWS, Microsoft Azure, or the Google Cloud Platform. You'll need to have an understanding of networking concepts like building and accessing servers, virtual networks, and so on. This enables cloud engineers to make sure that the network is responsive to the users. Next, you need to have experience with virtualization. With virtualization, you can reduce how many hardware units you need with the help of virtual machines. It also makes resources scalable and fault tolerant in an organization. Experience with the Linux operating system would also be very helpful, considering how 30% of the servers that power Azure are Linux based. You'll need to know about APIs to design RESTful services. Experience with DevOps is also a major skill to have, since it'll be able to help handle work dependencies between the development and operation teams. And finally, you need to have programming experience with languages like Java, Python, C++, and Ruby. Next, let's have a look at the salary offered to a cloud engineer. In the United States, the average salary of a cloud engineer is approximately $105,000 per annum. The average salary in India is approximately 5 lakh rupees per annum. Now, let's have a look at some of the companies hiring cloud engineers. We have companies like McAfee, IBM, JP Morgan, Visa, and so on. Now I see a pretty good question in the chat. How do you become a cloud engineer? So to become a cloud engineer, you need to have experience with the programming language, experience with at least one cloud service platform, which is Amazon Web Services or Microsoft Azure or Google Cloud Platform. The choice is yours. And you need to specialize in a particular service, be it storage and networking, disaster recovery, and so on. And now for number 1. Cloud architect. A cloud architect is responsible for managing cloud computing architecture in an organization. He or she handles everything to do with front-end platforms, servers, storage, delivery, and networks. Now, let's have a look at some of the skills required to become a cloud architect. First off, you need to have knowledge in programming. Knowledge about Perl, Python, Ruby, PHP, Java, and .NET can provide users with the ability to build, deploy, and manage applications quickly. You'll need to know about the basics of networking, Since most of the work what you'll be doing would be web related, knowledge about networking can be really helpful. Knowledge about data storage fundamentals are also really important. This provides you with the knowledge to determine which data storage option to use and when. Being experienced with cloud service platforms is also really important. Platforms like AWS, Google Cloud Platform, and Microsoft Azure are what you are going to be basing most of your work on. Experience with them is pretty important. And finally, cloud security. This will help you make sure that your data is secure and only authorized code is run and the right people are allowed to run it. Now, let's talk about the salary of a cloud architect. The average salary of a cloud architect is approximately $107,000 per annum. In India, the average salary of a cloud architect is approximately 16 lakh rupees per annum. And there you go. Those are the top job roles in the field of cloud computing. Now, let's have a look at some of the companies hiring cloud architects. We have companies like EY, Wipro, Huawei, Hewlett-Packard Enterprise, and so on.
Hello everyone, let me introduce myself as Sam, a multi-platform cloud architect and trainer, and I'm so glad and I'm equally excited to talk and walk you through this session about what AWS is and talk to you about some services and offerings and about how companies get benefited by migrating their applications and infra into AWS. So what's AWS? Let's talk about that. Now, before that, let's talk about how life was without any cloud provider, and in this case, how life was without AWS. So let's walk back and picture how things were back in 2000, which is not so long ago, but a lot of changes for better had happened since that time. Now, back in 2000, a request for a new server is not an happy thing at all, because a lot of money, a lot of validations, a lot of planning are involved in getting a server online or up and running. And even after we finally got the server, it's not all said and done. There are a lot of optimization that needs to be done on that server to make it worth it and get a good return on investment from that server. And even after we have optimized for a good return on investment, the work is still not done. There will often be a frequent increase and decrease in the capacity, and even news about our website getting popular and getting more hits, it's still an bittersweet experience, because now I need to add more servers to the environment, which means that it's going to cost me even more. But thanks to the present day cloud technology, if the same situation were to happen today, my new server, it's almost ready, and it's ready instantaneously. And with the swift tools and technologies that Amazon is providing in provisioning my server instantaneously and adding any type of workload on top of it and making my storage and server secure, creating a durable storage where data that I store in the cloud never gets lost, with all that features, Amazon has got our back. So let's talk about what is AWS. There are a lot of definitions for it, but I'm going to put together a simple and a precise definition as much as possible. Now, let me iron that out. Cloud still runs on an hardware, all right? And there are certain features in that infrastructure, in that cloud infrastructure, that makes cloud, or that makes AWS a cloud provider. Now, we get all the services, all the technologies, all the features, and all the benefits that we get in our local data center, like, security and compute capacity and databases. And in fact, we get even more cool features like content caching in various global locations around the planet. But again, out of all the features, the best part is that we get everything on a pay-as-we-go model. The less I use, the less I pay, and the more I use, the less I pay per unit. Very attractive, isn't it? Right? And that's not all. The applications that we provision in AWS are very reliable because they run on a reliable infrastructure, and it's very scalable because it runs on an on-demand infrastructure, and it's very flexible because of the designs and because of the design options available for me in the cloud. Let's talk about how all this happened. AWS was launched in 2002 after the Amazon, we know as the online retail store, wanted to sell their remaining or unused infrastructure as a service or as an offering for customers to buy and use it from them, sell infrastructure as a service. The idea sort of clicked, and AWS launched their first product in 2006. That's like 4 years after the idea launch. And in 2012, they held a big sized customer event to gather inputs and concerns from customers, and they were very dedicated in making those requests happen. And that habit is still being followed. It's still being followed as reInvent by AWS. And at 2015, Amazon announced its revenue to be 4.6 billion. And in 2015 through 2016, AWS launched products and services that help migrate customer services into AWS. Well, there were products even before, but this is when a lot of focus was given on developing migrating services. And in the same year, that's in 2016, Amazon's revenue was 10 billion. And not the least, as we speak, Amazon has more than 100 products and services available for customers and get benefited from. Alright, let's talk about the services that are available in Amazon. Let's start with this product called S3. Now, S3 is a great tool for internet backup, and it's the cheapest storage option in the object storage category. And not only that, the data that we put in S3 is retrievable from the internet. S3 is really cool. And we have other products like migration and data collection and data transfer products. And here we can not only collect data seamlessly, but also in a real-time way monitor the data or analyze the data that's being received. That there are cool products like AWS data transfers available that helps achieve that. And then we have products like EC2, Elastic Compute Cloud. That's an resizable computer where we can anytime alter the size of the computer based on the need or based on the forecast. Then we have simple notification services, systems and tools available in Amazon to update us with notifications through email or through SMS. Now anything can be sent through email or through SMS if we use that service. It could be alarms or it could be service notifications if you want, stuff like that. And then we have some security tools like KMS, Key Management System, which uses AES 256-bit encryption to encrypt our data at rest. Then we have Lambda, a service for which we pay only for the time in seconds it takes to execute our code, and we're not paying for the infrastructure here. It's just the seconds the program is going to take to execute the code. If it's a short program, we'll be paying in milliseconds. If it's a bit bigger program, we'll be probably paying in 60 seconds or 120 seconds. But that's lot cheap, lot simple, and lots cost effective as against paying for service on an hourly basis, which a lot of other services are. Well, that's cheap, but using Lambda is a lot cheaper than that. And then we have services like Route 53, a DNS service in the cloud. And now I do not have to maintain an DNS account somewhere else and my cloud environment with AWS. I can get both in the same place. Alright, let me talk to you about how AWS makes life easier, or how companies got benefited by using AWS as their IT provider for their applications or for the infrastructure. Now, Unilever is a company, and they had a problem, right? And they had a problem, and they picked AWS as a solution to their problem, right? Now, this company was sort of spread across 190 countries, and they were relying on a lot of digital marketing for promoting their products. And their existing environment, their legacy local environment, proved not to support their changing IT demands, and they could not standardize their old environment. Now, they chose to move part of their applications to AWS because they were not getting what they wanted in their local environment. And since then, rollouts were easy, provisioning new applications became easy, and even provisioning infrastructure became easy, and they were able to do all that in push button scaling. And needless to talk about backups that are safe and backups that can be securely accessed from the cloud as needed. Now that company is growing along with AWS because of their swift speed in rolling out deployments and being able to access secure backups from various places and generate reports, and in fact useful reports out of it that helps their business. Now on the same lines, let me also talk to you about Kellogg's and how they got benefited by using Amazon. Now Kellogg's had a different problem. It's one of its kind. Now their business model was very dependent on an infra that will help to analyze data really fast, right? Because they were running promotions based on the analyzed data that they get. So they being able to respond to the analyzed data as soon as possible was critical or vital in their environment. And luckily, SAP running on HANA environment is what they needed, and they picked that service in the cloud, and that sort of solved the problem. Now the company does not have to deal with maintaining their legacy infra and maintaining their heavy compute capacity and maintaining their database locally. All that is now moved to the cloud, or they are using cloud as their IT service provider, and now they have a greater and powerful IT environment that very much complements their business.
Coming to the AWS services, so essentially AWS services are compute, storage, database, migration, networking and content delivery, developer tools, management tools, media services, machine learning, analytics, security, identity and compliance, mobile services, application integration, AR and VR, which is augmented reality and virtual reality, customer engagement, business productivity, desktop and app streaming, Internet of Things, which is IoT. Now let's look into the compute service, which is one of the widely used service on the AWS. And what does the compute service do? These services help developers build, deploy, and scale an application in the cloud platform, that is EC2, Lambda, Elastic Container Service, Elastic Load Balancer, Lightsail, and Elastic Beanstalk. These are the services which lie in the compute service section only. One of the most widely used service within the compute section is EC2, which stands for Elastic Cloud Compute. It is a web service that allows developer to rent virtual machines and help to resize the compute capacity. So here what you can do is you can run the virtual machines, and you have the privileges to select the type of operating system that you want should be running on your instances or on your virtual machines. And likewise, later you can customize as per your requirement. Lambda is a serverless compute service. It is also responsible to execute code for a specific application. So those who are from the development background, they can focus more on creation of a code. They don't have to create a server, manage it. Instead, they can use a Lambda where they can deploy their code directly onto the Lambda server. Then comes the storage service. Now, couple of storage services are S3 Glacier, EBS, which is Elastic Block Storage, Storage Gateway. Now, AWS provides web data storage service for archiving data. Also, its main advantage is disaster data recovery with high durability. Let's look into some of the essential storage services, and one of the most widely used storage services is S3, which stands for Simple Storage Service. In the Simple Storage Service, what you need to do is you have to create a bucket, and in that bucket you have to put the files in it. So S3 gives open cloud-based storage service which is utilized for online data backup. Then comes the EBS, which is an Elastic Block Storage. Now you can understand EBS as a virtual hard drive also, which attaches with the EC2, and it provides high availability storage volume for persistent data. It is mainly used by Amazon EC2 instances. Then you have the database services. AWS Database Domain Service offers cost-efficient, highly secure, and scalable database instances in the cloud. And some of the database services are RDS, which is a relational database service, DynamoDB, the non-relational or NoSQL or NoSQL database service, Elasticache, and Amazon Redshift. Now, one of the essential database service is the DynamoDB. It is a flexible NoSQL database service, which offers fast and reliable performance with no scalability issues. It is fast, reliable, highly scalable, and suitable for small scale applications like mobile applications, gaming applications, or anything with respect to the Internet of Things devices. There, the DynamoDB is most widely used or suitable. Then comes the relational database service, that is the RDS, which is a structured database service. It is a managed distributed relational database cloud service that helps developers to operate and scale database in a simple manner. So RDS has different vendors platform with respect to the database usage, and that includes the PostgreSQL, MySQL, then you have Oracle, Microsoft, or MS SQL, and they have their own customized database as well, that is called as the Amazon Aurora. Along with that, they have a Maria database or MariaDB as well. So these are a couple of vendors that give their database engines that you can use on the RDS. Now coming to the networking services, it offers a highly secure cloud platform and helps in connecting your physical network to your private virtual network with high transfer speed. Now, some of the services in the networking and content delivery are VPC, which is a virtual private cloud, a very important service in order to make your applications or services more secure. Route 53, which is a DNS mapping service. Direct Connect, which directly connects with the AWS services and with your data centers. And the CloudFront, that is basically a content delivery service. Now coming to the VPC or a virtual private cloud, it helps a developer to deploy AWS resources such as Amazon EC2 instances in a private virtual cloud so that you can actually make your EC2 isolated or make it more secure, and even you can make it for a public access also. Depends on the administrator that how they want to customize it. So the complete control of a VPC and its networking is with the admins. Then comes the Route 53 service. It is a web service with highly available domain name system or the DNS that helps user to route software by translating text into IP address, and that is why it is called as a DNS mapping service. And that helps you to use your domains or the external domains pointed to the AWS services in case if you use AWS for hosting your websites or the applications. Note, DNS translates text into the IP address. Now coming to the developer tool services, it helps a user build, deploy and run an application source code automatically. It also updates a server and instance on the workload. So first is the CodeStar, Code Build, Code Deploy, Code Pipeline. So CodeStar, it is a service designed to manage application development at a single place. Here developers can quickly develop, build and deploy applications on AWS. So all the managed app development can be done with the CodeStar. Code Build removes the hassle of managing physical servers and helps developer build and test code with continuous scaling. So security, identity and compliance services helps in monitoring a safe environment for your AWS resources by providing limited access to specific users. So in case, let's assume that you have to give an access to someone but with limited privileges, you can primarily use IAM in that case. And if you want to make your applications or deployments more secure, then you can use these services like KMS, IAM, Cognito, WAF, which acts as a firewall. Now the IAM service, which is the Identity Access Management, is a framework that helps in maintaining access to AWS services in a secure way. So what happens is that the admin who has the complete access of the AWS console provide access to users, and there can be different users, and they would have the privilege accesses defined by the admin. So what type of permissions the admin gives them, they would have those limited access on the AWS console. KMS enables users to create and manage the encryption keys that are used for encrypting data. Coming to management tool services, With the help of management tools, using this service, an individual can optimize costs, minimize risk, and automate all the resources running on the AWS infrastructure efficiently. So with the management tools, you can monitor the resources application, its tools, and the utilizations. And along with that, you can scale up, scale down the resources likewise. With the help of the management tools, you can also do the auditing task. So one of the essential service in the management tool service is the CloudWatch. It is a monitoring tool for AWS resources and customer applications running on AWS platform. So let's assume that you have used EC2, DynamoDB, S3, RDS, and you want to monitor those resources. You can use the CloudWatch that can give you the results. Coming to the CloudFormation, this service helps you in monitoring all your AWS resources at one place so that you can spend minimum time in managing those resources and maximum time on developing the application. So with the help of the CloudFormation, you can deploy the entire solution with the help of creation of a template. You just need to create one template and you have to deploy it. The rest of the things will be done by the AWS, and hence it is a kind of an automation task only. Now let's look into the demo of some of the essential services. So we'll start with the EC2, and I have already logged in into my AWS account. So where exactly you can find the EC2? Just click on the services. Under the compute section, you can find the EC2. EC2 stands for Elastic Cloud Compute Service, primarily used for creating the virtual machines. So I'll click on this service and quickly I'll show you how the virtual machine is created and how we can basically access it. So I would be creating one virtual machine or an instance with the Windows operating system. So here you can see there are 3 instances which are already running. Let me create another one. So you have to click on launch instances, and here you have to select some configuration details. So most of the configuration details I'll be taking as default, and wherever it is necessary I'll be making the changes. So first of all, you have to select the operating system in the form of AMI, and I would be looking for Windows 2016, and then you have to select the type of instance with respect to the CPUs, number of CPUs, and the memory capacity. So I'll go with T2.micro, which is a free tier eligible instance. In the configure instance details, the rest of the things we'll keep it as default as of now. Click on add storage. This is basically the virtual hard drive or the EBS, the elastic block storage, that is attached with the EC2 instance. So primarily it is giving us 30 GB of space without any additional cost. We can leave the tags as blank. Click on configure security groups, and here you can see that the RDP port is by default open, which will actually allow us to RDP or to have a remote connectivity of our instance. Click on review and launch. Now to give an authentication or to provide an authentication, we should have a key pair with us so that the AWS can understand or can tally the key pair and give us the access. So I already have a key pair created. What I'll do is I'll create a new key pair for this instance and put a random name. Let's say I put it something like demo. Download the key pair and make sure that you keep your key pair in a safe and secure place. Click on launch instances. Now you will see that there is an instance ID that has been created, which is a number, alphanumeric number, that is randomly given by the AWS. You can name your instances. So let's say we name our instance as Windows 2016. Click on save, and the AWS deploys our instance on a respective infrastructure. It gives us the IP addresses, the public IP and the private IP, which is an internal IP, and we have to access the instance from the public IP only. So now to access that instance, we have to open up the RDP, put the public IP, click on connect, and when it asks you for the authentication, you put a username as administrator, and the password you have to generate by providing the key. So click on connect, and then you have to click on RDP client. Here you have to get a password. So click on get password, browse, and when you click on browse, you have to provide demo.pem file. So it should be in the download section here itself. Just provide that key pair and it is going to give you the password in the encrypted format. Decrypt your password, copy that, and then provide those details to the RDP client. Click on OK, and now it should allow you to log into the instance. Let's wait for the windows to appear. So here you can see that we have logged in into the Windows instance. The Windows 2016 screen is available in front of us.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
In this particular demonstration, I would be explaining you about how to use a storage service, specifically the S3 service, which is most widely used service under the storage section. Now the S3 stands for Simple Storage Service, primarily used for storing the objects and the files. And what we need to do is we just have to click on the S3 service under the storage section. So when you click on S3 service, you have to create the buckets inside the S3. And the buckets are the places where you keep your folders or you upload the files that are available on your systems. So here if you'll notice that the S3 service is a global service. That means it is irrespective of the region. And the buckets when you create, they are created in a specific region. Now what is the benefit? The benefit is that if you create a bucket in different regions, all those buckets in different regions can be viewed from a single dashboard. And you don't have to change the region again and again to view the S3 buckets. So what you need to do is you have to click on create bucket, and here you have to specify the name of the bucket. So let's say I put something like demo AWS, and that's the bucket name I am going to select. Now make sure that the bucket name starts with a lowercase and it should be always unique. Now why it should be unique? Because since S3 is a global service, so it may be that somebody else could be using the name that you have provided. So it should be always unique, otherwise it will not be allocated. Now you have to select a region, and that would be, let's say I go with the Ohio region. And in the bucket settings, you can basically change and configure these settings according to your requirement. By default, when you create a bucket, it blocks all the public access from the bucket. So when you have all public access blocked, no object can be viewed from the S3 bucket from a public network or by anyone else. And hence, in order to view the objects or the files in the bucket, you have to unblock or uncheck this option, so that first of all you make the bucket accessible from the public network. Likewise, you can customize as per the requirement, and then click on acknowledgement. The rest of the things we'll keep it as default, and click on create bucket. Now it says that the bucket with the same name already exists, so that means it is not a unique name. Somebody else might have been using this name. So I'll try to keep it more unique, and I'll try to assign some number. So let's say I put something like 987, and it says it is already existed. Let's say 9876, and then click on create bucket. Now if it creates a bucket, that means we have been allocated with that bucket name. So let's wait for wait for a minute to get that bucket created. So that happens quickly, and you can see there are a couple of buckets already created here, and these buckets can be viewed in a single dashboard. So some of the buckets are in Mumbai region, some of the buckets are in Ohio region, but they are available in the same or a single dashboard. So I'll open up the bucket that I have recently created and I'll try to upload some documents. Now what you can do is you can create a folder also inside the S3, and when you create a folder you can upload the objects accordingly. Otherwise you can directly also upload the objects. So click on upload and we will upload any random file from my system onto the S3 bucket. So I'll basically file and then click on upload. Now it is uploading my object from my system onto the S3 bucket, and now it has successfully done. So it says the message is successful. Now in order to validate, I will click on the bucket from the S3 service and view this object. Now you can see here is my bucket, so I'll just open up this bucket and these DNS records.csv file is available with us. Now the S3 is not only limited till storing the objects or the files. It has many other functionalities and the features also. Like you can enable versioning, you can host a static website on the S3. Along with that, you can have a cross-region replication enabled so that you can have high availability of your objects, or you can have a redundancy of your critical objects in different regions. So likewise, there are more features that would be covered up in the detail section of an S3 service. Now coming to another section of the essential services, that is the database. Now here you can see I have a database section in the AWS and it has multiple services within it. The RDS is there, DynamoDB is there, Elastic Cache and the other database services are there. So I would be showing a demo on the DynamoDB, which is a NoSQL database. Now when we say it is a NoSQL database, that means it is a non-relational database service where we can create a database table directly from the web console. We don't require a separate database engine like in the case of RDS. And in the tables you can insert the values and view those values directly from the AWS dashboard itself. So it says Amazon DynamoDB is a fast and flexible NoSQL database service primarily suitable for IoT and web gaming and other mobile applications. So what you need to do is, it is a straightforward database service which can be accessed while creating a table itself, and it's a compute based database service. That is the reason that it is more fast. So click on create table, and what you need to do is you just have to put a table name. So I'll just put something like test, and in the partition key, so these partition keys are unique entities. So what you need to do is you have to specify a partition key. So I'll put something like ID, and the string, instead of string I'll use a number. Likewise I can add sort keys also. Let's say I put a name and the name should be in the string format. Now these are the unique entries, these are the fixed entries in the table, and after that we are going to put the attributes, and in the attributes the data will be inserted. So what you need to do is, rest of the things we'll keep it as default as of now. Click on create, and here you can see the table has been created, the test table has been created. Now if I click on the items, so you would see that it has the sort keys available, the ID and the sort key associated with that, that is the name, but it does not have any entry because we have not added any value or the attributes. So how we can add or insert the values in this table? That can be done many ways. You can enter manually, you can use the help of CLI to enter the large chunk of data directly, upload it onto the DynamoDB table, and also you can use the APIs also in order to insert the data inside the table. So what you will do is, we will click on create item, and in the ID we will put some value. Let's say number 1 string. Let's say we put something like we will go with a random name. So instead of putting any name, we'll put a value like ABCD. That should be fine. And then we will insert some attributes. So let's say I put string as rank, and I'll put something like rank 2 and then click on save. So here you will see, just refresh the database table, close it and open it up again, click on the items. Now here you can see the ID 1, name is ABCD, got the rank 2. Likewise, you can click on create items. Let's say the serial number or the ID 2, name, let's say we put something like, we can go with XYZ, any random thing, put it up as number rank, and let's say this particular value got a rank 3. Likewise, you can add some more items. String, let's say you put something like HJK, and you put a rank, let's say it's a rank number 1 holder, rank 1 holder, right? So likewise, this is just an example. Likewise, you can add the attributes as per your need, and the table can be filtered out based on the attributes also. So if you have to search some values in the DynamoDB table, so you can always use filters to basically search the values inside the table. Apart from that, the DynamoDB table has a lot of other functionalities. It can be basically, you can have a backup of a table created in the DynamoDB table, in the Dynamo database, and then you can retrieve or recover the data by restoring the backups from the DynamoDB. This database can be created in the cluster format also. So these are a couple of features that you can use with the DynamoDB. Now let's move into the next section. Now coming to the networking services, so there are some of the networking services which are very useful, and that includes the VPC, which is a virtual private cloud, CloudFront, Route 53, API gateway, etc. Now I will basically demonstrate about the Route 53 service in this demo. So in the Route 53 is basically a DNS mapping service. So what you can do is, let's assume that you are hosting any web application on the server and you want to route the domain traffic onto those servers. You need to have the help of Route 53 to do that. So what you need to do is, you just have to click on Route 53 service. And from this service you can register your domains also. Otherwise, if you have domains purchased from any external site, you can point them to the Route 53 name servers also. So first of all, in the Route 53 you have to create a hosted zone. So there is already one hosted zone all created. Now when you create a hosted zone, you have to specify the domain name. So let me show you. I have one dummy domain. This is the domain that has been defined. So what you have to do is, when you click on create hosted zone, you have to put a domain. Here you can see example.com. Likewise, you have to put your own domain and click on the public hosted zone, click on create hosted zone, and it is going to give you 4 name servers. Now those 4 name servers have to be updated on the platform from where you have purchased the domain. So that is mandatory in order to route the traffic to the Route 53 service, right? So here you can see I already have a hosted zone created for a domain, and it has given me 4 name servers. These are the name servers, and these name servers have been updated in a record set from where the domain has been purchased, right? Once it is done, then you have to route the domain traffic to a server. So what you have to do is, you have to click on create record, and in the create record you have to specify the IP address, or you can use the alias also, where the traffic should be routed to, where your application is hosted at. So ideally it is a server details, and it exists with certain policies also. So you can see some view existing records. So here you can see this particular domain is routed to a DNS value which is hosted in the Elastic Beanstalk. Instead of that, you can put an IP address of the EC2 instance also. You can use the S3 URL also. You can use the CloudFront URL also. So likewise, what would happen is that the domain traffic will be routed to the server where actually the application or a web application is hosted at. Now, I'm using a routing policy as simple routing policy. That means all the traffic should be routed to that particular domain. Whereas there are other routing policies also in the Route 53 that includes the weighted routing policy, which acts as a kind of a load balancing, geolocation routing policy, multi-value answer routing policy, and then you have a redundancy based routing policy, which is a failover one. So likewise, you can select as per your requirement. So what you need to do is you just have to click on create records. You have to specify, you have the domain, so you have to specify any particular info you want to put before the domain, otherwise you can leave it as blank. And in the record type, let's assume that you are using an IP address of a server where your web application is hosted at, so you can basically use A routes traffic to an IPv4 address and put an IP address. Make sure that you put a public IP address or the elastic IP address attached to your instance. In case if you are not using any particular IP address or the URL, you can use the alias also. So likewise, the records can be created. Along with that, the Route 53 services used for domain verifications also. Like if you want the email services onto your web application, then you can basically verify your domain directly from the Route 53 service. You can get the verification done for the SSL certificate creation. For that also, the records will be directly created from the Route 53 service because it is actually managing or hosting your domain. Now with respect to the security services, the most widely used service is the IAM, which is Identity Access Management. That lies under security, identity and compliance. So from the IAM you can create the users whom you want to give an access to your AWS console. You can create groups and you can add multiple users in that group, give them the permissions. You can create the roles also so that multiple services can interact or integrate it together. So how the IAM is used, click on the IAM service and I'll show you how a particular user can be created and how the user is basically uses the credentials to access the AWS console. Now the IAM dashboard is open, and when you open up the IAM dashboard, it gives you the URL. So this is the URL through which the user has to actually access the AWS console by providing the user credentials. Now how the users are created, just click on the users and here you just have to click on add user. So I'll create one sample user. Let's say I put something like sample user. And what type of an access you want to give that particular user? Do you want to give a programmatic access, which is primarily the CLI access, or you want to give the AWS Management Console? So right now we'll go with the AWS Management Console access. Now, do you want an auto generation of the password or do you want to customize the password? So let's assume that we customize the password. So put any value. Make sure the password meets all the criterias and then click on next permissions. Now, what kind of permissions you want to give to that user? Let's assume that you want to give an access of a particular service only to that user. So you have to actually search a policy for that particular service that can be given an access to a user. Otherwise, if you want to give an admin policy or the admin access to that user, you can search an admin policy there. So the permissions are important, otherwise the user would not have privileges to access the AWS console. So we'll attach the existing policies directly. So click on it. And here, let's assume that I want to give an admin access to that user. So I'll just click on the admin access. Now to a particular user, you can give multiple policies also. It is not necessary that you have to give only a single policy. So you can provide a multiple policies to the users also. Now click on next tags. Let's make the tags blank. Click on review and create a user. Now you'll see that our sample user would be created, and to access the console, we'll just copy this URL which has the account information as well, that is the account number. So copy the link, or you can copy the complete URL. Log out from the root account. And then paste the URL that was copied from the console. And then we have to give the user credentials. So we'll put sample user as the username and the password that we provided while creating the user. Click on sign in, and if it is correct, then it should allow us to log in into the AWS console while asking the password change. So we'll change the password. Confirm password change. And now it should allow us to log in into the root accounts AWS console with the admin privileges. Now the next service is the monitoring services, and under the monitoring services, primarily the CloudWatch, the CloudTrail, the CloudFormation, these are some of the services that are most widely used. Now the CloudWatch is a service which is primarily used for monitoring the metrics, primarily of the servers. Like for example, if you create an EC2 instance and you want to basically watch out for the metrics associated with the CPU utilization or the storage utilization, the network in, network out, all those information you can get it from the CloudWatch. Now CloudWatch is not only related to monitoring the metrics, it can generate the alarms also, and here you can get the events also generated, which or the events that can be created which can trigger the Lambda function as well. So what you have to do is you just have to click on a dashboard. So monitoring metrics are viewed with the help of the CloudWatch. So first of all, you have to create a dashboard. Now you have to put a dashboard name. Let's say I put something like monitoring EC2. Click on create dashboard. Now how do you want the reports to be published? You have to actually select a widget. I want that, okay, the report should be visible in the numeric form. So I'll select a number. Now click on the dashboard that was created, and let's again add the widget. And here we'll select the metrics primarily for the EC2 per instance metric. So we have one single instance running. Now there are 14 metrics available for that particular instance. Now I would be looking for the CPU utilization for this particular instance. So I'll just select for the CPU utilization, and it is going to give me some information about what is the current CPU utilization of that particular instance. So that is somewhere around 29.3%. The CPU utilization has been done for the single instance that is running in my EC2 dashboard. So likewise, you can add some more metrics and view them in this particular dashboard, and the CloudWatch will keep on publishing the data at a refresh interval of 5 minutes. That is the default value.
And whether you are a fresher or an IT expert with some experience, you can improve your skills in cloud computing by getting the proper training and certification. On that note, we present the postgraduate program in cloud computing by Simplilearn. The postgraduate program in cloud computing, designed in collaboration with Caltech CTME, helps you become an Azure, AWS, and GCP expert. This in-depth cloud computing certification course lets you master key architecture principles and develop the skills needed to become a cloud computing expert. Benefits of this postgraduate program include Caltech CTMA postgraduate certificate, enrollment in Simplilearn Job Assist, receive up to 30 CEUs from Caltech CTMA. Simplilearn Job Assist help you to get noticed by top hiring companies, attend masterclasses from Caltech CTMA, live virtual classes led by industry experts, hands-on project and integrated labs, online convocation by Caltech CTMA program director, 40 plus hands-on experience projects and integrated labs, caption projects in 4 domains, Caltech CTMA Circle membership. You can also fast-track your career with this cloud computing certification and its in-depth course curriculum, which covers the key concept of Azure, AWS, and GCP platform. and services such as AWS Lambda, Amazon S3, Azure App Services, and many more. These programs also cover the essential skills to become an expert in cloud computing, and you can consider these programs because it provides you with the certification from Caltech CTME, a well-reputed university in United States. So check out the link mentioned in the description box below. So without any further ado, let's get started.
Hi there, I'm Samuel, a multi-platform cloud architect, and I'm very excited and honored to walk you through this learning series about AWS. Let me start the session with this scenario. Let's imagine how life would have been without Spotify. For those who are hearing about Spotify for the first time, Spotify is an online music service offering, and it offers instant access to over 16 million licensed songs. Spotify now uses AWS Cloud to store the data and share it with their customers, but prior to AWS, they had some issues. Imagine using Spotify before AWS. Let's talk about that. Back then, users were often getting errors because Spotify could not keep up with the increased demand for storage every new day. And that led to users getting upset and users canceling the subscription. The problem Spotify was facing at that time was their users were present globally and were accessing it from everywhere, and they had different latency in their applications. And Spotify had a demanding situation where they need to frequently catalog the songs released yesterday, today, and in the future, and this was changing every new day. And the songs coming in rate was about 20,000 a day, and back then they could not keep up with this requirement, and needless to say, they were badly looking for a way to solve this problem. And that's when they got introduced to AWS, and it was a perfect fit and match for their problem. AWS offered a dynamically increasing storage, and that's what they needed. AWS also offered tools and techniques like storage lifecycle management and trusted advisor to properly utilize the resource, so we always get the best out of the resource used. AWS addressed their concerns about easily being able to scale. Yes, you can scale the AWS environment very easily. How easily, one might ask? It's just a few button clicks. And AWS solved Spotify's problem. Let's talk about how it can help you with your organization's problem. Let's talk about what is AWS first, and then let's bleed into how AWS became so successful and the different types of services that AWS provides, and what's the future of cloud and AWS in specific. Let's talk about that. And finally, we'll talk about a use case where you will see how easy it is to create a web application with AWS. Alright, let's talk about what is AWS. AWS, or Amazon Web Services, is a secure cloud service platform. It is also pay-as-you-go type billing model where there is no upfront or capital cost. We'll talk about how soon the service will be available. Well, the service will be available in a matter of seconds. With AWS, you can also do identity and access management, that is, authenticating and authorizing a user or a program on the fly. And almost all the services are available on demand, and most of them are available instantaneously. And as we speak, Amazon offers 100 plus services, and this list is growing every new week. Now that would make you wonder how AWS became so successful. Of course, it's their customers. Let's talk about the list of well-known companies that has their IT environment in AWS. Adobe uses AWS to provide multi-terabyte operating environments for its customers. By integrating its system with AWS Cloud, Adobe can focus on deploying and operating its own software instead of trying to deploy and manage the infrastructure. Airbnb is another company. It's an community marketplace that allows property owners and travelers to connect each other for the purpose of renting unique vacation spaces around the world. And the Airbnb community users' activities are conducted on the website and through iPhones and Android applications. Airbnb has a huge infrastructure in AWS, and they're almost using all the services in AWS and are getting benefited from it. Another example would be Autodesk. Autodesk develops software for engineering, designing, and entertainment industries using services like Amazon RDS or Relational Database Service and Amazon S3 or Amazon Simple Storage Service. Autodesk can focus on deploying or developing its machine learning tools instead of spending that time on managing the infrastructure. AOL, or American Online, uses AWS, and using AWS they have been able to close data centers and decommission about about 14,000 in-house and co-located servers and move mission-critical workload to the cloud and extend its global reach and save millions of dollars on energy resources. Bitdefender is an internet security software firm, and their portfolio of softwares include antivirus and anti-spyware products. Bitdefender uses EC2, and they're currently running few hundred instances that handle about 5 terabytes of data, and they also use Elastic Load Balancer to load balance the connection coming in to those instances across availability zones, and they provide seamless global delivery of service because of that. The BMW Group, it uses AWS for its new connected car application that collects sensor data from BMW 7 series cars to give drivers dynamically updated map information. Canon's Office Imaging Products division benefits from faster deployment times, lower cost, and global reach by using AWS to deliver cloud-based services such as mobile print. The Office Imaging Products division uses AWS such as Amazon S3 and Amazon Route 53, Amazon CloudFront, and Amazon IAM for their testing, development, and production services. Comcast, it's the world's largest cable company and the leading provider of internet service in the United States. Comcast uses AWS in a hybrid environment. Out of all the other cloud providers, Comcast chose AWS for its flexibility and scalable hybrid infrastructure. Docker is a company that's helping redefine the way developers build, ship, and run applications. This company focuses on making use of containers for this purpose. And in AWS, the service called the Amazon EC2 Container Service is helping them achieve it. The ESA, or European Space Agency, although much of ESA's work is done by satellites, some of the program's data storage and computing infrastructure is built on Amazon Web Services. ESA chose AWS because of its economical pay-as-you-go system as well as its quick startup time. The Guardian newspaper uses AWS, and it uses a wide range of AWS services including Amazon Kinesis, Amazon Redshift that power an analytic dashboard which editors use to see how stories are trending in real time. Financial Times, FT, is one of the world's largest leading business news organization, and they used Amazon Redshift to perform their analysis. A funny thing happened. Amazon Redshift performed so quickly that some analysts thought it was malfunctioning. They were used to running queries overnight, and they found that the results were indeed correct, just as much faster. By using Amazon Redshift, FT is supporting the same business functions with costs that are 80% lower than what was before. General Electric, GE, is at the moment as we speak migrating more than 9,000 workloads including 300 disparate ERP systems to AWS while reducing its data center footprint from 34 to 4 over the next 3 years. Similarly, Harvard Medical School, HTC, IMDb, McDonald's, NASA, Kellogg's, and a lot more are using the services Amazon provides and are getting benefited from it. And this huge success and customer portfolio is just the tip of the iceberg. And if we think why so many adapt AWS, and if we let AWS answer that question, this is what AWS would say. People are adapting AWS because of the security and durability of the data and end-to-end privacy and encryption of the data and storage. Experience. We can also rely on AWS way of doing things by using the AWS tools and techniques and suggested best practices built upon the years of experience it has gained. Flexibility. There is a greater flexibility in AWS that allows us to select the OS, language, and database. Easy to use. Swiftness in deploying. We can host our applications quickly in AWS, be it a new application or migrating an existing application into AWS. Scalability. The application can be easily scaled up or scaled down depending on the user requirement. Cost saving. We only pay for the compute power, storage, and other resources you use, and that too without any long-term commitments. Now let's talk about the different types of services that AWS provides. The services that we talk about fall in any of the following categories you see, like compute, storage, database, security, customer engagement, desktop and streaming, machine learning, developers tools, stuff like that. And if you do not see the service that you're looking for, it's probably is because AWS is creating it as we speak. Now let's look at some of them that are very commonly used. Within compute services, we have Amazon EC2, Amazon Elastic Beanstalk, Amazon Lightsail, and Amazon Lambda. Amazon EC2 provides compute capacity in the cloud. Now this capacity is secure and it is resizable based on the user's requirement. Now look at this. The requirement for the web traffic keeps changing, and behind the scenes in the cloud, EC2 can expand its environment to 3 instances, and during no load, it can shrink its environment to just 1 resource. Elastic Beanstalk, it helps us to scale and deploy web applications, and it's made with a number of programming languages. Elastic Beanstalk is also an easy-to-use service for deploying and scaling web applications and services deployed be it in Java, .NET, PHP, Node.js, Python, Ruby, Docker, and a lot other familiar services such as Apache, Passenger, and IIS. We can simply upload our code, and Elastic Beanstalk automatically handles the deployment from capacity provisioning to load balancing to auto scaling to application health monitoring. And Amazon Lightsail is a virtual private server which is easy to launch and easy to manage. Amazon Lightsail is the easiest way to get started with AWS for developers who just need a virtual private server. Lightsail includes everything you need to launch your project quickly on a virtual machine, like SSD based storage, a virtual machine, tools for data transfer, DNS management, and a static IP, and that too for a very low and predictable price. AWS Lambda has taken cloud computing services to a whole new level. It allows us to pay only for the compute time, no need for provisioning and managing servers. And AWS Lambda is a compute service that lets us run code without provisioning or managing servers. Lambda executes your code only when needed and scales automatically from few requests per day to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. Let's look at some storage services that Amazon provides, like Amazon S3, Amazon Glacier, Amazon EBS, and Amazon Elastic File System. Amazon S3 is an object storage that can store and retrieve data from anywhere. Websites, mobile apps, IoT sensors, and so on can easily use Amazon S3 to store and retrieve data. It's an object storage built to store and retrieve any amount of data from anywhere. With its features like flexibility in managing data and the durability it provides and the security that it provides, Amazon Simple Storage Service or S3 is a storage for the internet. And Glacier is a cloud storage service that's used for archiving data and long-term backups. And this Glacier is an secure, durable, and extremely low-cost cloud storage service for data archiving and long-term backups. Amazon EBS, Amazon Elastic Block Store, provides block store volumes for the instances of EC2. And this Elastic Block Store is highly available and a reliable storage volume that can be attached to any running instance that is in the same availability zone. EBS volumes that are attached to the EC2 instances are exposed as storage volumes that persist independently from the lifetime of the instance. And Amazon Elastic File System or EFS provides an elastic file storage which can be used with AWS Cloud Service and resources that are on premises. And Amazon Elastic File System, it's simple, it's scalable, it's an elastic file storage for use with Amazon Cloud Services and for on-premises resources. It's easy to use and offers a simple interface that allows you to create and configure file systems quickly and easily. Amazon File System is built to elastically scale on demand without disturbing the application, growing and shrinking automatically as you add and remove files so your application have the storage they need and when they need it. Now let's talk about databases. The two major database flavors are Amazon RDS and Amazon Redshift. Amazon RDS, it really eases the process involved in setting up, operating, and scaling a relational database in the cloud. Amazon RDS provides cost-efficient and resizable capacity while automating time-consuming administrative tasks such as hardware provisioning, database setup, patching, and backups. It sort of frees us from managing the hardware and sort of helps us to focus on the application. It's also cost effective and resizable, and it's also optimized for memory, performance, and input and output operations. Not only that, it also automates most of the services like taking backups, monitoring, stuff like that. It automates most of those services. Amazon Redshift. Amazon Redshift is a data warehousing service that enables users to analyze the data using SQL and other business intelligence tools. Amazon Redshift is an fast and fully managed data warehouse that makes it simple and cost-effective to analyze all your data using standard SQL and your existing business intelligence tools. It also allows you to run complex analytic queries against petabyte of structured data using sophisticated query optimizations. And most of the results, they generally come back in seconds. Alright, let's quickly talk about some more services that AWS offers. There are a lot more services that AWS provides, but we're going to look at some more services that are widely used. AWS Application Discovery Services help enterprise customers plan migration projects by gathering information about their on-premises data centers. Planning a data center migration can involve thousands of workloads. They are often deeply interdependent. Server utilization data and dependency mapping are important early first step in migration process. And this AWS Application Discovery Service collects and presents configuration, usage, and behavior data from your servers to help you better understand your workloads. Route 53, it's a network and content delivery service. It's an highly available and scalable cloud domain name system or DNS service. And Amazon Route 53 is fully compliant with IPv6 as well. Elastic Load Balancing, it's also a network and content delivery service. Elastic Load Balancing automatically distributes incoming application traffic across multiple targets such as Amazon EC2 instance, containers, and IP addresses. It can handle the varying load of your application traffic in a single availability zone and also across availability zones. AWS Auto Scaling, it monitors your application and automatically adjusts the capacity to maintain steady and predictable performance at a lowest possible cost. Using AWS Auto Scaling, it's easy to set up application scaling for multiple resources across multiple services in minutes. Auto scaling can be applied to web services and also for DB services. AWS Identity and Access Management, it enables you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. And moreover, it's a free service. Now let's talk about the future of AWS. Well, let me tell you something. Cloud is here to stay. Here's what in store for AWS in the future. As years pass by, we're going to have a variety of cloud applications born like IoT, artificial intelligence, business intelligence, serverless computing, and so on. Cloud will also expand into other markets like healthcare, banking, space, automated cars, and so on. As I was mentioning some time back, lot or greater focus will be given to artificial intelligence. And eventually, because of the flexibility and advantage that cloud provides, we're going to see a lot of companies moving into the cloud. Alright, let's now talk about how easy it is to deploy an web application in the cloud. So the scenario here is that our users like a product and we need to have a mechanism to receive input from them about their likes and dislikes and give them the appropriate product as per their need. Alright, though the setup and the environment, it sort of looks complicated, we don't have to worry because AWS has tools and technologies which can help us to achieve it. Now we're going to use services like Route 53, services like CloudWatch, EC2, S3, and a lot more, and all these put together are going to give an application that's fully functionable and an application that's going to receive the information like using the services like Route 53, CloudWatch, EC2, and S3. We're going to create an application and that's going to meet our need. So back to our original requirement, all I want is to deploy a web application for a product that keeps our users updated about the happenings and the new comings in the market. And to fulfill this requirement, here is all the services we would need. EC2 here is used for provisioning the computational power needed for this application. And EC2 has a vast variety of family and types that we can pick from for the types of workloads and also for the intents of the workloads. We're also going to use S3 for storage. And S3 provides any additional storage requirement for the resources or any additional storage requirement for the web applications. And we're also going to use CloudWatch for monitoring the environment. And CloudWatch monitors the application and the environment, and it provides trigger for scaling in and scaling out the infrastructure. And we're also going to use Route 53 for DNS, and Route 53 helps us to register the domain name for our web application. And with all the tools and technologies together, all of them put together, we're going to make an application a perfect application that caters our need. Alright, so I'm going to use Elastic Beanstalk for this project, and the name of the application is going to be, as you see, GSG Signup, and the environment name is GSG Signup Environment 1. Let me also pick a name. Right, let me see if this name is available. Yes, that's available. That's the domain name. So let me pick that, and the application that I have is going to run on Node.js. So let me pick that platform and launch. Now, as you see, Elastic Beanstalk, this is going to launch an instance. It's going to launch the monitoring setup or the monitoring environment. It's going to create a load balancer as well. And it's going to take care of all the security features needed for this application. Alright, look at that. I was able to go to that URL, which is what we gave, and it's now having an default page shown up, meaning all the dependencies for the software is installed and it's just waiting for me to upload the code, or in specific the page required. So let's do that. Let me upload the code. I already have the code saved here. That's my code, and that's going to take some time. Alright, it has done its thing. And now if I go to the same URL, look at that, I'm being thrown an advertisement page. Alright, so if I sign up with my name, email, and stuff like that, it's going to receive the information and it's going to send an email to the owner saying that somebody had subscribed to your service. That's the default feature of this app. Look at that. Email to the owner saying that somebody had subscribed to your app and this is their email address, stuff like that. Not only that, it's also going to create an entry in the database. And DynamoDB is the service that this application uses to store data. There's my DynamoDB. And if I go to tables, right, and go to items, I'm going to see that a user with name Samuel and email address so and so has said okay or has shown interest in the preview of my site or product. So this is where, or this is how I collect those information, right? And some more things about the infrastructure itself is it is running behind an load balancer. Look at that. It had created a load balancer. It had also created an auto scaling group. Now that's the feature of Elastic Load Balancer that we have chosen. It has created an auto scaling group. And now let's put this URL. You see this? It's not a fancy URL, right? It's an Amazon given URL, a dynamic URL. So let's put this URL behind our DNS. Let's do that. So go to services, go to Route 53, go to hosted zone, and there we can find the DNS name, right? So that's a DNS name, all right? Alright, let's create an entry and map that URL to our load balancer, right? And create. Now, technically, if I go to this URL, it should take me to that application. Alright, look at that. I went to my custom URL and now that's pointed to my application. Previously, my application was having a random URL and now it's having a custom URL.
So now, what is Azure? What's the big cloud service provider all about? So Azure is a cloud computing platform provided by Microsoft. Now it's basically an online portal through which you can access and manage resources and services. Now resources and services are nothing but, you can store your data and you can transform the data using services that Microsoft provides. Again, all you need is the internet and being able to connect to the Azure portal. Then you get access to all of their resources and their services. In case you want to know more about how it's different from its rival, which is AWS, I suggest you click on the top right corner and watch the AWS versus Azure video so that you can clearly tell how both these cloud service providers are different from each other. Now, here are some things that you need to know about Azure. It was launched on February 1st, 2010, which is significantly later than when AWS was launched. It's free to start and has a pay-per-use model, which means, like I said before, you need to pay for the services you use through Azure. And one of their most important selling points is that 80% of Fortune 500 companies use Azure services, which means that most of the bigger companies of the world actually recommend using Azure. And then Azure supports a wide variety of programming languages, the C#, Node.js, Java, and so much more. Another very important selling point of Azure is the amount of data centers it has across the world. Now, it's important for a cloud service provider to have many data centers around the world because it means that they can provide their services to a wider audience. Now, Azure has 42, which is more than any cloud service provider has at the moment. It expects to have 12 more in a period of time, which brings its total number of regions it covers to 54. Now, let's talk about Azure services. Now, Azure services have 18 categories and more than 200 services, so we clearly can't go through all of them. It has services that cover compute, AI and machine learning, integration, management tools, identity, DevOps, web, and so much more. You're going to have a hard time trying to find a domain that Azure doesn't cover. And if it doesn't cover it now, you can be certain they're working on it as we speak. So first, let's start with the compute services. First, virtual machine. With this service, what you're getting to do is to create a virtual machine of Linux or Windows operating system. It's easily configurable. You can add RAM, you can decrease RAM, you can add storage, remove it. All of it is possible in a matter of seconds. Now let's talk about the second service, cloud service. Now with this, you can create an application within the cloud, and all of the work after you deploy it, deploying the application that is taken care of by Azure, which includes, provisioning the application, load balancing, ensuring that the application is in good health, and all of the other things are handled by Azure. Next up, let's talk about Service Fabric. Now with Service Fabric, the process of developing a microservice is greatly simplified. So you might be wondering, what exactly is a microservice? Now a microservice is basically an application that consists of smaller applications coupled together. Next up, functions. Now with functions, you can create applications in any programming language that you want. Another very important part is that you don't have to worry about any hardware components. You don't have to worry what RAM you require or how much storage you require. All of that is taken care of by Azure. All you need is to provide the code to Azure and it'll execute it, and you don't have to worry about anything else. Now let's talk about some networking services. First up, we have Azure CDN, or the Content Delivery Network. Now the Azure CDN service is basically for delivering web content to users. Now this content is of high bandwidth and can be transferred or can be delivered to any person across the world. Now these are actually a network of servers that are placed in strategic positions across the world so that the customers can obtain this data as fast as possible. Next up, we have Express Route. Now with this, you can actually connect your on-premise network onto the Microsoft Cloud or any of the services that you want through a private connection. So the only communication that happens is between your on-premise network and the service that you want. Then you have Virtual Network. Now with Virtual Network, you can have any of the Azure services communicate with each other in a secure manner, in a private manner. Next, we have Azure DNS. So Azure DNS is a hosting service which allows you to host their DNS or domain name system domains in Azure. So you can host your application using Azure DNS. Now for the storage services. First up, we have disk storage. With disk storage, you're given a cost-effective option of choosing HDD or solid-state drives to go along with your virtual machines based on your requirements. Then you have blob storage. Now this is actually optimized to ensure that they can store massive amounts of unstructured data, which can include text data or even binary data. Next, you have file storage, which is a managed file storage and can be accessible via the SMB protocol or the server message block protocol. And finally, you have queue storage. Now with queue storage, you can provide durable message queuing for an extremely large workload. And the most important part is that this can be accessed from anywhere in the world. Now, let's talk about how Azure can be used. Firstly, for application development. It could be any application, mostly web applications. Then you can test the application, see how well it works. You can host the application on the internet. You can create virtual machines like I mentioned before. With the service, you can create these virtual machines of any size or RAM that you want. You can integrate and sync features. You can collect and store matrices. For example, how the data works, how the current data is, how you can improve upon it. All of that is possible with these services. And you have virtual hard drives, which is an extension of the virtual machines where these services are able to provide you a large amount of storage where data can be stored. Let's talk about Azure services. As I told you, Azure provides services for a wide range of domains. Now let's have a look at some of these domains. There's AI and machine learning, compute, containers, database, identity, management tools, networking, security, storage, and so much more. Now let's have a look at some of the individual services within these domains. Firstly, you have Azure Virtual Machines. With Azure Virtual Machines, what you get is the opportunity to create Windows or Linux virtual machines. Now all of this is possible in a matter of seconds with a large amount of customization. Now let's have a look at some of its features. Firstly, you can choose from a wide variety of virtual machine options. Then you have a large amount of optimization available to you. For example, what size of operating system do you want? How much size do you want allocated to it? What version of the system is it? And so much more. Then it provides low cost and per minute billing. Now Azure provides you per minute billing, which means that you're only charged for how much time you use the service. And finally, you have enhanced security and protection for your virtual machines. Next, we have Service Fabric. Now with Service Fabric, you have a platform which enables you to create microservices. Now this also makes the process of application lifecycle management a whole lot easier. As a direct result, you can create applications with a faster time to market. It supports Windows, Linux, on-premises or other clouds, and it enables you to do a tremendous amount of scaling up depending on your requirement. And finally, we have functions. Now with functions, you can build applications with the help of serverless computing. Here, the users only pay for the amount of resources that they've used. You can create applications in any language that you want, and the only thing you need to worry about is the code of the application. Everything other than that, that is the hardware requirements, are taken care of by Azure. Now let's have a look at the networking services. Firstly, we have the Azure CDN, or the Content Delivery Network. With Azure CDN, what you get is the ability to deliver your content with reduced load times, fast responsiveness, and less bandwidth. Now, CDN can be integrated with several other Azure services so that the process can move at a faster rate. It can handle heavy loads and traffic spikes with ease. It also provides a robust security system. Now, with the content that's delivered, you can get advanced analytic data with which you can understand how customers are using your content. Next, we have ExpressRoute. With ExpressRoute, you can connect your on-premises network to Azure through a private network. Now, by default, this lowers latency. It increases the emphasis on reliability and speed, and it can be of great use when you have to transfer large amounts of data between networks. Now, another way this can be useful is if it's used to add compute or storage capacity to data centers. Next, we have Azure DNS. Domain Name Service, or Azure DNS, can be used to host your domains on Azure. This provides high availability and great performance. It provides fast responses to DNS queries by taking advantage of Microsoft's global network. It also provides high availability. Next, we have Virtual Network. Azure Virtual Network allows the Azure resources to communicate with each other or other on-premise networks via the internet, and all of this is kept extremely secure. Now with this, users can create their own private network for communication. It provides users with an isolated and extremely secure environment for their applications to run. Now all of the traffic stays entirely within the Azure network, and it also allows users to design their own networks. Next, we have Traffic Manager. Now with Traffic Manager, you can route incoming traffic to improve your performance and availability. Now one thing it provides is multiple failover options. So if a particular situation goes wrong, there's always an option to consider to salvage the situation. It helps reduce application runtime and enables the distribution of user traffic across multiple locations. It also helps the people who are using it to know where the customers connecting from across the world. Next, we have Load Balancer. With this, you are provided the ability to instantly scale applications at the same time providing high availability and improved network performance for users' applications. It can be integrated into virtual machines and cloud services. It provides highly reliable applications. It also allows users to secure and integrate security groups. Finally, we have Azure VPN Gateway. Now this allows users to connect their on-premise networks to Azure using a site-to-site VPN. Now this allows users to connect their virtual machine to anywhere in the world through a point-to-site VPN. And also it's very easy to manage and is highly available. Now let's talk about the storage services. First, we have Data Lake Storage. Now with this, what you get is a scalable data storage with an emphasis on cost effectiveness and scalability. Now it comes of maximum use when you integrate it with other services so that you can get analytics on how the data is being used. It is also integrated with other services like the Azure Blob Storage. Now it is also optimized for big data analysis tools like Apache Spark and Hadoop. Next up, we have Blob Storage. Now Blob Storage provides a storage capacity for data. Now depending on how often a particular data is used, it is classified into different tiers. Now all the data that is within the blob storage is unstructured data. Now it has a way of ensuring that the data integrity is maintained every time a particular object is being changed or the data is being accessed. And it also helps improve app performance and reduces bandwidth consumption. Next, we have queue storage. Now with this, you have a message queuing system for large workloads. This allows users to build flexible applications and separate functions. Not to mention, with this, you can be sure that your individual components will not fail. It also makes sure that your application is scalable. Queue storage provides queue monitoring, which helps ensure that the customer's demands are met. Then we have file storage. Now with file storage, you can perform file sharing with the help of the SMB protocol or the server message block protocol. Now this data is protected by SMB 3.0 and the HTTPS protocol. In this case, like we mentioned in functions, Azure takes care of all the hardware needs and the operating system deployments on its own. It also improves on-premises performance and other capabilities. Lastly, we have table storage. With table storage, you can deploy semi-structured datasets and a NoSQL key value store. Now this is used for creating applications which have a flexible data schema, and also considering how it has a very strong consistency model, it's mainly aimed for enterprises. Next, let's have a look at some web and mobile services. First, we have the Azure Search. Now with Azure Search, you get a cloud search service which is powered by artificial intelligence. With this, you can develop web applications as well as mobile applications. Now one big advantage is that you don't have to set up or manage your search indices. Azure takes care of that, and by extension, it increases your development speed. The artificial intelligence also will provide insights and structured information that you can use to improve the search and structured information. Next, we have Logic Apps. Now with this, you can create integration solutions which can connect applications that are important to your business. Now with this, you can visually create business processes and workflows. You can integrate SaaS or software as a service applications and enterprise applications. And more importantly, it allows you to unlock data within a firewall and securely connect to services. Next, we have web applications. Now with web apps, you can create, deploy, and scale web applications according to business requirements. Now it supports both Windows and Linux platforms, and it helps with continuous integration or deployment abilities. Another very important aspect of this is that the data can be deployed and hosted across multiple locations in the world. And finally, we have mobile apps. With mobile apps, you can create applications for iOS, Android, and Windows platforms. One advantage is that it automatically scales up and down based on your requirements. Now, in situations where you have network issues, offline data syncing ensures that your applications work anyway. And you can create cross-platform applications or native applications for iOS, Android, and Windows. Next, let's have a look at some container services. First, let's talk about ACS or Azure Container Services. It is also known as the Azure Kubernetes Services, as it's a fully managed Kubernetes container orchestration service. Now, what this means is that it eases the process of container integration and deployment. It also can be used with other resources from security like virtual networks, cryptographic keys, and so much more to ensure that your container is kept secure. Next, we have container instances. Now, this is similar to functions in a way, just that in this we're using containers without having to manage servers. Now, applications can be developed here without managing virtual machines or learning new tools. All that is Azure's problem to take care of. And it enables building applications without having to manage the infrastructure. That is, all you need to worry about is running the container. Next, let's have a look at some database services. First, we have the SQL database. Now with SQL database, what you get is a relational cloud database service. Now this means that it helps accelerate your app development and makes it easier for you to maintain your application. Now SQL database is also used extensively in migrating workloads to the cloud and hence saves time and cost. It also helps improve your performance by integrating machine learning and adaptive technologies into your database. Next, we have Azure Cosmos DB. Now this is a globally distributed multi-model database service. Now what this means is that with this, you can create application with support NoSQL. It provides a high-grade security system, has high availability and low latency. Now this is usually used in situations where you have a diverse and highly unpredictable workload. Now let's have a look at some security and identity services. Firstly, we have the Azure Active Directory. Now if you want to know more about Azure Active Directory, I suggest you click on the top right corner and watch our video on the Azure Active Directory. This is just an introduction. So with this, you can manage user identities and you can make sure the resources are kept safe with the help of access policies. Most of these are intelligence driven. Now, one of the main features is that you can have access to your applications from any location or device. It helps increase your efficiency and helps down cutting costs when it comes to having a help desk. It can also help improve security and can respond to advanced threats in real time. Next, you have Azure Active Directory B2C. It helps provide customer identity and access management in the cloud. Now, protecting customer identity is extremely important for an organization, and that's what Azure AD B2C does. Now, it also enables the application to be scaled to great amounts, even billions of customers. Next, we have the Azure Security Center. This is basically like a command post with which you get a complete view of the security across users on your on-premises and cloud workloads. So with this, you are given a threat protection method that adapts to situations and helps reduce exposing you to threats. It also has rapid threat response and makes the process of finding and fixing vulnerabilities a whole lot easier. Next up, let's talk about monitoring and management services. So first, let's have a look at Azure Advisor. Now, Azure Advisor is basically a guide for the best practices when it comes to Azure. Now, when you follow these, it improves performance, security, cost, and increases availability. Now, it also learns from how you use the services on your configuration and usage pattern, and the adjustments that it suggests can be implemented very quickly and easily. Next, we have Network Watcher. Now, with this, you can monitor, diagnose, and understand the working of your network. Now, you can monitor your network without actually having to log in to your virtual machine. Now, you can also use something known as network security flow logs to understand the traffic pattern, how much traffic is coming towards you, how much you're giving, and so much more. It also helps diagnose VPN problems that you might have with detailed logs. And finally, you have the Azure Resource Manager. Now, with this, you can ensure that the resources that you have are managed and deployed at a consistent rate. Now, this makes it extremely easy for you to manage and visualize your resources that are used in your applications or some other requirements, and you can control who can access your resources as well as perform actions on it. And now, let's have a look at how we can use one of these services to satisfy a particular requirement. So the friend asks that she needs one last bit of help. She wants her friend's help to host a website on Azure, and here's how we can do it. So now we're going to put one of these services into action. So this is the Azure dashboard. So from here, we are going to create a virtual machine within which we are going to create a website. A very simple HTML website nonetheless. So let's get started. So first what we're going to do is create a resource group. So what a resource group is actually a repository of all the resources like virtual machines or storage that you're going to use in your project. So in this we need a virtual machine, so let's get that created. So first we'll name it demo East US and we'll create it. Now this will take a few seconds and that's it. So now that that's done, we go on add. So we're going to be using a Windows operating system, so we'll just search for virtual machine. We select this and create. Okay, so here we're going to select the resource group, the one that we just created, a virtual machine name. Okay, this storage and name. Passwords, and then just breeze through the rest of it. We can reduce the size, we don't need it this big. And create. Now that the validation is done, the next step is to create. Now this will take a few minutes, so we'll wait. And as you can see here, the virtual machine has been created. We'll go to resource. So here all we need to do is connect and download the RDP file. Let's see if we run this file and see what happens. Now this error shows up in a whole lot of systems that I've used. So there's a very easy way to troubleshoot this problem. So here's what you need to do. Now, so these are the problems. As remote access to the server is not enabled, the remote computer is turned off, the remote computer is not available on the network. So what we're going to do is go to networking and add an inbound port rule. Now we're trying to access a computer remotely, right? So to remotely access the computer, we would need to add an inbound port rule. So that's what we're going to do right now. So we can keep the source as any, port range as any, and our destination port as 3389. If you've noticed there, we'd actually have used the 3389 as the inbound port. And then we change the name as 3389. And this rule is added. Now after this is done, all we need to do, you can see here that if you refresh the page, this would be here. A new rule has been added now, so we'll go to overview and try to connect again. Do the same thing again. And this time it worked. So here we'll input the name and our password. And that's it. Now we just press yes. And there you go. The system has started. Now your virtual machine is started. Now in a while, the server manager will pop up. So there's some things that we need to do so that we can host the website. So the first thing is to create an inbound port. So we'll turn off the virtual machine for now. Come back to that later. First we'll go to our resource group. Check the name of our resource. And then we'll look at all its resources here. So here we need to find the network security group and add an inbound security rule. Press add. We take any source port range, and then we add port 80, which is the one that we're going to use, and we'll put the name as port 80. We'll add the security rule. It will take a few seconds, and that's that. Now it's allowed. Now let's go back to our virtual machine. Here you go. And let's get it started. Log in again. And there you have it. It's on again. Now we'll go to Server Manager. So we need to add roles and features. So most of this we can just run through. We'll leave them at the default values. Same. And here we need to add a web server, which is the IIS. So we'll select this. We add the features. Next. So we can add the .NET 3.5 features as well. Next. And we'll install now. Now we'll wait for the installation to finish. And now the installation is done. So now what we're going to see is if the website can be reached. Now we'll go to the public address which is given here. So we've come back to our original system. Click. And you can see that the IIS page has been created. Now we need to work more to create the HTML page. Here's what we'll need to do to run our website. So right now what we're getting is this, the IIS page. Now let's make it our own HTML page, a very simple HTML page. From there on we can create the website. So we go back to the virtual machine and then we go to C drive. So the IIS is located in a location which is in C drive, init and www root. So if you click on this, actually what you'll get is the page I showed you earlier, which is this one. So now we'll go to the server manager, click on tools and find the IIS manager. So we click on this and sites. Now there's a default website. We can now add a new one. The site name, demo. We need a physical path. We'll put it inside the folder we just saw, which is right here, C drive, init www root, within which we'll create a new folder, for Simplilearn demo. We save it and port 80 and okay. Now this is assigned to another site, so we'll change that, but we'll wait for that. Okay. Now for this, we'll just change it. We'll click on this. So since both of them have the same port, we'll change that. Go here, edit binding. We change this to something else. Okay, and close. So now both are different, and now we can start our website. It's already started now. Now we'll start the website. Right click this, so manage website, and start. And that's it. Now we will go to the init pub, www.root, and we have Simplilearn demo. So here we will create the HTML website, or the document. So index.html. Okay. Open this. It's a very simple website now, so we keep it, save it. And so here, what we're going to do is save as an HTML file, but for all files. We close this. Now to make sure this is recognized as a .html file, we'll go to View, Options. Here we'll hide extensions for known file types. We'll just rename this. And there you have it. It's a .html file. Now let's go back to our original computer and run this page. And there you have it. Now this is just the initial version. More work has to be done on it, but your first step is already done. Hi guys, I'm Rahul from Simplilearn, and today I'd like to welcome you all to the greatest debate of the century. Today, I'm joined by two giants of the cloud computing industry. They'll be going head to head with each other to decide who amongst them is better. It's going to be one hell of a fight. Now, let's meet our candidates. On my left, we have AWS, who's voiced by Apeksha.
Hi guys.
And on my right, we have Microsoft Azure, who's voiced by Anjali.
Hey there.
So today, we'll be deciding who's better on the basis of their origin and the features they provide, their performance in the present day, and comparing them on the basis of pricing, market share and options, free tier, and instance configuration. Now, let's listen to their opening statements. Let's start with AWS.
Launched in 2006, AWS is one of the most commonly used cloud computing platforms across the world. Companies like Adobe, Netflix, Airbnb, HTC, Pinterest, and Spotify have put their faith in AWS for their proper functioning. It also dominates the cloud computing domain with almost 40% of the entire market share. So far, nobody's even gotten close to beating that number. AWS also provides a wide range of services that covers a great number of domains. Domains like compute, networking, storage, migration, and so much more.
Now, let's see what Azure has to say about that.
Azure was launched in 2010 and is trusted by almost 80% of all Fortune 500 companies. The best of the best companies in the world choose to work only with Azure. Azure also provides its services to more regions than any other cloud service provider in the world. Azure covers 42 regions already, and 12 more are being planned to be made. Azure also provides more than 100 services spanning a variety of domains.
Now that the opening statements are done, let's have a look at the current market status of each of our competitors. This is the performance round. Here we have the stats for the market share of AWS, Azure, and other cloud service providers. This is for the early 2018 period. Amazon Web Services takes up a whopping 40% of the market share, closely followed by Azure at 30% and other cloud services adding 30%.
This 40% indicates most organizations' clear interest in using AWS. We are number one because of our years of experience and trust we've created among our users.
Sure, you're the market leader, but we are not very far behind. Let me remind you, more than 80% of the Fortune 500 companies trust Azure with their cloud computing needs. So it's only a matter of time before Azure takes the lead.
The rest of the 30% that is in AWS or Azure accounts to the other cloud service providers like Google Cloud Platform, Rackspace, IBM SoftLayer, and so on. Now for our next round, the comparison round. First, we'll be comparing pricing. We'll be looking at the cost of a very basic instance, which is a virtual machine of 2 virtual CPUs and 8 GBs of RAM. For AWS, this will cost you approximately $0.0928 per hour. And for the same instance in Azure, it'll cost you approximately $0.096 per hour. Next up, let's compare market share and options.
As I mentioned before, AWS is the undisputed market leader when it comes to the cloud computing domain, taking up 40% of the market share. By 2020, AWS is also expected to produce twice its current revenue, which comes close to $44 billion. Not to mention, AWS is constantly expanding its already strong roster of more than 100 services to fulfill the shifting business requirements of organizations.
All that is great, really, good for you. But the research company Gartner has released a magic quadrant that you have to see. You see, the competition is now neck to neck between Azure and AWS. It's only a matter of time before Azure can increase from its 30% market share and surpass AWS. This becomes more likely considering how all companies are migrating from AWS to Azure to help satisfy their business needs. Azure is not far behind AWS when this comes to services as well. Azure's service offerings are constantly updated and improved on to help users satisfy their cloud computing requirements.
Now, let's compare AWS and Azure's free offerings.
AWS provides a significant number of its services for free, helping users get hands-on experience with the platform, products, and services. The free tier services fall under 2 categories: services that will remain free forever and the others that are valid only for 1 year. The always free category offers more than 20 services, for example Amazon SNS, SQS, CloudWatch, etc. And the valid for a year category offers approximately 20 services, for example Amazon S3, EC2, Elasticache, etc. Both types of services have limits on their usage, for example storage, number of requests, compute time, etc. But users are only charged for using services that fall under the valid for a year category after a year of their usage.
Azure provides a free tier as well. It also provides services that belong to the categories of free for a year and always free. There are about 25 plus always free services provided by Azure. These include App Service, Functions, Container Service, Active Directory, and lots more. And as of the valid for a year, there are 8 services offered. There's Linux or Windows virtual machines, blob storage, SQL database, and few more. Azure also provides the users with credits of $200 to access all their services for 30 days. Now this is a unique feature that Azure provides, where its users can use their credits to utilize any service of a choice for the entire month.
Now, let's compare instance configuration. The largest instance that AWS offers is that of a whopping 256 GBs of RAM and 16 virtual CPUs. The largest that Azure offers isn't very far behind either, 224 GBs of RAM and 16 virtual CPUs. And now for the final round. Now each of our contestants will be shown facts and they have to give explanations for these facts. We call it the rapid fire round. First, we have features in which AWS is good and Azure is better.
AWS does not cut down on the features it offers its users. However, it requires slightly more management on the user's part.
Azure goes slightly deeper with the services that fall under certain categories like Platform as a Service and Infrastructure as a Service.
Next, we have hybrid cloud, where AWS is good and Azure is better.
Okay, although AWS did not emphasize on hybrid cloud earlier, they are focusing more on technology now.
Azure has always emphasized on hybrid cloud and has features supporting it since the days of its inception.
For developers, AWS is better and Azure is good.
Of course it's better, because AWS supports integration with third-party applications.
Well, Azure provides access to data centers that provide a scalable architecture.
For pricing, both AWS and Azure are at the same level.
It's good for AWS because it provides a competitive and constantly decreasing pricing model.
And in the case of Azure, it provides offers that are constantly experimented upon to provide its users with the best experience.
And that's it. Our contestants have finished giving their statements. Now, let's see who won. Surprisingly, nobody. Each cloud computing platform has its own pros and cons. Choosing the right one is based entirely on your organization's requirements.
And whether you are a fresher or an IT expert with some experience, you can improve your skills in cloud computing by getting the proper training and certification. On that note, we present the postgraduate program in cloud computing by Simplilearn. The postgraduate program in cloud computing, designed in collaboration with Caltech CTME, helps you become an Azure, AWS, and GCP expert. This in-depth cloud computing certification course lets you master key architecture principles and develop the skills needed to become a cloud computing expert. Benefits of this postgraduate program include Caltech CTMA postgraduate certificate, enrollment in Simplilearn Job Assist, receive up to 30 CEUs from Caltech CTMA. Simplilearn Job Assist help you to get noticed by top hiring companies, attend masterclasses from Caltech CTMA, live virtual classes led by industry experts, hands-on project and integrated labs, online convocation by Caltech CTMA program director, 40 plus hands-on experience projects and integrated labs, caption projects in 4 domains, Caltech CTMA Circle membership. You can also fast-track your career with this cloud computing certification and its in-depth course curriculum, which covers the key concept of Azure, AWS, and GCP platform, and services such as AWS Lambda, Amazon S3, Azure App Services, and many more. These programs also cover the essential skills to become an expert in cloud computing, and you can consider these programs because it provides you with the certification from Caltech CTME, a well-reputed university in United States. So check out the link mentioned in the description box below. So without any further ado, let's get started.
Let's understand why Google Cloud Platform. So Google Cloud Platform is popular for many reasons. Now let us see few of most important reasons why it stands out. When you talk about pricing, pricing is one of the significant factors that make Google Cloud stand out among the other cloud providers. It offers a monthly pricing plan, which is billed according to monthly usage. And when we talk about billing here, the billing can be in hours, it can be in minutes, and it can also be in seconds. There are different options when you talk about your pricing, which can be found from your Google Cloud webpage. Now, pricing could be based on preemptive machines. Pricing could be based on reserved instances or reserved resources. I'll show you the link where you can find more details on pricing part of it. So Google Cloud really has various pricing options which help customers in their different requirements, whether they would go for any of the service models such as infrastructure as a service, platform as a service, or even software as a service. One more attractive thing about Google Cloud pricing is that it provides committed use discounts. For example, under this scheme, you can purchase a specific amount of virtual CPU cores and memory for up to 57% discount off regular prices if you commit usage for either 1 or 3 years. Now, this is just one option. There are various such options which you can learn about from the Google Cloud's page, and that really suits different customers for their different requirements. Now, when we talk about speed, we don't need to really challenge this aspect when it comes to Google services. So Google provides its Google Cloud and Google App customer speed up to 10 terabytes because of its faster cable system. There are different kind of machines which can be used if you're talking about computation, if you're talking about memory hungry applications, or even storage intensive workloads. All in all, speed is one of the defining characteristics of Google Cloud services. The cable has connections over US West Coast, main cities in Japan, and even major hubs in Asia. This speed enhances performances and leads to customer satisfaction. Now, when we talk about customers, any or every customer would prefer to have low latency, high throughput based services. They would want to use higher speeds to process their data in as less time as possible. Google provides a low latency network infrastructure. In fact, you can say that when you are using Google Cloud services, you are using the services from the same infrastructure which Google uses for its popular services such as Google Search or even YouTube, which is one of the second largest repository which can be accessed for videos. Now, when we talk about big data is data which is very complex, has a lot of other characteristics such as your volume, you have velocity, you have variety, you have veracity, validity, volatility, virality, and so on. So if an organization is working on big data, Google Cloud can be a better choice because Google has many innovative tools for cloud warehousing, for example, such as BigQuery, and even real-time data processing tools such as Dataflow. BigQuery is a data warehouse that allows massive processing of data at high speeds, basically working on your structured data. Google also has launched some new machine learning from artificial intelligence tools. Now, there are various other services which we can use from Google Cloud Platform. But let's understand what is Google Cloud Platform and what are some of the services. Even the services which are not listed here can be found in your console from Google Cloud. So what is Google Cloud Platform? GCP. It is a set of cloud computing services provided by Google that runs on the same infrastructure, as I mentioned, that Google uses for its end user products like YouTube, Gmail, and even Google Search. The various set of services offered by Google Cloud Platform are, so you have services which are specific to computing requirements. And again, in computing, you have various different options available. You have machines which are compute optimized, machines which are memory optimized, machines which are storage optimized, and also we have certain machines such as preemptive, which basically means that you could get a machine to work on at a far lesser price than any other machine. But when we talk about preemptive, these are the machines which can be requested on demand and they can be taken back by Google at any time. You have networking related services, which can be very useful when you are setting up your applications or your services across globe. You also have different services which are specific to machine learning, and organizations which would be interested in working on machine learning or artificial intelligence would be really interested in using these services. There are also innovative solutions to work on big data and big data related technologies. Now, when we talk about Google Cloud Platform domains, so we can break down these services into specifics, such as you have compute. Now, the compute service allows for computing and hosting the cloud. Now, when you talk about computing, here there are different services such as App Engine, you have Compute Engine, you have Kubernetes, you have Cloud Functions, and Cloud Run. When you talk about storage and database, so the storage and database service allows application to store media files, backups, or other file-like objects. Now, various services under this are as follows. You have cloud storage, cloud SQL, cloud bigtable for unstructured data. You have cloud spanner, cloud data store, persistent disks, and cloud memory store. When we talk about networking, the networking service allows us to load balance traffic across resources. Now, as I mentioned earlier, resources could be your different resources which you would be using from a cloud platform, such as your devices, your instances, memory optimized or CPU optimized instances, or other resources, creating DNS records, and much more. So various services under this are VPC, that stands for Virtual Private Cloud. You have Cloud Load Balancing, Cloud Armor, Cloud CDN. You have Cloud Interconnect, DNS, and Network Service tiers. When we talk about the Big Data Service, this allows us to process and query big data in cloud. Now, various services under these are as follows. You have BigQuery, Cloud, Cloud Data Proc, Cloud Composer, Cloud Data Lab, Cloud Data Prep, Cloud PubSub, which is publish and subscribing system. You have Cloud Data Studio. Now, you also have the developer tools. And developer tools service includes tools related to development of an application. Now, various services under these are as follows. That is, you have Cloud SDK, Software Development Kit, you have Deployment Manager, Cloud Source Repositories, and Cloud Test Lab. When we talk about identity and security, which is one of the primary concerns for any organization or any user who would be interested in using a cloud platform, Google Cloud really has taken care of this. So when you talk about identity and security domain, this deals with security services. Now, various services here are Cloud Identity. You have Identity and Access Management, that is Cloud IAM. You have Identity Aware Proxies. You have Cloud Data Loss Prevention API, Security Key Enforcement, Key Management Service, and many more. You also have cloud services which are related to Internet of Things. So very much would be used by organizations who would be working on IoT devices or the data generated by these devices. So various services here are Cloud IoT Core, you have Edge TPU, and Cloud IoT. Also, when we talk about cloud AI, that is artificial intelligence, this comprises of services related to machine learning and much more. So you have Cloud Auto ML, Cloud TPU, Cloud Machine Learning Engine, Job Discovery, Dialogflow Enterprise, Natural Language Cloud, Text to Speech, and much more. If you would be interested in services related to API platform, then there are different services under this category or this domain. So you have Maps platform, you have APG API platform, monetization, developer portal, analytics, that is API analytics, APG Sense, cloud endpoints, and service infrastructure. So these are some of the listing of services under each cloud platform domain. Now let's look at Ferrero use case, and let's also understand what was done here. So Ferrero is one of the famous chocolate and ranks third among worldwide chocolate and confectionery producers. It was found in 1946 in Italy. I'm sure you would have seen the Ferrero chocolates when you would have gone out to buy some chocolates. So the challenges here was that Ferrero, as we know, is sold in every supermarket and is known for its quality. Once the business grew, some issues arose, right? And that's what happens when the business grows. You have issues popping up, which could be related to the volume of data, the speed with which the data is getting generated, the variety of data, and also looking at your platforms which support different dynamic applications or your scalability requirements, performance requirements, and so on. So it needed data storage, processing, and analysis system for a wide customer database. There was a huge gap between the company and the people who bought its goods because the company relied on data-given sales outlets. Now that's one of the challenge. Ferrero wanted to create a digital ecosystem where there was a point of contact with its customers and also a foundation for an innovative data-driven marketing strategy. What was the solution here? So one of the service of cloud platforms or Google Cloud Platform is BigQuery. And this was an answer to Ferrero's challenges since it was capable of hyper-fast and efficient data analysis as a solution. Now, as I mentioned, BigQuery is a data warehouse which allows you to store structured data. Now, this could directly be used as a service where you could store in any amount of data and you would not be paying for storage. So there are different pricing models, and for data up to 1 terabytes, you would not be charged anything. And if you would be accessing the data, that is reading the data or processing the data from BigQuery, that's where the pricing model kicks in. Now, using Google Cloud's BigQuery, business analysts of Ferrero were able to store and analyze massive data sets in a very reliable, fast, and affordable manner. Consumer behavior and sales pattern data reports were easy to build and automate. And the analysis also followed Ferrero to adopt advertising across various marketing channels to serve the customer needs in a better way. What was the result? They could divide their database into real-time, actionable consumer clusters to generate more accurate user profiles. Ferrero was also able to personalize its marketing strategies to match the user needs. Now, Google Cloud Platform completely tailored the website, mobile content, and advertising, and created a very cost-effective media buy strategy. Now, these were some basics on Google Cloud. Now, as I said, you can always find a lot of details about pricing, about services, and also all the services are accessible in your free trial account. Now, let me just walk you through here. So one is you could always find details on documentation on each of these services. So if I would click on getting started, you have quick start, which basically shows you short tutorials. You have trainings and you have also certifications. Now, if we click on quick start, now that takes me to this page, which shows me quick starts, or if you would want to understand about different projects, if you would want to look into the documentation of creating a Linux virtual machine or storing a file and sharing it, deploying a container, Docker container image, and so on. So you have a lot of quick starts here. You can also look at Cloud Minute. On the same page, on the right side, you have docs. And once you click on that, it takes you to these links. Now this shows you build solutions, which shows you top use cases, best practices, all the solutions. It's always good to learn from these use cases which are available. And here you have different featured products and all the different services which Google Cloud offers. Now you can click on featured products, and that basically shows you a list of these products. Now here we have all the solutions which you can look at: architecture, database, enterprise level, big data and analysis, gaming related, Internet of Things, and so on. Now if you go down here, it shows you featured products, and that shows you some of the important products such as Compute Engine, which is belonging to the compute domain. You have Cloud Run, you have Anthos, which is for migration and basically cloud adoption. When organizations would want to move from on-premise to cloud-based solutions, you have Vision AI, you have cloud storage. Now that basically allows you to store any kind of data, whether that's an object. So this is acting as an object storage. You have Cloud SQL, which is basically a ready-to-use service where you would be using MySQL, Postgres, or any other SQL Server database services. You have BigQuery, which is a data warehouse, which basically allows you to store your structured data. And then you have your AI and machine learning related products. So you have AutoML, Vision AI, Video AI, text to speech, speech to text, and so on. Now you also have different platform accelerators which can be used. And in any of these cases, for example, if I would click on Compute Engine, which is a featured product from Google Cloud, now that shows you basically your quick starts using your Linux machines, how-to guides, which tells you completely working on a VM instance or working on storage, working on persistent disks, and so on. And it shows you the documentation here. Now you also have products and pricing option, which you can see for GCP pricing. And you could straight away go to the pricing. You could be looking at solutions, which talks about infrastructure modernization. Now, this is something which organizations are interested in when they would want to move from their on-premise solution to your Google Cloud. Now, here I can say, for example, I click on infrastructure modernization. You can always find some case studies. What are the different solutions we have here, right? When you talk about Google Cloud. So you can always click on See Solutions, and you can look at VM migration or SAP Cloud, right? Why Google Cloud, what it can be used for, VMware as a service, or HPC, that is high performance computing. And about these services, we will learn in detail later. Now I can go back on the same page where I was clicking on the services. So you have quick starts, you have how to guides, you have deep understanding of different concepts, right? And here, if I click on all how-to guides, so that shows me what are the different ways in which you can work with compute engine and working with different instances. Although it's quite exhaustive content, but then if you follow steadily, then you can learn a lot about Google Cloud. Now here I can just go back. So this is just giving you some idea on the different products which are available from Google Cloud, looking into different sections, finding right documentation here, right? And you can always look into each one of these in detail for each product which Google Cloud offers. Now, if we scroll down, we could see all the options or all the domains which we see here, right? Let me just go back because we got into solutions. Now we have quick starts, right? And then you can basically scroll all the way down to look at Cloud SDK, which can be set up on your Windows machine, like I have set it up on my Windows machine. Plus, when you use Google Console, you have a GUI, which I'll show you in a couple of minutes, and also a Cloud Shell where you can use your command line options to work with Google Cloud Platform. You have Cloud Console, which is nothing but your GUI to access your resources. Now, you can also look at in-depth tutorials, pricing, and you have different other options. So let's just click on pricing here. And then we have your price list, which basically gives you details of different services, what are available, and what are the services or what are the prices. So for example, if I click on compute engine, right, and this shows me the pricing aspect of compute engine, which belongs to compute domain. And here you can see you have VM instance pricing, you have networking pricing, sole tenant nodes, which are specific to particular organizations, or if organizations would want to have dedicated nodes, you have GPU based pricing, right? So general processing units, you have disk and image pricing, and you can click on any of the links and you can see pricing, which also shows you your different kind of machine types. So here you have different kind of machine types, which says N1, N2, N2D, E2. You have memory optimized machine types, you have compute optimized, you have premium images, and you can basically look at all the categories. You can look at disk pricing, which involves your persistent disk pricing for SSDs or HDDs. What are the kind of images, what are the different network services, right? And you can always look at your machine types. You can choose a particular region, right? There is the concept of region and availability zones here, and as per region you could look at the prices. You can also look at standard prices. You could be looking for what are the free tier machines. If I'm specifically looking for VM instance pricing, I can click on this one, and that takes me to the VM instance pricing. What is the billing module? What is the instance uptime? What is the resource-based pricing? And then you can also look at different kind of discounts, such as sustained use discounts, committed use discounts, discounts for preemptible VM instances, and so on. And this is how you can be looking at pricing for all different resources. And you can choose the resource which you are interested in and then look for the pricing, benchmarks, reservations if you would want to use and you would want to benefit, if you would want to look at what are the quotas and limits, and so on. So please explore this link and you can find a lot of information when it comes to technical options, looking at different Google Cloud products, which we briefly discussed when it comes to domains and what each product can be used for. You can always come back to the main page where I was showing you different services. We went into pricing straight away, right? Now you can always come back to this page on your cloud.google.com, and then you have your solutions, which talks about different products, right? And you can click on these or you can look into technical documentation. So this talks about your different featured solutions, infrastructure solutions, you have data center migration related, and so on. So I could be talking more and more about Google Cloud Platform. It's a ocean. It's a huge chunk of different services for different organizational requirements. So look into this link. And also what you can do is create a account on Gmail. I mean, you could create a free account or you could go to cloud.google.com and then you could create a free account like I have created here, and I can just click on console. Now that's my GUI, or Google Cloud Console, which basically allows me to work with Google Cloud. Now there are a lot of options here. By default, when you create an account, now in my case, on the top it says it's a free trial account. I have $300 credit, and out of that $251 is left, and 237 days out of a year are left for my account. Now here I can basically see the project, right? And by default we can create a project, or by default there is a project existing for any user. So when you log in, it creates a particular project, and you could create a new project, and project would be to dedicate your different services or different resources per different project. So this is your dashboard, which basically shows your project, which shows you a project number and a project ID, which is always unique. Now you can click on this, and this, if you would want, you can hide this information. You can also look into the documentation part of it. Then it shows you the different services or a graphical information of services which you might have used in past. So you have compute engine, which shows you how much percentage of CPU was used. You can always go to compute engine as a service. You can look at your Google Cloud Platform status and look at the Google Cloud status. Now this is billing. Now since this shows me the billing period for April month, and I can always look at detailed charges. I can look at reporting. I can look at different APIs which Google offers. And for your different kind of work, you can always go to the API overview or the API link and enable or disable any API. Now, once you enable or disable any API, then you can use that. So you have news section, you have documentation, and you have getting started guides, which tells you how to work or enable different APIs. If you would want to deploy a pre-built solution, add dynamic logging, monitoring errors, deploying a Hello World app, and so on. Now this is your dashboard. I can click on activity, and that would show me what kind of activity I would have done in my cloud platform. I can always choose the kind of activities by saying activity type. I can choose the resources. Now it shows me that I created some VM instances, I deleted them, I updated some metadata, I basically worked on instances, I changed some firewall rules here. I have then also worked on some other services or APIs. So I created some buckets, which is for object storage. And again, I have been working with some instances and creating some firewall rules. Here, I have granted some permissions. I am setting up a policy, right? So this activity gives me a history of what things I have done over the past couple of months while working on Google Cloud Platform. Now, on the top left corner, you have the hamburger menu, which you can click on this. So that's your navigation menu. And when you click on this, this shows you home. It takes you to the marketplace. It specifically takes you to billing. You can always look at APIs and services. So here in API services, I can pretty much go to a dashboard and I can see a report on the traffic or errors or latency and the kind of APIs which are available. So you have Compute Engine API, you have BigQuery API, BigQuery Data Transfer API, BigQuery Storage, Cloud Data Proc. So these are some of the APIs or services I've used in past. Might be I was evaluating a product, might be I was using a particular product. So you have, whenever you would want to use a particular service from Google Cloud Platform, you would be enabling these APIs. So here we see some APIs for data proc. You have logging, monitoring, you have resource manager API, you have cloud SQL, which allows you to directly use MySQL or Postgres, you have cloud storage, right? And so many APIs. So if I would want to enable a particular API, which is not right now required, but then it's good to know, you can always click on this one. You can search for an API. So for example, if I would say data proc, right? And that shows me the cloud data proc API, which manages Hadoop based clusters and jobs on Google Cloud Platform. So I can spin up a Hadoop cluster and I can start running some jobs on a Hadoop cluster on demand. And as I'm done with it, I can just get rid of it. So this is an API which I would have to enable. And then for every particular service, you also have an admin API which you would enable. Now going back, so coming out from this API library, I got into API and services. Now you can look into the library, you can look at credentials, and you can also look at different time intervals for which you can see the usage of your different APIs. Now going back to the menu, you have support, wherein you can always reach out to the Google support team if you are using a paid version. Even with free trial, you can try to reach out and you will find someone to help, but it is always good when you have a billing cycle reaching out the customer care. You have identity access management and admin, and this is required when you're working with different APIs or services, when you would want to have relevant access. You have getting started, you have security related options, you have Anthos, which is mainly for migration. Now here you can look at your different domains, such as which we discussed. So you have compute, and in compute you have different services. So you have App Engine, you have Compute Engine, Kubernetes, you have Cloud Functions and Cloud Run. You can look into the storage aspect, which shows you Bigtable, which is usually and mainly for your unstructured data. Bigtable, which is something which gave rise to popular NoSQL databases like HBase and Cassandra. You have Data Store, which can be used. You have Firestore, File Store, Storage, which can be used to put in data of any kinds. You have SQL for structured data. You have Spanner as a service. You have Memory Store, and you have Data Transfer. Now, when it comes to the networking domain, you have all these services such as VPC, Virtual Private Network, network related services for your load balancing, for using a cloud-based DNS or cloud-defined network. You have hybrid connectivity, network service tiers, security, and intelligence. Then you have other options for your operations which can be used. And here you have different other tools which can be used, such as Cloud Build. You have Cloud Tasks, Container Registry, Deployment Manager, and many more. Big data specific, you have the services here. So you have Dataproc, which can be used to spin up your clusters. You have publish subscribe messaging systems such as now Kafka, which you might have heard of, originates its idea from here. So PubSub, you have Dataflow, you have IoT Core, BigQuery, which is a data warehouse package or data warehousing solution from Google Cloud. Now, then you have your artificial intelligence related services and other Google solutions. So you can always find a huge list of services, or you can say at high level solutions offered by Google Cloud. And we can use these to basically test some of the solutions, use them, and work on them. So I'll give you a quick demo on different services which can be used here from your Google Cloud platform. Now this is your Google Cloud platform and this is your console. Now this also gives you a Cloud Shell which can be activated so that you can work from command line, and you can always find a lot of documentation on that. So you can also set up your Cloud Shell, that is SDK, on your Windows machine. And if you have set it up, then basically you could be doing something like gcloud, right? If the cloud has been set up. So in my case, I had set up the Cloud SDK, and basically I can get into that by looking at what path I have set up. So Cloud SDK, and then I can be using it from my Windows machine as per my comfort. I can also activate the Cloud Shell here, which will basically open up a terminal, and at any point of time you can open up this one Cloud Shell in a different window. It is preparing the Cloud Shell, where it will by default set up your project. It will set up the metadata, and now I am logged into my Google Cloud account from command line, and here I can basically use gcloud, right? And that basically shows you the different options which are available, which you can be using. So if you would want to use a particular service, you can also try giving a help, and that shows you how do you manage your Google Cloud platform, right? So you have different options for billing, to work with your different services, and basically you could be working on Google Cloud using this Cloud Shell from your command line. Usually for people who are learning Google Cloud in the beginning, it is always good to go for console and use your different services from here in an easier way. But as I said, you can always use the command line. For example, if I would just go ahead and type gcloud create instances, and that will directly take me to the Cloud Console documentation, which shows you different options which you can use to work with instances. So I could do a gcloud compute instances create, and then I can give my instance name and so on. And I'll show you some examples on that. So you can be using your Cloud Console, right? That is your Cloud Shell, and you can straight away start working from command line. However, I would suggest using console in the beginning, and when you are well experienced, then you can start using Cloud Shell to do things from command line. And when you are fully experienced, you can always switch, and certain things are usually useful or easier when done from command line, and some are easier when you do it from the console. And you can use any one of these options. Now we can go to Google Cloud Console. Now, as of now, I can close this one. I still have my Cloud Shell open. If I would want to look into it, I can click on this one and I can straight away go to Compute Engine, where I would want to work on creating some instances on Google Cloud Platform using the Compute Engine service, and then basically connecting to those instances and basically trying out some basic things. So you can click on VM instances, and then once this comes up, I can always create some instances. Now if you see here, I have some instances already created, right? And I can continue working on those. I can create new instances. I can use different options while creating instances, and I'll show you that in a demo in quick seconds. So let's have a quick demo on setting up GCP instances. Now before that, let's have a quick recap. So when you talk about instance or a virtual machine, it is hosted on Google's infrastructure, right? And you can create your Google Cloud instance using this Google Cloud Console. That is by clicking on this and then going to Compute Engine and clicking on VM instances. Now you can also do that from Google Cloud command line tool, that is Cloud Shell, and you can be doing that using Compute Engine API. So Compute Engine instances can run the public images for Linux or Windows servers that Google provides. You also have option of creating or using custom images that you can create and import from your existing systems. You can deploy Docker containers which are automatically launched on instance running containers, optimized OS. Now, when you talk about instances and projects, always remember that each instance belongs to a Google Cloud Console project, and a project can have one or more instances. When you talk about instances and storage options, each instance has a small boot persistent disk, which I will show you in further screens, that contains the OS. You can add more storage space if needed. And when you talk about instances and network, a project can have up to 5 VPC networks. So VPC network is virtual private networks, wherein you can virtual private cloud networks, where you can have your resources within your own subnet. And each instance belongs to one VPC network. Now, instances in same network can communicate with each other through local area network protocol. An instance uses internet to communicate within any machine. So that could be virtual, physical, or outside its own network. When you talk about instances and containers, you should remember that Compute Engine instances support a declarative method for launching your application using containers. Now you can create a VM instance or a VM instance template. You can provide a Docker image and launch the configuration. So there are different ways in which you can create these instances. And once you create these instances, you can say, for example, you're creating a Linux instance. You can associate SSH keys with your Google account or your G Suite account, and then manage your admin, non-admin access to the instance using IAM roles. If you connect to your instance using gcloud or SSH from console, which we will see later, Compute Engine can generate SSH keys for you and apply that to your Google Cloud or G Suite account. Now, what we can do is we can see how we can create your Google Cloud instances from your console or from the command line. Let's have a look in creating instances using GCP console. Now that we have learned on some basics of Google Cloud Platform, what are the different services, what are different domains, basically looking at your Google Cloud Console or even Cloud Shell, let's go ahead and create some VM instances. Now that's from your Compute Engine service, and let's try connecting to these instances and see how this works. Let's also see what are the different options which are available when you would want to create the virtual machine instances here. So when you click on your drop down from the top left and choose Compute Engine, so it brings you to this page. So I can show that again. So you can click on Compute Engine, click on VM instances, and that basically brings you to this page. Now here it tells you Compute Engine lets you use virtual machines that run on Google's infrastructure. So we can create micro VMs or large instances running different distributions of Linux or Windows using standard images, that is public images, and you can also have your own image. So let's create a VM instance by clicking on create. Now that's basically helping me to create an instance here. So it shows me the instance name. I can give it something. So let me say C1. Now I can add labels. So what is label? It basically allows you to organize your project, add arbitrary labels as key value pairs to your resources. This is basically categorizing your labels in projects if you have multiple projects. Now remember, if you have your Cloud Console and if you have created your free trial account, it will allow you to do these things. If not, you may have to go back to the billing section and see if the billing is enabled. Which also means that when you are creating your Google Cloud account, it will ask you to key in your credit card details, but they do not charge anything, or they might be $1 or 1 rupee depending on your location, and that's also refunded, but that's just to verify your card. Now, once I've given the name, I can choose a region. So I would basically choose Europe. Since I'm in Europe, I would be clicking on Europe West 3, and here I can choose an availability zone. Availability zone is basically to make your services or instances or any other resources highly available. So you can choose one of the availability zones. Now I would choose say West 3. Now this one, we can scroll down and here it says machine configurations. You have general purpose machines, you have memory optimized machines, which is M1 series, and you can always go back to the Google Cloud page and see what a particular kind of machine specializes in. So I would click on general purpose, and in general purpose you have different categories. So you have N1, which is powered by Intel Skylake CPU platform, or you have E2, which is CPU platform selection based on availability. So let's have N1 selected. Now this one shows me the machine type, and if you are using your free tier account, then you can start with correcting a micro machine, which is 1 virtual CPU core. You can go for a G1 small, which is 1 virtual CPU core and 1.7 GB RAM. You can even go up to a high-end machine, and then you can basically see if you're using a free account how many of these machines you can use. If I would be selecting 8 virtual CPU cores and 32 gigabyte of memory, then it would allow me to create at least 2 instances by this configuration. We will use N1 standard, which is 1 virtual CPU core, 3.75 GB memory. Now, then we can also deploy a container image to this VM instance. If you would be interested in deploying a container image, let's not get into that right now. Here it shows you the boot disk and it shows you Debian GNU 9 Linux 9. What I would do is I can go for this distribution, or I can choose a Linux distribution of my choice. So here you have public images, you have custom images, you also have snapshots if you have created backup of your previous images. Here I can choose, for example, Ubuntu, and then I can choose a particular version. So let's go for Ubuntu 18.04. You can go for the latest one also. 18.04 would be good enough. And here it tells me what is the boot disk. So you have SSDs or you have standard persistent disks. Now SSDs are little expensive in comparison to your standard persistent disks or your SSDs, but then SSDs are faster. So as of now, we can choose standard persistent disk as it is, and we can let the gigabyte be 10. Now depending on your requirement, you can increase this. You can even add disks later. That's not a problem. Click on select. Now here I have access scopes. So here I will say allow default access. You can also set access for each API, or you can give full access to all cloud APIs. So that based on your requirement, you can anytime change later also. We will also say allow HTTP traffic, and we can also choose allow HTTPS traffic. That basically allows me to access this machine or services which are HTTP based accessible from this machine. Now I can just click on create. However, it would be good to basically enable connectivity to this machine. Now we can do that in different ways. One is when you bring up your machine, it will have an SSH access which you can log in from the cloud platform here itself. Or what you can do is you can create a private and a public key using some softwares like Putty or PuttyGen. So for example, if you do not have that on your machine, you can just type in download Putty. That takes you to the putty.org page, and here you can click on download Putty and scroll down, which shows you for your 64-bit machine, which I have in my case. You can download putty.exe, which is basically your SSH and Telnet client to connect to your machines. You can also use PuttyGen, which will be allowing you to create a private and a public key, which I have done in my case. Let me show you how. So what you can do is you can go to PuttyGen to begin with, and here you can click on generate. Now then, to have this key generated, just move your cursor on the top here in the empty space, and that creates your key. You can give it a name. So for example, let's give a username. I would give HDU. Now I can give a password for this one. So let me give a simple password. And what I can also do is I can copy this public key from here, and for my later usage, I can just keep it in my notepad file, which I can use later, and I'll show you when. So now we can save this private key, and this will basically allow me to save my private key. I can choose desktop and I can give it a name. So let's say new key, and that will be getting saved in a .ppk file. So let's save it, and that's done. So we also have our public key and we have saved our private key. Now we know that when you would want to connect using SSH, you need your private keys to the client, and public key also has to be existing. So let's take this public key. So let's do a Control A. I'm going to copy this, and I'm going to come back to my Google Cloud Console, and here you can click on security. So you can click on the security tab here, scroll down, and just give your public key. Once you give that, it resolves and shows you the name, and this is good enough so that I can use my SSH client to connect to this machine. I can click on create, and this will basically create my VM instance. It will take some time, and then your instance will have an internal IP which will show up here, external IP, and it will also show you options to connect to these machines. So this is my internal IP, this is my external IP, which I can use to connect from a client. I can easily connect from the option here which says SSH, and I can say open in a browser window. I can even open this in a custom port. I can look at the gcloud command, which you can give from Cloud Shell, or you can use another SSH. So let's first do a open in browser window, and let's see if this connects. So we can easily connect to our instance, the Ubuntu 18 instance, which I just set up here easily in a couple of seconds. Now this is trying to establish a connection using your SSH keys. And when you do that, it also basically brings up this web browser. So I'm already connected. It shows my username, which is my cloud account username, and I have been connected to this machine here using SSH. It did not ask me for any password, and basically now I can just check what do I have in my Linux file system, right? And I can anytime log in as root by doing a sudo su. For example, let's try installing a package, and I can say apt-get install vim, or apt-get install wget, or apt-get install open ssh, and all these packages are already existing, so not an issue. Now I can start using this instance. I can just look at the disk, what is available. Okay, now we gave around 10 gigabyte, out of which we see 8.3 gigabyte here for the dev SDA1, and then 1.8 gigabyte available, and you can continue using this machine. This was the easiest way of connecting to a VM instance using SSH. Now what we can also do is I can just leave this, and I will now try to connect using an external SSH client, right? And here you can copy the public IP. So when you want to connect to an instance, you will have to get the public IP. Also remember that if you select and stop this machine, which will stop your billing counter, and if you start it again, the internal IP will remain same, but the external IP is the one which will change. I can obviously select this machine anytime, and I can do a cleanup and I can delete it. I can do a start of the machine if it is stopped, and I can even import the virtual machine to be used later. So there are different options which you can always use. So this is my instance, and if you would want to look at the details, click on this one, C1, and that should basically allow you to look at the details. So it shows you what is the instance ID, what is the machine type, is it reservation specific, what is the CPU platform, what's the zone, and all the other details. At any point of time, if you would want to edit, you can always click on edit, and you can change the details as you need. Now you can also look at the equivalent REST command to basically use the REST API to connect to this instance. For now, I have copied the public IP, and I would want to connect it using PuTTY. So let's go in here, and let's give it the host name. So I can give Ubuntu, I can give my IP address. So that's in my session. Now I will click on SSH. I would go into authentication. I'll click on browse, and this is where I need to choose the PPK file. So this is the one which we created, new key. Let's select this, and then I can come back to session. I can even save this, and I can call it as my instance 1. Let's save it, and you can create any number of instances. So you see, I have created different instances here for my Google Cloud or Amazon related instances, and I can click on open. It says the server's host key is not cached in the registry. That's fine. Just click on yes. And basically it says no authentication method supported. Now this could be because we have not enabled your SSH access. So let's look at that. So now let's see if we were trying to connect using PuTTY, what was the issue here. So if I go back to my PuTTY, select my instance, load it, it says port 22. I'm giving the username, which is Ubuntu, or sorry, that's the wrong username we gave, and that might be the reason. We had set up the user as SDU. So let's save this again, and now let's try connecting to this one, and it asks for my password, and you are able to connect this. Right now, if there was any other issue related to network connectivity, then we could look at the rules, the inbound and outbound rules, which allow us to look into the machine. Now we are connected to our machine here using HDU user. I can log in as root, and I can continue working. So not only from the SSH within the cloud console, but you can use an external SSH client and connect to your machine. So this is your Ubuntu machine, and we can basically look at the space, and that basically confirms we are connecting to the same machine, which shows 8.3 gigabytes here and 1.8 gigabytes here, which we were seeing from the SSH in the browser. Now let's close this, and let's go back to our instance page. Now here you can always look at the network details, And this will show you your different kind of rules, that is ingress or egress rules, which basically allows to connect to this machine from an external network or for this machine to connect to an external network. So here we have different firewall rules, which shows default allow HTTP, that's your ingress rule, and it tells you apply to all. It shows me what are the IP ranges where I can specifically give the IP of my machine. It shows the protocols. It shows what are the different ports which you have used for these services. For example, RDP or SSH, which shows 22. You have ICMP, HTTP and HTTPS. Now, anytime if you would want to make a change to these rules, that can be done by going into your network details and say, for example, you would want to work on firewall rules. So we have these firewall rules here. You can click on this one. So right now we are looking into the network domain and we are looking into VPC network, right? And this shows me what are the different rules we have. Now, if I would want to create a different firewall rule for a different protocol, I can always click on create firewall rule. I can give it a name. Okay, I can say what if you would want to turn on the firewall logs. You can basically say what is the kind of traffic. So ingress applies to incoming traffic and egress applies to outgoing traffic. And you can then basically choose what are the IP ranges from where you want that connection to be coming in or to going out. You can choose a particular protocol. You can give a protocol here with comma separated values and you can create a firewall rule. So this might be required depending on the services which you are running, wherein you might want to enable your access to your machine from an external service or to an external service. So you can always go to network details. From here you can then go into firewall rules, create a firewall rule, apply that to your instance and restart your instance. So as of now, we don't need to create any network details here because my ingress or egress rules are already available, right? Now I can basically then have my instance stopped and removed. So I can just do a stop, or since this is running, the ideal way would be to do a stop. I could also do a reset. Now what does reset do? Reset does not basically delete the machine. What it does is it does a cleanup of the machine and it brings it to the initial state. So sometimes we might have installed certain things on our machine. We would want to clean them up, and at that time reset can be useful. I can basically click on delete, right? And I can select this and I can do a cleanup. And this is good always when you are using a free trial account. Try to use different services, play around with them, and then you can clean up so that you do not waste your free billing credit, right? And you can use it for meaningful stuff. Now I have clicked on delete, and within few seconds my instance which I had created will be deleted. Also to remember is if you are creating multiple instances, then you can connect from one machine to other machine using SSH by using the private file. So for that we can learn in detail later. So this is just a simple example of using your compute engine, creating your instances, connecting to it from an internal SSH or from an external SSH client such as PuTTY, where you have already created your private and public keys. Now I can click on the browser here and then I can basically come out and I can basically be looking into any particular service. So we just looked into compute engine, right? You have different other options. You have instance groups, you have instance templates. For example, let's click on instance templates here. And that basically shows you that you don't have any instance template. And this basically facilitates, say for example, you are working as an admin and you would want to create an instance template so that using that, you can describe a VM instance and then you can basically use this template to create different instances. You can go for sole tenant nodes. You can look for machine images. You can also look at your disks. You can create a snapshots and you can look at different options here. Now let's come back here and let's click on home, and that should take you back to your home page, which basically shows you if a particular API which you have used recently, which shows me in the graph here. So I can go to the API's overview, right? And that basically shows me if there were any errors, if I was using the Compute Engine API to basically create a VM instance, and that's why we were seeing some spike in the graph. So this is a quick demo of using your Compute Engine service provided by Google Cloud, wherein you can create VM instances and use those VM instances for your application installation, for any other purpose. Now that we have seen how you use your Cloud Console to create an instance and also clean it up, let's also understand how you can do using your command line options, and let's see what it takes or what are the different commands which you can use to create your instances. Now you can always, when you're creating an instance, you can use Compute Engine, which provisions resources to start the instance. So instance basically has different states which we can see when we are creating the instance. So you basically start the instance moves into staging, that is prepared for your first boot. Finally, it boots up and then it moves into running. So when you look at instance states, which we will create instance and see, it will basically have different states such as provisioning, where resources are being allocated for instance, but instance is not yet running. Then it goes into staging, where resources have been acquired and instance is being prepared for your first boot. Then instance is booting up and running, and if you are stopping an instance, it goes into being stop status and it would be moved to the terminated option. You can also do a repairing of instance, and finally you can terminate your instance or clean it up by stopping and then deleting it. Now, when you say stopping and resetting an instance, you can stop the instance as I showed earlier if you no longer need it. But if you need for future use, you can just use the reset option, which will basically wipe the contents of instance or any application state. And then finally, you can stop it and have it terminated. Now, when you would want to do that using your Cloud Console, we have seen the options. Now, let's also see from the command line tool how you can do it. So here I have the Cloud Shell, which I brought up from here, and I basically opened it in a new window. So command line tool enables you to easily manage your Compute Engine resources in a friendlier format than using your Compute Engine API. Now, gcloud, which is part of Cloud SDK, is the main command here, and then you can always autocomplete the different options here. So when you would want to create or work on gcloud, you can just type in gcloud here, and then, for example, I could just say help to see different options of gcloud, which will show me different options which you can use here. Now we would be interested in compute instances, so I could also do a gcloud compute instances, and then I can basically say create, and then I can do a help. Now that should show me different options which work with gcloud compute instances create command, which is expecting an instance name. So your Google Cloud SDK, which we can set up on our Windows machine or even on your Linux machine, is set of tools that helps you to manage resources and applications hosted on your GCP, that is your Google Cloud Platform. Now here you have options such as gcloud, which I'm showing you right now. You have gsutil, and then you have bq, so that also can be used. So you can set up a Google Cloud Compute if using gcloud. Now what we can do is, if we are setting up our SDK on our Windows machine, then we would have to do a gcloud init, which basically initializes your configurations for gcloud. Now here we are using a Cloud Shell which was started from the console, and we don't have to basically give your gcloud init command because it's already initialized. Now you can always look at your default zone, you can look at your region, what is being used. All those things are coming from the metadata which is being used. So for example, I could be looking at the metadata for my particular project by just doing a gcloud, and then I can say compute, and I would be interested in project info. So I can just do a project minus info, and then I can do a describe, and then I need my project ID, so I can say minus minus project, and I can get my project ID from here. So you can click on this one, and that's my project ID. So I can click on this one, and here I can just do a right click, and if it does not paste, then you can do a control V, and then I can try to look at my project info. So this basically will give me the metadata, which is by default set, and we can always look at what are the regions or what is the zone which has been set. So if it has been set, so I'm looking at my details, it is showing me my SSH keys, and then it can be using your default region and your default available zones. It also shows my username and other details. So this is basically to look at the metadata which is available. Now at any point of time, I can basically say add metadata. I can basically choose metadata option, and I can say my default region should be Europe, which I was choosing earlier. So I can just bring up this command again, and what I can do is I can say here where I have gcloud compute project info, where I did a describe earlier. Now what I can also do is I can just say add metadata, and then I can specify what is the metadata I would be interested in adding. I can then say Google compute default region, and then I can basically give a region, for example Europe, and then I can say West 3. And if you are not well experienced, you can always do it from console, or you can be doing it from here. So I'm giving Google Compute default region. Then I can also give a Google Compute default zone, and then I can pass in a value for default zone. So I can say Europe West 3, and then basically I can give an availability zone. So if it is basically giving me some error where I'm trying to pass in these values, so I can just give it this way, and then it basically says that if you can look into particular help to see what is the command which you would have to do. Now I can basically do a gcloud init here, initial configuration, and this basically says that it is initializing my default configuration. It says reinitialize this configuration from Cloud Shell. You want to create a new configuration. So if I had updated my metadata, then basically I could just do a cloud init, and I could be reinitializing my default configuration or properties which I have passed in. So as of now, I will not activate or change the default region. Let's go for a simple way in which you can create your compute engine. So for example, I'll just say 1, and it is reinitializing. It asks me what is the username, and let's select that. It says what is the project, and let's select that. And do you want to configure a default compute region and zone, right? And I will just say yes, and basically then it shows me different options which we have here. So there are too many options here, and then here we were interested in Europe West 3, so let's choose 21, right? And then that basically allows me to choose my region and my zone. So it also gives you some specifications. So it says your project default compute zone has been set to Europe West 3A. You can change it by running gcloud config set, and you can give a compute zone, right? So I can always give these commands. I can get help information here. So I can just say gcloud config set, and I can be specifying the compute zone. So I can say compute slash zone, and I can give a zone. I can say compute slash region, and I can give a region name if I would want to do it. Or the easier way is like what I did right now. So you can basically do a command gcloud init, and then basically it allows you to change your configuration or set default things here. You can all the times you can say gcloud config unset to basically remove a compute zone or a compute region. Now, there are different ways. So if you were working on a Linux machine, you could always use an export command, something like this. So you could do a export cloud SDK, and then you can say compute underscore zone, and then give your zone name, or compute underscore region and give your region, or you could add it in your bash rc file, right? Now that is when you have your cloud SDK set up on your Linux machine or on Windows machine, and you would want to specifically set a zone and a region for all your compute related resources. So we don't need to do that. The default settings are already given here, right? And what we can do is we can start by quickly looking into gcloud compute instances options. So I can say gcloud compute instances, and then I can just do a list. At any point of time, if you would need help, you can just do a gcloud compute and then say minus minus help, or I could just do a gcloud compute, and that shows me different options which I have here from which I use instances. I can always type instances and again hit enter, and it shows me different options what you would want to do. So I can initially just type list, which should show me what are the lists or what are the instances available. And as of now, we don't have any instances. I can always do a list, and then I can specify minus minus format, and then try to get the information in a JSON format or YAML or minus minus format text. So you can always do a list, you can do a filter. So there are different options with your list, and you can try doing a help here, and that basically shows you what are the options. So for example, if I do a help and it shows me with list what are the things you can do. So you can give a name, you can give a regular expression, you can say in particular zone, you can use a minus filter. So there are different commands which are available, and you can always find all those options here as I showed you earlier. So now what we would be interested in is basically going for your compute instances. I can always do a SSH, and I can create an instance. I can add and remove metadata, right, for my instances by giving a particular zone, by giving a particular region, and if you would want to do that. Now here what we can do is we can basically create an instance by just giving a name to that particular instance, and we can then go back to our console and see what has it done. So I can say here create, so that's an option. Let's see what does the create do. So it says okay, you are giving a create option, but you would have to give a name. So let's say, let's call it E1, and that will be the name of my instance. And this one is an easy command from your Cloud Shell, which basically creates an instance. You see the zone which has been set. It is the standard machine type. It is not preemptible. It has an internal IP and it has an external IP. Now I have created an instance, and here I can just go back, and then I can just do a refresh on this page, and that already shows me the instance which I've created. And then you can use the same method to connect to it using an SSH. So I have an instance created from my Cloud Shell, and what I can do is I can basically look into instances and see what are the different options with instance. So if we did a create, right, you have an option delete. We did a create, you have an option delete. You can be then deleting the instance from the command line, or you can use other options. So you can do a list, you can do a stop, you can start. So I can basically do a stop, and let's say E1, let's go ahead and do a stop. Commands are pretty easy here to remember, or you can always use the help option. And now I'm trying to stop the instance, and then basically I can go ahead and delete it. So this is a simple way where I created a instance from the command line or from the console which I showed earlier. And similarly, you can be working with other options. So now I've created stop the instance. Let's do a listing to see if my instance shows up. It shows up, right? and it says the status is terminated. So you have stopped it. It's in the terminated status. And now what I can do is I can go ahead and delete it. So it says this will be lost. Are you sure you would want to continue? Just say yes, and that should take care of deleting your instance. So this is a quick demo on creating your instance. We have already seen how you can connect to these instances using SSH. Now that we have created instances, let's also see how to use Google Cloud's storage service, which can be used to load data or upload data. So for this, we will have to look into your Google Cloud storage options. And here you can look in cloud storage. So let's go back here on the top, which shows me different services which we have here. And let's look into storage. So this one shows me your storage option. Now you can click on browser, and that basically shows me your storage browser, which shows me on the top you have options for creating a bucket. Now Google Cloud Storage allows you to store any kind of data here. The easiest and the simplest way would be by using Cloud Console, although you can again use Cloud Shell, and in that you can use your gsutil command. And gsutil basically has different options where you can be using, say for example, I would want to work on buckets, so I can be using MB, and then I can use my command line option to create buckets. I can put in data there, I can browse it, and I can access the data from command line. So let's create a bucket here. Let's click on this. Let's give it a name. So let's say my data important. That's the name. Now I can click on continue straight away. I can look into all of these options if I'm interested in. So you can basically be looking at your monthly cost estimate in the beginning. Now I can click on continue, or you can say choose where to store your data. And this one shows you different options. So you have region specific. So let's also give the bucket name with all lowercase. That's what is required. Yeah. So coming back to the location type, you can choose multi-region, which basically allows high availability. So your bucket or your storage option will be accessible across regions. You can also give dual region and high availability and low latency across two regions. I can also say region specific. So for our use case, we can just give region specific, which can keep our cost low. But in business use cases, you would be going for multi-region. Now here you have location, and I would again go for say Europe, and let's choose Europe West 3 Frankfurt. It is always a good practice that when you create your instances, when you create your storage, or you use different services, try to have a geographical region chosen, and then you would try to put things or your services within the particular region, within a particular zone, unless you would want to make it accessible and available across regions. Now I can then choose a default storage class. So when you say default storage class, there are different storage class, and each one is for a different use case. So you have standard, which is best for short-term storage and frequently accessed data. You have nearline. So this is basically best for backups and data access less than once a month. You can also have cold line. So these are basically like your cold storage or freezing storage, which you might have heard generically as terms. So you can choose one of these storage classes depending on what will be the use case for this particular storage bucket. So let it be standard. Now how to control access to objects. So you can basically say specify access to individual objects by using object level permissions. Now you can give permissions to the bucket. You can just say uniform access to all objects in the bucket by using only bucket level permissions. So you can choose that. You can also go into advanced settings, and here you can see different ways in which you can have configuration set up. Now you can also have a retention policy to specify the minimum duration where that this bucket's object must be protected from deletion, and you can set a retention policy. We'll not get into all that. We will just first try creating a bucket. So just click on create, and that should create your bucket, wherein I have my bucket Now I can click on overview to see the details. What is the region, which region it belongs, what is the storage class. Anytime you can always click on edit bucket and make some changes here. You can look at the permissions. So bucket uses fine-grained access, allowing you to specify access to individual objects. And then you can basically look at who has access to this. So in my case, editors of the project, they basically are the bucket owners, owners of project, viewers of the project, right? And you can basically choose what kind of access you need. So for this, you can always go into cloud storage, and then you can decide what kind of access you would want to give, whether that's a storage admin, it's an object admin, object creator, object viewer, and so on. You can always look at storage legacy, and for any other services, depending on what APIs you have enabled, right? You can always control your permissions. So right now it is storage legacy bucket reader, and that's fine. And this one is bucket owner. And then might be I was using some other services like Dataproc, which uses cloud storage, and that's why I've given Dataproc service agent also. So these are some of the members you can remove. You can view by specific members, you can view by roles. So what are the different roles which have access to this? So it says storage legacy bucket owner. There are 2 owners based on this particular project. So these are auto controlled, but then you can add or remove machines. You can save storage cost by adding a lifecycle rule to delete objects after the duration of current retention policy. So you can add different policies, and you can basically control your bucket. Now my bucket is already created, right? So I can go back, and then I see my bucket is already here. I can click on this option, and you can anytime edit the bucket permissions. You can edit the labels, the default storage class. You can just go ahead and delete the bucket. You can export it to cloud pub sub. So basically, if you would want to have the content from this bucket being accessible in a message queuing system, you can go for pub sub. You can process with cloud functions, and you can scan with cloud data loss prevention. So there are different options which are available. We can always select this bucket and delete it. Now I can click on the bucket, and that basically shows me different ways in which I can upload some data here. So I can just click on upload files, and here then I can choose some files. So for example, I'll go in here, I'll go into data sets, and I have different data sets. So for example, let's choose this one, which is a CSV file, and then I'm just uploading this to my cloud storage, right? It's as simple as this. So you can drag and drop your files, or you can just upload your files, and my file is uploaded here. Now I can basically edit permissions for this one, right? So this is in the bucket. So anyone who has access to this bucket can basically download this file. They can copy, move, or rename this. You can export it, and you can look at the permissions of this file. So let's look at edit permissions, and it says for this project, whoever is the owner, it has access. I've also given a specific user, my Gmail ID, and I've given access. So at any point of time, you can just say add item, and then you can start giving different kind of accesses. So let's click on cancel here. Now my data is already uploaded into this particular bucket, and that's a simple usage of your cloud storage. Now what we can also do is I can basically select this, and I can delete it. I can also create specific folders and then basically load data into it. I can click on this one. I can just do a download, and then I can download it anywhere on my machine. So let's go to desktop, and let's download this file. So we not only uploaded some content in the bucket, but we also downloaded that in a different location, which will be accessible. Now what I could have also done is I could have created a folder here, and I could have specified, say for example, immediate data. Okay, and I'm clicking on this one. So that's my immediate data. I can click on this one, and now I can upload my data specifically to this particular folder. By using the same mechanism, you can just do upload file. Let's choose air passengers. Let's do a open, and my file will be uploaded. So you can always choose what is the retention expiry date for this one. So as of now, there is nothing, right? But you can be deleted. Objects can be deleted or modified until they reach their minimum duration. You can control all of that. You can basically download it, right? You can copy it and you can move it and rename it. So this is a simple example where I created a particular bucket, right? Now, if for example you click on this transfer, so it says cloud storage data transfer products have moved. You can now find storage transfer service, on-premise data and transfer appliance in new data transfer section, right? So you can always go back to cloud storage. You can also look at transfer options, which are mainly when you are using an on-premise service and you would want to upload data in a Google Cloud, right? So this is my bucket here. Now I can go to Cloud Console, and here what I can do is, if I would be interested in working, so I can just say gsutil, right? And then we have, for example, let's try a help, okay? And that basically shows me my gsutil. Now you can always go to quick start gsutil tool, and this is one more way wherein basically you can do it from the command line. So working with buckets, so you can do a gsutil mb -b and then on a particular zone if you would be interested in, and then you can say gs colon and give a name. So my awesome bucket, this is how you will create a bucket, which will show you it is creating a bucket. And then basically you can upload an image or some data from internet. You can just do a wget, download the file, and then you can just do a gsutil copy command, and that basically will pick up the file from your Cloud Shell location, put it in your bucket. Once you have done that, you can always do a copy, right? So here you are doing a copy from your local machine, that is your Cloud Shell machine, to your bucket, and you can do the reverse of that. That is, you can do a copy and you can point your bucket and the file and download it to your desktops. So you can just download that using the command line, and you can copy the object to a folder in the bucket. So that is by creating a particular folder, and you're pushing the file into a particular bucket. You can list the contents of a bucket using ls and then give your bucket name. So gs colon. So we can just try this one to be simple, and rest you guys can try. So here you can just do a gsutil, you can do a ls gs colon / and then I need to give my bucket name. So in my case, the bucket name was my data important. So let's try that. So let's say my data important, and I'm trying to list the bucket and the content it has, right? And then you have a folder, and then you can look into the folder and look into the files. So this is a simple, quick option wherein you can use your Cloud Shell. You could be using your Google Cloud SDK from your local machine, or you can be using Cloud Console to create a bucket, upload some data on it, download the data, see if the data is accessible, and that basically shows you the power of cloud storage, where you can easily upload any kind of data. Now, what we can also do is, as you're using a free account or even a paid account, unless and until you would want to keep the bucket, you can select it and you can just go ahead and delete it. So this will basically ask you to key in the bucket name, and let's say my data important. You need to confirm your bucket name, click on confirm, and you could have done that using gsutil and a delete command from the command line, that is from Cloud Shell. So we have now created a bucket. We have uploaded some data into it. We saw how you can download it or create a folder and upload some specific data into it. And also you can do the same thing using gsutil tools, wherein you can list your bucket, create your buckets, delete it, create some folders into it, and do everything from the command line. So this is, in simple way, you can use your GCP, where either you can spin up your machines or you can use cloud storage to basically use a storage or a easy to use instance on Google Cloud Platform.
In this video, we will compare and contrast AWS, Azure, and GCP based on a few related concepts around these cloud computing platforms. It will help us understand the functioning of these top cloud platforms and will also let us figure out the individuality of each one of them. But before starting with the comparison, let's have a quick introduction of AWS versus Azure versus GCP. So let's get started. Amazon Web Services, or AWS, is a cloud computing platform that manages and maintains hardware and infrastructure, reducing the expense and complexity of purchasing and running resources on site for businesses and individuals. These resources are available for free or for a fee per usage. Microsoft Azure is a cloud computing service that offers a collection of cloud computing services for building, testing, deploying, and managing applications in the cloud, including remotely hosted and managed versions of Microsoft technology. Google Cloud Platform offers a variety of cloud computing services for building, deploying, scaling, monitoring, and operating a cloud. The services are identical to those that power Google products, such as Google Search, Gmail, YouTube, and Google Drive. Now let's move on to the comparison between AWS, Azure, and GCP. We will be comparing them based on a few major parameters like origin, service integration, availability zone, cloud tools like compute, storage, networking, market share, pricing, and at last, who uses them. Now let's move ahead and start with the first comparison, origin. In the year 2006, Amazon Web Services, or AWS, was introduced to the market. And in the year 2010, Azure launched its services, whereas on the other hand, GCP was established in the year 2008. From the start, AWS has been supportive of the open source concept, but the open source community has a tense relationship with Azure. On the other hand, GCP, similar to AWS, provides Google Cloud with managed open source services that are tightly linked. AWS offers services on a large and complex scale that can be manipulated, but Azure's support is comparatively low quality, whereas GCP's monthly support price is almost $150 for the Silver class, which is the most basic of services and is quite expensive. Now let's move on to the service integration of these cloud platforms. Service integration is a set of tools and technology that connects different applications, systems, repositories, and data and process interchange in real time. AWS makes it simple for users to combine services such as Amazon EC2, Amazon S3, Beanstalk, and others. And on the other hand, Azure allows customers to effortlessly combine Azure VMS, Azure App Service, SQL, databases, and other services. Whereas users can utilize GCP to combine services such as compute, engine, cloud storage, and cloud SQL. Now that we know briefly about all these cloud platforms, let's have a look at the availability zones of these platforms. Because AWS was the first in the cloud domain, they have had more time to build and extend their network. But Azure and GCP both have various locations around the world. But the distinction is in the amount of availability zones they have. AWS now offers 66 availability zones, with an additional 12 on the pipeline. Close to it, Azure is available in 140 countries and is available in 54 regions throughout the world. But Google Cloud Platform is now available in 20 global areas, with 3 more on the way. Now let's move on to the next important factor, which is tools. Now let's move ahead and have a look at the first feature, which is compute. Elastic Compute Cloud, or EC2, is AWS's compute service, which offers a wide range of features, including a large number of instances, support for both Windows and Linux, high-performance computing, and more. Azure, on the other hand, as virtual machines, is Microsoft Azure's core cloud-based compute solution. It includes Linux, Windows Server, and other operating systems, as well as better security and Microsoft program integration. In comparison to its competitors, Google's computing services catalog is somewhat smaller. Compute Engine, that company's principal service, offers custom and predefined machine types, per second invoicing, Linux, and Windows support, and carbon neutral infrastructure that uses half the energy of traditional data centers. Within the compute category, Amazon's different container services are gaining prominence. It has Docker, Kubernetes, and it's also Fargate service, which automates server and cluster management when using containers, as well as other alternatives. Azure, unlike AWS, uses virtual machine scale sets of 2 container services. Azure Container Services is based on Kubernetes, and Container Service uses Docker, Hub, and Azure Container Registry for management. For enterprises interested in deploying containers, Google offers the Kubernetes engine. And it's also worth noting that Google was significantly involved in the Kubernetes project, providing an extensive knowledge in this field. Now let's move on to the next parameter of comparison, which is storage. Simple Storage Service for object storage, Elastic Block Storage for persistent block storage, and Elastic File System for file storage are among AWS's storage offerings. Block storage for REST-based object storage of unstructured data, queue storage for a large volume workload, file storage, and disk storage are among Microsoft Azure core storage services. GCP offers an increasing number of storage options. Its Unified Object Storage Service, Cloud Storage, also has a persistent disk option. Relational Database Service, or RDS, DynamoDB, NoSQL Database, Elastic In-Memory Data Store, Redshift Data Warehouse, Neptune Graph Database, and Database Migration Service are all SQL-compatible databases offered by Amazon. The database choices in Azure are specifically wide. SQL Database, MySQL Database, and PostgreSQL Database are the 3 SQL-based choices. Now, when it comes to databases, GCP offers the SQL-based Cloud SQL and Cloud Spanner, a relational database built for mission-critical workloads. Now, the next parameter is networking. AWS uses Amazon Virtual Private Cloud, or VPC. On the other hand, Azure uses Azure Virtual Network, or VNet. And GCP uses Cloud Virtual Network. Now let's move on to another factor, which is market share and pricing. All these cloud services are based on comparative pricing strategies, which means you need to pay on the basis of its usage. According to Canalys, the worldwide cloud market rose 35% to $41.8 billion in the first quarter of 2021. AWS accounts for 32% of the market, with Azure accounting for 19% and Google accounting for 7%. On one hand, Amazon charges on a yearly basis, and on the other hand, Microsoft Azure and Google services charge on a minute basis. And also, all of them provide you a standard price for you to access these services. AWS charges roughly $69 per month for a very basic instance with 2 virtual CPUs and 8 gigabytes of RAM. And AWS largest instance with 3.84 TB of RAM and 128 vCPUs will set you back roughly $3.97 per hour. But in Azure, the same type of instance, one with 2 vCPUs and 8 gigabytes of RAM, costs roughly $70 US per month. And Azure's largest instance has 3.89 TB of RAM and 128 virtual CPUs, and it costs about $6.79 per hour. Compared to AWS, GCP will supply you with the most basic instance, which includes 2 virtual CPUs and 8 gigabytes of RAM for 25% less. And as a result, it will set you back roughly $52 every month. And the largest instance that includes is 3.75 TB of RAM and 160 vCPUs, and it will cost you about $5.32 per hour. Amazon, other than this, also provides spot instances, reserved instances, and dedicated hosts where you can look for multiple offers and discounts. But for Azure, it provides special prices to developers based on situations, or even Azure Hybrid Benefit, which benefits your organization up to 40% if it uses Microsoft software in their data centers. Whereas Google offers quite assorted pricing to its customer compared to the other two. It gives you sustained use discounts, which activate if you use the same instance for a month. The printable instance, which is very similar to Amazon's spot instances, but one thing is common in all three cloud services, which is that they all offer long-term discounts. Now, let's have a look at the last comparison, which is the companies that are using them. Because AWS is the oldest player in the cloud business, it has the largest user base and community support. As a result, AWS has the largest number of high-profile and well-known clients, including Netflix, Airbnb, Unilever, BMW, Samsung, Misinga, and others. With time, Azure is getting a large number of high-profile customers. Azure currently boasts around 80% of Fortune 500 firms as customers. Johnson Controls, Polycom, Fujifilm, HP, Honeywell, Apple, and others are among its key clients. Google Cloud, on the other hand, uses the same infrastructure as Google Search and YouTube, and as a result, many high-end enterprises trust Google Cloud. HSBC, PayPal, 20th Century Fox, Bloomberg, Domino's, and other are among Google Cloud's many clients.
And whether you are a fresher or an IT expert with some experience, you can improve your skills in cloud computing by getting the proper training and certification. On that note, we present the postgraduate program in cloud computing by Simplilearn. The postgraduate program in cloud computing, designed in collaboration with Caltech CTME, helps you become an Azure, AWS, and GCP expert. This in-depth cloud computing certification course lets you master key architecture principles and develop the skills needed to become a cloud computing expert. Benefits of this postgraduate program include Caltech CTMA postgraduate certificate, enrollment in Simplilearn Job Assist, receive up to 30 CEUs from Caltech CTMA. Simplilearn Job Assist help you to get noticed by top hiring companies, attend masterclasses from Caltech CTMA, live virtual classes led by industry experts, hands-on project and integrated labs, online convocation by Caltech CTMA program director, 40 plus hands-on experience projects and integrated labs, caption projects in 4 domains, Caltech CTMA Circle membership. You can also fast-track your career with this cloud computing certification and its in-depth course curriculum, which covers the key concept of Azure, AWS, and GCP platform, and services such as AWS Lambda, Amazon S3, Azure App Services, and many more. These programs also cover the essential skills to become an expert in cloud computing, and you can consider these programs because it provides you with the certification from Caltech CTME, a well-reputed university in United States. So check out the link mentioned in the description box below. So without any further ado, let's get started.
Hey everyone, welcome to Simplilearn's YouTube channel. Today, we will be discussing the cloud computing interview questions. But before that, let me share a few facts with you. According to O'Reilly, more than 90% of the organizations are expected to increase their cloud infrastructure. In 2021, the upshot is that the majority of cloud users plan to scale their business in the cloud rather than reducing their cloud usage share. Suppose you are very much interested in cloud industry, then you have come to the right place. Welcome to this video on cloud computing interview questions. In this video, we will learn everything about AWS and Azure in detail. Our interview questions are divided into 3 segments: beginner level, intermediate level, and advanced level. By the end of this video, I can assure you that all your AWS and Azure related queries would have been answered. For this training with me, I have our experienced AWS and Azure expert Sam, who will take you through the various topics of Azure. So let's get started with an exciting video on cloud computing interview questions. Before we begin, please make sure to get subscribed to our YouTube channel and hit that bell icon to never miss an update from Simplilearn.
Hi there, I'm Samuel and I'm here to walk you through some of the AWS interview questions which we find are important. And our hope is that you would use this material in your interview preparation and be able to crack that cloud interview and step into your dream cloud job. By the way, I'm a cloud technical architect, trainer, and an interview panelist for cloud, network, and DevOps. So as you progress in watching, you're going to see that these questions are practical scenario-based questions that tests the depth of the knowledge of a person in a particular AWS product or in a particular AWS architecture. So why wait? Let's move on. All right, so in an interview, you would find yourself with a question that might ask you, define and explain the 3 basic types of cloud services and the AWS products that are built based on them. See, here, it's a very straightforward question. Just explain 3 basic types of cloud service. And when we talk about basic type of cloud service, it's compute, obviously, that's a very basic service. Storage, obviously, because you need to store your data somewhere. And networking, that actually connects a couple of other services to your application. These basic will not include monitoring. These basic will not include analytics because they are considered as optional. They are considered as advanced services. You could choose a non-cloud service or a product for monitoring and for analytics. So they're not considered as basic. So when we talk about basics, they are compute, storage, and networking. And the second part of the question says, explain some of the AWS products that are built based on them. Of course, compute EC2 is a major one. That's the major share of the compute resource. And then we have platform as a service, which is Elastic Beanstalk. And then function as a service, which is Lambda. Autoscaling and Lightsail are also part of compute services. So the compute domain, it really helps us to run any application, and the compute service helps us in managing the scaling and deployment of an application. Again, Lambda is a compute service, so the compute service also helps in running event initiated stateless applications. The next one was storage. A lot of emphasis is on storage these days because if there's one thing that grows in a network on a daily basis, that's storage. Every new day we have new data to store, process, manage. So storage is again a basic and an important cloud service. And the products that are built based on the storage services are S3, object storage, Glacier for archiving, EBS, Elastic Block Storage as a drive attachment for the EC2 instances, and EFS, file share for the EC2 instances. So the storage domain helps in the following aspects. It holds all the information that the application uses, so it's the application data. And we can also archive old data using storage, which would be Glacier, and any object files and any requirement for block storage can be met through Elastic Block Store and S3, which is again an object storage. Talking about networks, it's just not important to answer the question with the name of the services and the name of the product. It'll also be good if you could go in depth and explain how they can be used, right? So that actually proves you to be a person knowledgeable enough in that particular service or product. So talking about networking domain, VPC, networking, can't imagine networking without VPC in a cloud environment, especially in AWS cloud environment. And then we have Route 53 for domain resolution or for DNS. And then we have CloudFront, which is an edge caching service that helps customers to read their application with low latency. So networking domain helps with some of the following use cases. It controls and manages the connectivity of the AWS services within our account. And we can also pick an IP address range. If you're a network engineer or if you are somebody who works in networks or are planning to work in network, you will soon realize the importance of choosing your own IP address for easy remembering. So having an option to have your own IP address in the cloud, own range of IP address in the cloud, it really helps, really helps in cloud networking. The other question that gets asked would be the difference between the availability zone and the region. Actually, the question generally gets asked So to test how well you can actually differentiate and also correlate the availability zone and the region relationship, right? So a region is a separate geographic area like the US West 1, which represents North California, or the AP South, which represents Mumbai. So regions are a separate geographic area. On the contrary, availability zone resides inside the region. You shouldn't stop there. You should go further and explain about availability zones. And availability zones are isolated from each other, and some of the services will replicate themselves within the availability zone. So availability zone does replication within them, but regions, they don't generally do replication between them. The other question you could be asked is, what is autoscaling? What do we achieve by autoscaling? So in short, autoscaling, it helps us to automatically provision and launch new instances whenever there is an demand. It not only helps us meeting the increasing demand, it also helps in reducing the resource usage when there is low demand. So autoscaling also allows us to decrease the resources or resource capacity as per the need of that particular hour. Now, this helps business in not worrying about putting more effort in managing or continuously monitoring the server to see if they have the needed resource or not, because autoscaling is going to handle it for us. So business does not need to worry about it. And autoscaling is one big reason why people would want to go and pick a cloud service, especially an AWS service. The ability to increase and shrink based on the need of that hour. That's how powerful is autoscaling. The other question you could get asked is, what's geo-targeting in CloudFront? Now we know that CloudFront is caching, and it caches content globally in the Amazon caching service global wide. The whole point is to provide users worldwide access to the data from a very nearest server possible. That's the whole point in using or going for CloudFront. Then what do you mean by geo-targeting? Geo-targeting is showing customer and specific content. Based on language, we can customize the content. Based on what's popular in that place, we can actually customize the content. The URL is the same, but we could actually change the content a little bit. Not the whole content, otherwise it would be dynamic, but we can change the content a little bit, a specific file or a picture or a particular link in a website, and show customized content to users who will be in different parts of the globe. So how does it happen? CloudFront will detect the country where the viewers are located, and it will forward the country code to the origin server. And once the origin server gets the specialized or a specific country code, it will change the content and it will send to the caching server, and it gets cached there forever. And the user gets to view a content which is personalized for them for the country they are in. The other question you could get asked is the steps involved in using CloudFormation or creating a CloudFormation or backing up an environment with a CloudFormation template. We all know that if there is a template, we can simply run it and it provisions the environment, but there is a lot more going into it. So the first step in moving towards infrastructure as a code is to create the CloudFormation template, which as of now supports JSON and YAML file format. So first create the CloudFormation template and then save the code in an S3 bucket. S3 bucket serves as the repository for our code, and then from the CloudFormation call the file in the S3 bucket and create a stack. And now CloudFormation uses the file, reads the file, understands services that are being called, understands the order, understands how they are connected with each other. CloudFormation is actually an intelligent service. It understands the relation. Based on the code, it would understand the relationship between the different services, and it would set an order for itself and then would provision the services one after the other. Let's say a service has a dependency, and the dependent service, the other service which this service, let's say service A and B, service B is dependent on service A, let's say. CloudFormation is an intelligent service. It would provision the resource A first and then would provision resource B. what happens if we inverse the order? If we inverse the order, resource B first gets provision, and because it does not have dependency, chances that the CloudFormation's default behavior is that if something is not provisioned properly, if something is not healthy, it would roll back. Chances that the environment provisioning will roll back. So to avoid that, CloudFormation first provisions all the services that has or that's dependent by another service. So it provisions those services first and then provisions the services that has dependencies. And if you're being hired for a DevOps or if the interviewer wanted to test your skill on systems side, this definitely would be a question in his list. How do you upgrade or downgrade a system with near zero downtime? Now everybody's moving towards zero downtime or near zero downtime. All of them want their application to be highly available. So the question would be, how do you actually upgrade or downgrade a system with near zero downtime? Now we all know that I can upgrade an EC2 instance to a better EC2 instance by changing the instance type, stopping and starting. But stopping and starting is going to cause a downtime, right? So you should be answering, or you should be thinking in those terms, because that's a wrong answer. Specifically, the interviewer wants to know, how do you upgrade a system with zero downtime? So upgrading system with zero downtime, it includes launching another system parallelly with the bigger EC2 instance type with a bigger capacity, and install all that's needed. If you're going to use an AMI of the old machine, well and good. You don't have to go through installing all the updates and installing all the application. From the AMI, once you've launched it in a bigger instance, locally test the application to see if it is working. Don't put it on production yet. Test the application to see if it is working. And if the application works, we can actually swap. If your server is behind Route 53, let's say, all that you could do is go to Route 53, update the information with the new IP address of the new server, and that's going to send traffic to the new server now. So the cutover is handled. Or if you're using static IP, you can actually remove the static IP from the old machine and assign it to the new machine. That's one way of doing it. Or if you are using elastic NIC card, you can actually remove the NIC card from the old machine and attach the NIC card to the new machine. So that way we would get near zero downtime. If you're hired for an architect level, you should be worrying about cost as well, along with the technology. And this question would test how well you manage cost. So what are the tools and techniques we can use in AWS to identify and know that we are paying the correct amount for the resources that we are using? Or how do you get a visibility of your AWS resources running? One way is to check the billing. There's a place where you can check the top services that were utilized. It could be free and it could be paid service as well. Top services that can be utilized. It's actually in the dashboard of the cost management console. So that table here shows the top 5 most used services. So looking at it, you can get it. All right, so I'm using a lot of storage. I'm using a lot of EC2. Why is storage high? You can go ahead and try to justify that, and you will find if you are storing things that shouldn't be storing, and then clean it up. Why is compute capacity so high? Why is data transfer so high? So if you start thinking in those levels, you'll be able to dig in and clean up unnecessary and be able to save your bill. And there are cost explorer services available which will help you to view your usage pattern or view your spending for the past 13 months or so, and it will also forecast for the next 3 months. Now, how much will you be using if your pattern is like this? So that will actually help and will give you a visibility on how much you have spent, how much you will be spending if the trend continues. Budgets are another excellent way to control cost. You can actually set a budget. All right, this is how much I am willing to spend for this application, for this team, or for this month, for this particular resource. So you can actually put a budget mark, and anytime it exceeds, anytime it's nearing, you would get an alarm saying that, well, we're about to reach the allocated budget amount. stuff like that. That way you can go back and know, and you know that how much the bill is going to be for that month, or you can take steps to control bill amount for that particular month. So AWS Budget is another very good tool that you could use. Cost allocation tags helps in identifying which team or which resource has spent more in that particular month. Instead of looking at the bill as one list with no specifications into it and looking at it as an expenditure list, you can actually break it down and tag the expenditure to the teams with cost allocation tags. The dev team has spent so much. The production team has spent so much. The training team has spent more than the dev and the production team. Why is that? Now, you'll be able to think in those levels only if you have cost allocation tags. Now, cost allocation tags are nothing but the tags that you would put when you create a resource. So for production services, you would put as a production tag, you would create a production tag and you would associate that resources to it. And at a later point, when you actually pull up your bill, that's going to show a detailed list of this is the owner, this is the group, and this is how much they have used in the last month. And you can move forward with your investigation and encourage or stop users using more services with the cost allocation tags. The other famous question is, are there any other tools or is there any other way of accessing AWS resource other than the console? Console is GUI, right? So in other words, other than GUI, how would you use the AWS resource and how familiar are you with those tools and technologies? The other tools that are available that we can leverage and access the AWS resource are, of course, PuTTY. You can configure PuTTY to access the AWS resources, like log into an EC2 instance. An EC2 instance does not always have to be logged in through the console. You could use PuTTY to log into an EC2 instance, and like the jump box, like the proxy machine, and like the gateway machine, and from there you can actually access the rest of the resources. So this is an alternative to the console. And of course, we have the AWS CLI in any of the Linux machines or Windows machines. We can install, so that's point 2, 3 and 4. We can install AWS CLI for Linux, Windows, also for Mac. So we can install them, and from there, from your local machine, we can access, run AWS commands and access, provision, monitor the AWS resources. The other ones are, we can access the AWS resource programmatically using AWS SDK and Eclipse. So these are a bunch of options we have to use the AWS resource other than the console. If you're interviewed in a company or by a company that focuses more on security and want to use AWS native services for their security, then you would come across this question. What services can be used to create a centralized logging solution? The basic services we could use are CloudWatch logs, store them in S3, and then use Elasticsearch to visualize them, and use Kinesis to move the data from S3 to Elasticsearch. Right? So log management, it actually helps organizations to track the relationship between operational and security changes and the events that got triggered based on those logs. Instead of logging into an instance or instead of logging into the environment and checking the resources physically, I can come to a fair conclusion by just looking at the logs. Every time there's a change, the system will scream and it gets tracked in the CloudWatch, and then CloudWatch pushes it to S3. Kinesis pushes the data from S3 to Elasticsearch, and I can do a time-based filter, and I would get a fair understanding of what was going on in the environment for the past 1 hour or whatever the time window that I wanted to look at. So it helps in getting a good understanding of the infrastructure as a whole. All the logs are getting saved in one place, so all the infrastructure logs are getting saved in one place, so it's easy for me to look at it in an infrastructure perspective. So we know the services that can be used, and here are some of the services and how they actually connect to each other. It could be logs that belongs to one account. It could be logs that belongs to multiple accounts. It doesn't matter. Those three services are going to work fairly good, and they're going to inject or they're going to suck logs from the other accounts, put it in one place and help us to monitor. So as you see, you have CloudWatch here that actually tracks the metrics. You can also use CloudTrail if you want to log API calls as well, push them in an S3 bucket. So there are different types of log. Flow logs are getting captured in an instance. Application logs are getting captured from the same VPC, from a different VPC, from the same account, from a different account, and all of them are analyzed using Elasticsearch using the Kibana client. So step 1 is to deploy the ECS cluster. Step 2 is to restrict access to the ECS cluster because it's valid data. You don't want anybody to put their hands and access their data. So restrict access to the ECS dashboard. And we could use Lambda also to push the data from CloudWatch to the Elasticsearch domain. And then Kibana is actually the graphical tool that helps us to visualize the logs instead of looking at log as just statements or in a bunch of characters, a bunch of files. Kibana helps us to analyze the logs in a graphical or a chart or a bar diagram format. Again, in an interview, the interviewer is more concerned about testing your knowledge on AWS security products, especially on the logging, monitoring, event management, or incident management. Then you could have a question like this: what are the native AWS security logging capabilities? Now, most of the services have their own logging in them, have their own logging, like S3. S3 has its own login, and CloudFront has its own logging. DS has its own logging. VPC has its own logging. In addition, there are account level logins like CloudTrail and AWS config services. So there are a variety of logging options available in the AWS, like CloudTrail, config, CloudFront, Redshift logging, RDS logging, VPC flow logs, S3 object logging, S3 access logging, stuff like that. So we're going to look at two servers in specific. CloudTrail. Now this CloudTrail, the very first product in that picture we just saw, the CloudTrail provides an very high level history of the API calls for all the accounts. And with that, we can actually perform a very good security analysis of our account. And these logs are actually delivered to, you can configure it, they can be delivered to S3 for long time archivals. And based on a particular event, it can also send an email notification to us saying, hey, just got this error, thought I'll let you know, stuff like that. The other one is config service. Now, config service helps us to understand the configuration changes that happened in our environment, and we can also set up notifications based on the configuration changes. So it records the cumulative changes that are made in a short period of time. So if you want to go through the lifetime of a particular resource, what are the things that happened? What are the things it went through? They can be looked at using AWS config.
All right. The other question you could get asked is if your role includes taking care of cloud security as well. Then the other question you could get asked is the native services that Amazon provides to mitigate DDoS, which is denial of service. Now, not all companies would go with Amazon native services, but there are some companies which want to stick with Amazon native services just to save them from the headache of managing the other softwares or bringing in another tool, a third-party tool, into managing DDoS. They simply want to stick with Amazon proprietary, Amazon native services. And a lot of companies are using Amazon service to prevent DDoS, denial of service. Now, denial of service is, if you already know what denial of service is, well and good. If you do not know, then let's know it now. Denial of service is a user trying to or maliciously making attempt to access a website or an application. The user would actually create multiple sessions and he would occupy all the sessions, and he would not let legitimate users access the service. So he's in turn denying the service for the user. A quick picture review of what denial of service is. Now look at it. These users, instead of making one connection, they are making multiple connections, and there are cheap software programs available that would actually trigger connections from different computers in the internet with different MAC addresses. So everything kind of looks legitimate for the server, and it would accept those connections and it would keep the sessions open. The actual users won't be able to use them. So that's denying the service for the actual users, denial of service. All right, and distributed denial of service is generating attacks from multiple places, from a distributed
environment. So that's distributed denial of service. So the tools, the native tools that helps us to prevent the denial of service attacks in AWS is Cloud Shield and Web Access Firewall, AWS WAF. Now they are the major ones. They are designed to mitigate a denial of service. If your website is often bothered by denial of service, then we should be using AWS Shield or AWS WAF. And there are a couple of other tools that also does. When I say that also does, denial of service is not their primary job, but you could use them for denial of service. Route 53's purpose is to provide DNS. CloudFront is to provide caching. Elastic Load Balancer, ELB's work is to provide load balancing. VPC is to create an secure virtual private environment. But they also support mitigating denial of service, but not to the extent you would get in AWS Shield and AWS WAF. So AWS Shield and WAF are the primary ones, but the rest can also be used to mitigate distributed denial of service. The other tricky question is this actually will test your familiarity with the region and the services available in the region. So when you're trying to provision a service in a particular region, you're not seeing the service in that region. How do we go about fixing it, or how do we go about using the service in the cloud? It's a tricky question. And if you have not gone through such situation, you can totally blow it away. You really need to have a good understanding on regions, the services available in those regions, and what if a particular service is not available, how to go about doing it. The answer is not all services are available in all regions. Anytime Amazon announces a new service, they don't immediately publish them on all regions. They start small, and as and when the traffic increases, as and when it becomes more likable to the customers, they actually move the service to different regions. So as you see in this picture, within America, North Virginia has more services compared to Ohio or compared to North California. So within North America itself, North Virginia is the preferred one. So similarly, there are preferred regions within Europe, Middle East, and Africa, and preferred regions within Asia Pacific. So anytime you don't see a service in a particular region, chances that the service is not available in that region yet, we got to check the documentation and find the nearest region that offers that service and start using the service from that region. Now you might think, well, if I'm looking for a service in Asia, let's say in Mumbai, and if it is not available, why not simply switch to North Virginia and start using it? You could, but that's going to add more latency to your application. So that's why we need to check for application, which is check for region, which is very near to the place where you want to serve your customers, and find nearest region instead of always going back to North Virginia and deploying your application in North Virginia. Again, there's a place, there's a link in aws.com that you can go and look for services available in different region, and that's exactly what you're seeing here. And if your service is not available in a particular region, switch to the other region that provides your service, the nearest other region that provides that service, and start using service from there. With the coming up of cloud, a lot of companies have turned down their monitoring team. Instead, they want to go with the monitorings that cloud provides. Nobody wants to, or at least many people don't want to go through the hassle of, at least new startups and new companies that are thinking of having a monitoring environment, that they don't want to go with traditional NOC monitoring. Instead, they would like to leverage AWS monitorings available, because it monitors a lot of stuff, not just the availability, but it monitors a lot of stuff like failures, errors. It also triggers emails, stuff like that. So how do you actually set up a monitor to website? How do you set up a monitor to monitor the website metrics in real time in AWS? The simple way, anytime you have a question about monitoring, CloudWatch should strike your mind, because CloudWatch is meant for monitoring, is meant for collecting metrics, is meant for providing graphical representation of what's going on in a particular network at a particular point of time. So CloudWatch helps us to monitor applications, and using CloudWatch we can monitor the state changes. Not only the state changes, the auto-scaling lifecycle events. Anytime there are more services added, there is a reduction in the number of servers because of less usage. Very informative messages can be received through CloudWatch. And CloudWatch can now support
scheduled events. If you want to schedule anything, CloudWatch has an event that would schedule an action, right? Schedule a trigger, time-based, not incident-based. Anything happening and then you get an action happening that's incident-based. On the other hand, you can simply schedule few things on time-based. So that's possible with CloudWatch. So this CloudWatch integrates very well with a lot of other services like notifications for notifying the user or for notifying the administrator about it, and it can integrate well with Lambda. So to trigger an action, anytime you're designing an auto-healing environment, this CloudWatch can actually monitor and send an email if we are integrating it with SNS, Simple Notification Service. Or this CloudWatch can monitor and based on what's happening, it can trigger an event in Lambda, and that would in turn run a function till the environment comes back to normal. So CloudWatch integrates well with a lot of other AWS services. Alright, so CloudWatch has 3 statuses: green when everything is going good, yellow when the service is degraded, and red when the service is not available. Green is good, so we don't have to do anything about it. But anytime there's an yellow, the picture that we're looking at, it's actually calling a Lambda function to debug the application and to fix it. And anytime there's a red alert, it immediately notifies the owner of the application about, well, the service is down, and here is the report that I have. Here is the metrics that I've collected about the service, stuff like that. If the job role requires you to manage the servers as well, there are certain job roles which are on the system side. There are certain job roles which is development plus system side. Now you're responsible for the application and the server as well. So if that's the case, you might be tested with some basic questions like the different types of virtualization in AWS and what are the difference between them. Alright, the 3 major types of virtualization are HVM, which is hardware virtual machine. The other one is PV, para virtualization. And the third one is PV on HVM, para virtualization on hardware virtual module. Alright, the difference between them, or actually describing them, is actually the difference between them. HVM, it's actually a fully virtualized hardware. The whole hardware is virtualized and all virtual machines act separate from each other. And these VMs are booted by executing master boot record in the root block. And when we talk about para virtualization, Paragrub is actually the special boot loader which boots the PV AMIs. And when we talk about PV on HVM, it's actually the marriage between HVM and PV. And this para virtualization on HVM, in other words, PV on HVM, it actually helps operating system take advantage in storage and the network input output available through the host. Another good question is, name some of the services that are not region specific. Now, you've been taught that all services are within a region and some services are within an availability zone. For example, EC2 is within an availability zone, EBS is within an availability zone, S3 is region specific, DynamoDB is region specific, stuff like that. VPC is both availability and region specific, meaning subnets are availability zone specific and VPC is region specific, stuff like that. So you might have thought, you might have learned in that combination. But there could be some tricky questions that tests you how well you have understood the region, non-region, and availability, non-availability services. I should say there are services that are not region specific. That would be IAM. So we can't have IAM for every availability zone and for every region, which means users will have to use one username and password for one region, and anytime they switch to another region, they will have to use another username and password. That's more work, and that's not a good design as well. Authentication has to be global. So IAM is a global service, and which means it's not region specific. On the other hand, Route 53 is again a regional specific, so we can't have Route 53 for every region. Route 53 is not a region specific service. It's a global service, and it's one application. Users access from everywhere or from every part of the world, so we can't have one URL or one DNS name for each region if your application is a global application. And then web application firewall works well with CloudFront,
then CloudFront is a region-based service. So the web application firewall, it's not a region-specific service, it's a global service. And CloudFront is again a global service. Though you can cache content on a continent and country basis, it's still considered a global service, right? It's not bound to any region. So when you activate CloudFront, you're activating it away from region or availability zone. So when you're activating a web application firewall, because it's not a region specific service, you're activating it away from availability zone and regions. So a quick recap: IAM users, groups, roles, and accounts, they are global services. They can be used globally. Route 53 services are offered at edge locations and they are global as well. Web application firewall, a service that protects our web application from common web exploits. They are global service as well. CloudFront is Global Content Delivery Network, CDN, and they are offered at edge locations, which are a global service. In other words, non-region specific service or beyond region service. All right, this is another good question as well. In the project that you are being interviewed, if they really want to secure their environment using NAT, or if they are already securing their environment using NAT by any of these two methods like NAT gateway or NAT instances, you can expect this question. What are the difference between a NAT gateway and NAT instances? Now, they both serve the same thing, right? So they're not two different services trying to achieve two different things. They both serve the same thing, but still they do have differences in them, right? On a high level, they both achieve providing NATing for the service behind it, but the difference comes when we talk about the availability of it. NAT gateway is a managed service by Amazon, whereas NAT instance is managed by us. Now I'm talking about the third point, maintenance here. NAT gateway is managed by Amazon, NAT instance is managed by us, and availability of NAT gateway is very high and availability of NAT instance is less compared to the NAT gateway because it's managed by us. It's on an EC2 instance which could actually fail, and if it fails we'll have to relaunch it. But if it is NAT gateway, if something happens to that service, Amazon would take care of reprovisioning it. And talking about bandwidth, it can burst up to 75 gigabits. Traffic through the NAT gateway can burst up to 75 gigabits. But for NAT instance, it actually depends on the server that we launch. And if we are launching a T2 micro, it barely gets any bandwidth. So there's a difference there. And the performance, because it's highly available because of the bigger pipe, 75 gigabits, the performance of the NAT gateway is very high, but the performance of the NAT instance is going to be average. Again, it depends on the size of the NAT instance that we pick. And billing. Billing for NAT gateway is the number of gateways that we provision and the duration for which we use the NAT gateway. But billing for NAT instance is number of instance and the type of instance that we use. Of course, number of instance, duration, and the type of instance that we use. Security in NAT gateway cannot be assigned, meaning it already comes with full packed security. But a NAT instance, security is a bit customizable. I can go and change the security because it's a server managed by me or managed by us. I can always change the security. Well, allow this, don't allow this, stuff like that. Size and load of the NAT gateway is uniform, but the size and the load of the NAT instance changes as per a NAT gateway is a fixed product. But NAT instance can be small instance, can be a big instance, so the size and the load through it varies. Right. The other question you could get asked is, what are the difference between stopping and terminating an EC2 instance? Now you will be able to answer only if you have worked on environments where you have your instance stopped and where you have your instance terminated. If you have only used lab and are attending the interview, chances are that you're always lost when answering this question. It might look like both are the same. Well, stopping and terminating, both are the same. But there is a difference in it. So when you stop an instance, it actually performs a normal shutdown on the instance and it simply moves the instance to the stopped state. But when you actually terminate the instance is moved to the stop state. The EBS volumes that are attached to it are deleted and removed, and we'll never be able to recover them again. So that's a big difference between stopping and
terminating an instance. If you're thinking of using the instance again, along with the data in it, you should only be thinking of stopping the instance, but you should be terminating the instance only if you want to get rid of that instance forever. If you are being interviewed for an architect level position or a junior architect level position or even an cloud consultant level position or even in an engineering position, this is a very common question that get asked. What are the different types of EC2 instances based on their cost or based on how we pay them, right? They're all compute capacity. For example, the different types are on-demand instances, spot instances, and reserved instances. It kind of looks the same. They all provide the compute capacity. They all provide the same type of hardwares for us. But if you're looking at cost saving or optimizing cost in our environment, we got to be very careful about which one are we picking. Now we might think that, well, I'll go with on-demand instance because I pay on a per hour basis, which is cheap. I can use them anytime I want, and anytime I don't want, I can simply get rid of it by terminating it. You're right, but if the requirement is to use the service for 1 year, the requirement is to use the service for 3 years, then you'll be wasting a lot of money buying on-demand instances. You'll be wasting a lot of money paying on an hourly basis. Instead, we should be going for reserved instance, where we can reserve the capacity for the complete 1 year or complete 3 years and save huge amount in buying reserved instances. Alright, so on-demand is cheap to start with if you're only planning to use it for a short while, but if you're planning to run it for a long while, then we should be going for reserved instance. That is what is cost efficient. So spot instance is cheaper than on-demand instance. And there are different use cases for spot instance as well. So let's look at one after the other. The on-demand instance. The on-demand instance is purchased at a fixed rate per hour. This is very short term and irregular workloads. And for testing, for development, on-demand instance is a very good use case. We should be using on-demand for production. Spot instance. Spot instance allows users to purchase EC2 at a reduced price, and anytime we have more instances, we can always go and sell it in spot instances. I'm referring to anytime we have more reserved instances, we can always sell them in spot instance catalog. And the way we buy spot instance is we actually put a budget. This is how much I'm willing to pay. All right, would you be able to give service within this cost? So anytime the price comes down and meets the cost that we have put in, we'll be assigned an instance, and anytime the price shoots up, the instance will be taken away from us. But in case of on-demand instances, we have bought that instance for that particular hour and it stays with us. But with spot instances, it varies based on the price. If you meet the price, you get the instance. If you don't meet the price, it goes away to somebody else. And the spot instance availability is actually based on supply and demand in the market. There's no guarantee that you will get spot instance at all time. All right, so that's a caveat there you should be familiar with. That's a caveat there you should be aware when you are proposing somebody that we can go for spot instance and save money. It's not always going to be available. If you want your spot instance to be available to you, then we need to carefully watch the history of the price of the spot instance. Now, how much was it last month and how much is it this month? So how can I quote, or how much can I quote, stuff like that. So you got to look at those history before you propose somebody that, well, we're going to save money using spot instance. On the other hand, reserved instance provide cost savings for the company. We can opt for reserved instances for 1 year or 3 years. There are actually 3 types of reserved instances: light, medium, and heavy reserved instances. They are based on the amount that we would be paying. And cost benefit also depends with reserved instance. The cost benefit also depends based on, are we doing all upfront or no upfront or partial payment, then split the rest as monthly payments. So there are many purchase options available. But overall, if you're looking at using an application for the next 1 year and 3 years, you should not be going for on-demand instance. You should be going for reserved instance, and that's what gives you the cost benefit. And in an AWS interview, sometimes you might be asked, how you interact with the AWS environment. Are you using CLI? Are you using console? And depending on your answer, whether console or CLI, the panelists put a score. Okay, this person is CLI specific, this person is console specific, or this person has used AWS environment through the SDK, stuff like that. So this question tests whether you are a CLI person or a console person. And the question goes like this. How do you set up SSH agent forwarding so that you do not have to copy the key every time you log in? If you have used PuTTY, anytime if you want to log into an EC2 instance, you will have to put the IP and the port number. Along with that, you will have to map, or we will have to map the key in the PuTTY, and this has to be done every time. That's what we would have done in our lab environments, right? But in production environment, using the same key or mapping the same key again and again every time, it's actually an hassle. It's considered as a blocker. So you might want to cache it. You might want to permanently add it in your PuTTY session so you can immediately log in and start using it. So here in the place where you would actually map the private key, there's a quick button that actually fixes or that actually binds your SSH to your PuTTY instance. So we can enable SSH agent forwarding that will actually bind our key to the SSH, and next time when we try to log in, we don't have to always go through mapping the key and trying to log in. Alright, this question, what are Solaris and AX operating systems? Are they available with AWS? That question generally gets asked to test how familiar are you with the AMIs available? How familiar are you with EC2? How familiar are you with the EC2 hardwares available? That basically tests that. Now the first question or the first thought that comes to your mind is, well, everything is available with AWS. I've seen Windows, I've seen Ubuntu, I've seen Red Hat, I've seen Amazon AMIs, and if I don't see my operating system there, I can always go to Marketplace and try them. If I don't find a Marketplace, I can always go to Community and try them. So there are a lot of AMIs available, there are a lot of operating systems available. I will be able to find Solaris and AX, but that's not the case. Solaris and AX are not available with AWS. That's because Solaris uses a different, Solaris does not support the architecture, does not support public cloud currently. The same goes for AX as well. They run on Power CPU and not on Intel, and as of now, Amazon does not provide power machines. This should not be confused with HPC, which is high performance computing. Should not be confused with that. Now these are different hardwares, different CPU itself that the cloud providers they do not provide yet. Another question you could get asked in organizations that would want to automate their infrastructure using Amazon native services would be, how do you actually recover an EC2 instance or auto recover an EC2 instance when it fails? Well, we know that EC2 instances are considered as immutable, meaning irreparable. We don't spend time fixing bugs in an OS, stuff like that. Once an EC2 instance crashes, like it goes on a OS panic, or there are various reasons why it would fail. So we don't have to really worry about fixing it. We can always relaunch that instance and that would fix it. But what if it happens at 2 o'clock in the night? What if it happens during a weekend when nobody's in office looking or monitoring those instances? So you would want to automate that, not only on a weekend or during midnights, but it's general practice good to automate it. So you could face this question, how do you actually automate an EC2 instance once it fails? And the answer to that question is using CloudWatch, we can recover the instance. So as you see, there is an alarm threshold set in CloudWatch, and once the threshold is met, meaning if there is an error, if there is a failure, if the EC2 instance is not responding for a certain while, we can set an alarm. And once the alarm is met, let's say the CPU utilization stayed high for 5 minutes, right? It's not taking any new connections, or the instance is not pinging for 5 minutes, or in this case, it's 2 minutes. It's not pinging, so it's not going to respond connection. So in those cases, you would want to automatically recover that EC2 instance by rebooting the instance. All right, now look at this, the take this action section under the action. So there we have a bunch of options like recover this instance, meaning reboot the instance. So that's how we would recover. The other two options are beyond the scope of the question, but still you can go ahead and apply, just like I'm going to do it. So the other option is stop the instance. That's very useful when you want to stop instances that are having low utilizations. Nobody's using the system as of now. You don't want them to be running and wasting the cloud expenditure. So you can actually set an alarm that stops the EC2 instance that's having low utilization. So somebody was working in an instance and they left it without, or they forgot to shut down that instance, and it gets, they will only use it again the next day morning. So in between there could be like 12 hours that the system is running idle, nobody's using it, and you're paying for it. So you can identify such instances and actually stop them when the CPU utilization is low, meaning nobody is using it. The other one is to terminate. Let's say you want to give system to somebody temporarily and you don't want them to hand the system back to you, right? This is actually an idea. In other words, this is actually the scenario. So you hand over a system to somebody, and when they're done, they're done. We can actually terminate the system. So you could instruct the other person to terminate the system when they're done, and they could forget and the instance could be running forever. Or you can monitor the system after the specified time is over and you can terminate the system. Or best part, you can automate the system termination. So you assign a system to somebody and then turn on this CloudWatch action to terminate the instance when the CPU is low for like 2 hours, meaning they've already left, or CPU is low for 30 minutes, meaning they've already left, stuff like that. So that's possible. And if you're getting hired for an system side architect or even on the sysops side, you could face this question: what are the common and different types of AMI designs? There are a lot of AMI designs. The question is the common ones and the difference between them. So the common ones are the full back AMIs, and the other one is just enough OS AMI, JEOS AMI, and the other one is hybrid type AMIs. So let's look at the difference between them. The full backed AMI, just like the name says, it's fully baked. It's ready to use AMI. This is the simplest AMI to deploy. Can be a bit expensive, it can be a bit cumbersome because you'll have to do a lot of work beforehand. You could use the AMI, so a lot of planning, a lot of thought process will go into it, and the AMI is ready to use, right? You hand over the AMI to somebody and it's ready to use, or if you want to reuse the AMI, it's already ready for you to use. So that's full baked AMI. The other one is just enough operating system AMI. Just like the name says, it has as you can also see in the diagram or in the picture, it covers a part of the OS. All bootstraps are already packed properly, and the security monitoring, logging, and the other stuff are configured at the time of deployment or at the time you would be using it. So not much thought process will go in here. The only focus is on choosing the operating system and what goes, the operating system specific agents or bootstraps that goes into the operating system. That's all we worry about. The advantage of this is it's flexible, meaning you can choose to install additional softwares at the time of deploying, but that's going to require an additional expertise on the person who will be using the AMI. So that's another overhead there. But the advantage is that it's kind of flexible. I can change the configurations during the time of deployment. The other one is a hybrid AMI. Now the hybrid AMI actually falls in between the fully baked AMI and just enough operating system options. So these AMIs have some features of the baked type and some features of the just enough OS type. So as you see, the security monitoring, logging are packed in that AMI, and the runtime environments are installed during the time of a deployment. So this is where the strict company policies would go into the AMI. Company policies like you got to log this, you got to monitor this. These are the ports that generally gets open in all the systems, stuff like that. So they strictly go into the AMI and sits in an AMI format. And during deployment, you have the flexibility of choosing the different runtime and the application that sits in an EC2 instance. Another very famous question you would face in an interview is, how can you recover login to an EC2 instance to which you lost the key? Well, we know that if the key is lost, we can't recover it. There are some organizations that integrate their EC2 instances with an AD. That's different. All right, so you can go and reset the password in the AD and you will be able to log in with the new password. But here the specific tricky question is, you are using a key to log in, and how do you recover if you have lost the key? Generally, companies would have made a backup of the key so we can pick from the backup. But here the specific question is, we have lost the key, literally no backups on the key at all. So how can we log in? And we know that we can't log into the instance without the key present with us. So the steps to recover is that make the instance use another key and use
that key to log in. Once the key is lost, it's lost forever. We won't be able to recover it. You can't raise a ticket with Amazon. Not possible. They're not going to help. It's beyond the scope. So make the instance use another key. It's only the key that's the problem. You still have valid data in it. You got to recover the data. It's just the key that's having the problem. So we can actually focus on the key part alone and change the key, and that will allow us to log in. So how do we do it? Step-by-step procedure. So first, verify the EC2 config service is running in that instance. If you want, you can actually beforehand install the EC2 config in that service, or you can actually make the EC2 config run through the console. Just a couple of button clicks and that'll make the EC2 config run in that EC2 instance, and then detach the root volume for that instance. Of course, it's going to require a stop and start. So detach the root volume from the instance, attach the root volume to another instance as a temporary volume, or it could be a temporary instance that you've launched only to fix this issue, and then log in to that instance and to that particular volume and modify the configuration file. Modify it to use the new key, and then move the root volume back to its original position and restart the instance. And now the instance is going to have the new key, and you also have the new key with which you can log in. So that's how we go ahead and fix it. Now let's move on to some product specific or S3 product specific questions. A general perception is S3 and EBS can be used interchangeably, and the interviewer would want to test your knowledge on S3 and EBS. Well, EBS uses S3, that's true, but they can't be interchangeably used. So you might face this question: what are some key differences between AWS S3 and EBS? Well, the differences are: S3 is an object store, meaning you can't install anything in it. You can store drive files, but you can't actually install in it. It's not a file system. But EBS is a file system. You can install services, install applications in it, and that's going to run stuff like that. And talking about performance, S3 is much faster and EBS is super faster when accessing from the instance, because from the instance, if you need to access S3, you'll actually have to go out through the internet and access the S3, or S3 is an external service, a very external service. You'll have to go through, or you'll have to go outside of your VPC to access S3. S3 does not come under a VPC, but EBS comes under a VPC. It's on the same VPC, so you would be able to use it kind of locally. Compared to S3, EBS is very local, so that way it's going to be faster. And redundancy, talking about redundancy of S3 and EBS. S3 is replicated. The data in S3 is replicated across the data centers, but EBS is replicated within the data center, meaning S3 is replicated across availability zones. EBS is within an availability zone. So that way redundancy is a bit less in EBS. In other words, redundancy is higher in S3 than EBS. And talking about security of S3, S3 can be made private as well as public, meaning anybody can access S3 from anywhere in the internet. That's possible with S3. But EBS can only be accessed when attached to an EC2 instance. Right? Just one instance can access it, whereas S3 is publicly directly accessible. The other question related to S3 security is: how do you allow access to a user to a certain bucket, which means this user is not having access to S3 at all, but this user needs to be given access to a certain bucket. How do we do it? The same case applies to servers as well. In few cases, there could be an instance where a person is new to the team and you actually don't want them to access the production service. Now he is in the production group, and by default he or she is granted access to that server, but you specifically want to deny access to that production server till the time he or she is matured enough to access or understand the process, understand the do's and don'ts before they can put their hands on the production server. So how do we go about doing it? So first we would categorize our instances. Well, these are critical instances. These are normal instances. And we would actually put a tag on them. That's how we categorize. Right? So you put a tag on them. Put a tag saying, well, they are highly critical, they are medium critical, and they are not critical at all. Still they're in production, stuff like that. And then you would pick the users who wants to, or who should be or should not be given access to a certain server, and you would actually allow the user to access or not access servers based on a specific tag. In other words, you can use actually tags. In the previous step, we put tags on the critical server, right? So you would define that this user is not going to use this tag. All right, this user is not allowed to use the resources with this tag. So that's how you would make your step forward. So you would allow or deny based on the tags that you have put. So in this case, he or she will not be allowed to servers which are tag critical servers. So that's how you allow deny access to them. And the same goes for bucket as well. But if an organization is excessively using S3 for their data storage because of the benefit that it provides, the cost and the durability, you might get asked this question, which is organizations would replicate the data from one region to another region for additional data durability and for having data redundancy. Not only for that, they would also do that for DR purposes, for disaster recovery. If the whole region is down, you still have the data available somewhere else and you can pick and use it. Some organizations would store data in different regions for compliance reasons, to provide low latency access to their users who are local to that region, stuff like that. So when companies do replication, how do you make sure that there is consistency in the replication? How do you make sure that the replication is not failing and the data gets transferred for sure and there are logs for that replication? This is something that the companies would use where they're excessively using S3 and they're fully relying on the replication in running their business. And the way we could do it is we can set up a replication monitor. It's actually a set of tools that we could use together to make sure that the cloud replication, region level replication, is happening properly. So this is how it happens. Now on this side, on the left hand side, we have the region 1, and on the right hand side we have region 2, and region 1 is the source bucket and region 2 is the destination bucket. Alright, so object is put in the source bucket and it has to go directly to the region 2 bucket, or made a copy in the region 2 bucket. And the problem is sometimes it fails and there is no consistency between them. So the way you would do it is connect these services together and create an cross-replication or cross-region replication monitor that actually monitors your environment. So there are CloudWatch that make sure that the data is moved, no data is failing. Again, there's CloudWatch on the other end, make sure that the data is moving. And then we have the logs generated through CloudTrail, and that's actually written in DynamoDB. And if there is an error, if something is failing, you get notified through an SMS or you get notified through an email using the SNS service. So that's how we could leverage these tools and set up an cross-region replication monitor that actually monitors your data replication. Some common issues that companies face in VPC is that we all know that I can use Route 53 to resolve an IP address externally from the internet, but by default the servers won't connect to the other servers using our custom DNS name. That it does not do that by default. So it's actually a problem. There are some additional things that as an administrator or as an architect or as a person who uses it, you will have to do. And that's what we're going to discuss. So the question could be, VPC is not resolving the server through the DNS. You can access it through the IP, but not through the DNS name. And what could be the issue and how do you go about fixing it? And you will be able to answer this question only if you have done it already. It's a quick and simple step. By default, VPC does not allow, that's the default feature. And we will have to enable the DNS hostname resolution before. Now this is for the custom DNS, not for the default DNS that comes along. This is for the custom DNS. So we will have to enable the DNS hostname resolution. So we'll have to enable the DNS hostname resolution so they actually resolve. Let's say I want to connect to server1.simplylearn.com. By default, it's not allowed. But if I enable this option, then I will be able to connect to server1.simplylearn.com. If a company has VPCs in different regions and they have a head office in a central place and the rest of them are branch offices and they are connecting to the head office for access or for saving data or for accessing certain files or certain data or storing data, all right, so they would actually mimic the hub and spoke topology where you have the VPC which is centrally in an accessible region, a centrally accessible region, and then you would have a local VPCs or branch offices in different other regions, and they get connected to the VPC in the central location. And the question is, how do you actually connect the multiple sites to a VPC and make communication happen between them? By default, it does not do that. We know that VPCs, they need to be peered between them in order to access the resources. Let's look at this picture, right? So I have like a customer network or branch offices in different parts, and they get connected to a VPC. That's fine. So what we have achieved is those different offices, the remote offices, they are connecting to the VPC and they're talking, but they can't connect or they can't talk to each other. That's what we have built. But the requirement is the traffic needs to, or they should be able to talk to each other, but they should not have a direct connection between them, which means that they will have to come and hit the VPC and then reach the other customer network, which is in Los Angeles or which is in New York. Right? That's the requirement. So that's possible with some architecting in the cloud. So that's using VPN Cloud Hub. You look at these dotted lines, which actually allows customers, or which actually allows the corporate networks to talk to each other through the VPC. Again, by default, it doesn't happen. Cloud Hub is an architecture that we should be using to make this happen. And what's the advantage of it? As a central office or as the headquarters office, which is in the VPC, or headquarters data center, which is in the VPC, you have control, or the VPC has control on who talks to who, and what traffic can talk to, what traffic can be routed to the other head office, stuff like that. That centralized control is on the VPC. The other question you could get asked is, name and explain some security products and features available in VPC. Well, VPC itself is an security service. It provides a security service to the application, but how do you actually secure the VPC itself? That's the question. And yes, there are products that can actually secure the VPC, or the VPC delivers those products to secure the application. Access to the VPC is restricted through a network access control list. Right? So that's an security product in VPC. And a VPC has security groups that protects the instances from unwanted inbound and outbound traffic, and network access control list protects the subnets from unwanted inbound and outbound access. And there are flow logs we can capture in VPC that captures incoming and outgoing traffic through a VPC, which will be used for later analysis, as in what's the traffic pattern, what's the behavior of the traffic pattern, stuff like that. So there are some security products and features available in VPC. Now, how do you monitor VPC? VPC is a very important concept, very important service as well. Everything sits in a VPC. Most of the service sits in a VPC, except for Lambda and S3 and DynamoDB and a couple of other services. Most of them sit in a VPC for security reasons. So how do you monitor your VPC? How do you gain some visibility on your VPC? Well, we can gain visibility on our VPC using VPC flow log. That's the basic service. As you see, it actually captures what's allowed, what's not allowed, stuff like that. Which IP is allowed, which IP is not allowed, stuff like that. So we can gather it and we can use that for analysis. And the other one is CloudWatch and CloudWatch logs, the data transfers that happen. So this is who gets allowed and who does not get allowed. I mean, the flow logs is who is allowed and who's not allowed, that kind of detail. And CloudWatch gives information about the data transfer, how much data is getting transferred. We can actually pick unusual data transfers if there is a sudden hike in the graph. There's a sudden hike and something happens at 12 on a regular basis and you weren't expecting it. There's something suspicious. It could be valid backups. It could be malicious activity as well. So that's how you know, by looking at CloudWatch logs and CloudWatch dashboard.
And with that, we have come to end of this video on Cloud Computing Expert full course. I hope you found it useful and entertaining. Please ask any question about the topics covered in this video in the comments box below. Our experts will assist you in addressing your problems. Thank you for watching. Stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.